Welcome to
Chrome?
Dev.
Well, it's meh.
That wasn't so good, was it?
No, this is a conference, and I know it's early, but we got up so you can put in a little more effort. I know it's you in the room here, but there's also like at least 1 million people on the live stream.
Well, at least billion.
Billion people on the live stream, and this didn't make us look great.
No.
Yeah, come on, right? Okay. Join in if you know the words, okay? Soma, what's the word?
Summit.
See, he knows it, and he's an idiot. Don't give him sympathy, he feeds off that.
Give it the day, they'll give up on giving him sympathy.
Shall we from the top, try again?
Okay. You ready?
No, I'm not ready, hang on. Okay, I'm ready.
Okay. Welcome to
Clone?
Dev. Hey, well done. You have redeemed
nice.
yourselves.
That was nice.
As a cheesy, horrible start to a conference.
Yep.
This
Get
is
ready
the
for it.
start of 2 days of amazing talks about the web, Chrome, the platform. We're going to talk about how to build the next generation of web apps and all the new features that are coming your way.
Yes, but first thing first, we would like you all to remind that we do have a code of conduct for this event. So let's try to keep this event open and inclusive for learning for everybody. And if somebody's not making that happen, please find one of us or one of the staff wearing a t-shirt, or you can find the email address on the website to let us know, okay? And, this event has been going for like 7 years. You might be meeting old friends and, you get excited, but we all practice Pac-Man circle, okay?
So, what?
Pac-Man circle.
The Pac-Man circle.
Pac-Man.
Oh,
Are you making fun of my pronunciation?
No, I'm not. I just genuinely have no idea what you're talking about right now.
Right, so make a circle.
We have 4 people.
That's
circle
a
with 4
square.
people.
That's a square.
Okay?
Yeah.
Okay.
Chatty, friendly.
Okay, we're talking.
friendly.
Okay.
All right.
Pac-Man circle.
So you leave a gap for people to join in.
Meet new friends, okay?
Like shape of a Pac-Man.
Yeah.
Oh, I thought you meant people should just take pills until they start seeing ghosts.
I mean, that's not mutually exclusive.
Right, so we should be going.
Yeah.
Okay.
And that means our keynote, and that means inviting our very first speaker onto the stage. So would you give a huge welcome to Anil Sabharwal. Ladies and gentlemen, Anil.
The year was 1993. Now, I realize that some of you may not have even been born yet, but for me, it was the year that my parents first brought home our internet-capable computer, the Commodore Amiga 4000. Frogger never looked so good. Yeah, sure, WordPerfect was still on 19 3.5-inch floppy disks, but I had a 9600 baud modem for the first time. The possibilities were limitless. Now, I grew up in Canada, so like any self-respecting Canadian, I have a healthy obsession for hockey. And my team is the Edmonton Oilers. And if I'm honest with myself, my love for computers started because of hockey bulletin boards. Weeks after I got my first computer, I had a friend of mine who said to me, I have to download this so-called browser called Mosaic and visit this thing called a URL. Well, 22 seconds and 37 beautiful modem beeps later, it was everything I hoped it would be. I was on the web. I was hooked. I checked this website every single day before class. That's a big deal for me because I'm not a morning person. But every morning I would wake up and have a look at this website. And my friends and I, we would actually start exchanging notes in class with URLs on them that we had found the day before, which was a big deal because this is 1993, so there are no search engines. So finding a URL that actually worked and had interesting content was a pretty big deal. Now, about a month of this went on, and I thought to myself, I want to create my own site too. So I started researching stuff like FTP servers and domain registrars and hypertext markup language. But what I remember most was the first time that I viewed source. It was like being led into this open, secret club where I could see the HTML for this site, warts and all, and being invited in. Source code was where people knowingly allowed you to see and share all of this really interesting code that allowed you to accelerate your own work and share the expertise. So I did what most first-timers did. I copied the HTML into VI, I edited it to make it look like it was my own, and I pushed my changes live with which is linked back to the original site, of course. And my code, by the way, didn't look anything like this. This looks way too nice for 1993. I had a lot more table and break tags. Well, today, nearly 25 years later, we're all members of this amazing, vibrant, global, and growing community. Now, we all have our own story for how we first got started, but I bet for many of you it's not too dissimilar to mine. It was because you wanted to be part of this broader community. And that's why today we're all here, to take a moment to recognize and really celebrate the we in web. Because the web is so much more than any one company, any one product, or any one person. It's all of us. What started with Mosaic and Navigator in the 90s has grown to dozens of web browsers across the globe, each stretching and improving the end user experience in significant ways. Microsoft and IE actually jump-started the Ajax era with the XML HTTP request, bringing powerful interactive apps to the web. Apple and Safari ushered in the mobile web with key technologies like offline and geolocation. And of course, Mozilla and Firefox, who continue to shape the modern web from the initial Phoenix project to SVG and Canvas, and to their critical privacy and security work. Meanwhile, what started off as a small group of coders has now grown into a family of more than 17 million developers worldwide, and we're on track to more than double in the next decade. About 1,000 of us are here in San Francisco today, and tens of thousands more are watching on the live stream in meetups in places such as Amsterdam, Brazil, and Uganda. Hello, everyone. And of course, the fact that each of us can contribute to this amazing community and this web's future is what makes all of this so unique. When you consider our contributions together, they are staggering. There are now more than 1.5 billion active sites and web applications on the internet today. And they're serving more than 4.5 billion users all over the world. It is a tremendous responsibility and opportunity, and one that's only possible because of this incredible web platform that we have. Now, as a community, we're going to debate and we're going to even argue, but that is how we create something truly great. After all, the contributions to the web come from everywhere, with no single company or individual owning it, and that is very much working as intended. Celebrating the we in web is naming how we're better together because of this diversity, because we're all here to move the web platform forward. And events like CDS, with many different companies and developers represented, are really critical to reminding us of this fact. If you remember only one thing from this morning, please know that Chrome is here today and every day to show up as one small member of this much, much bigger community. And so with that in mind, we're here at CDS to highlight some of our recent contributions in 3 key areas. So today we're going to talk first about the platform itself. And as developers, we're highly motivated to address some of the web's key challenges. For example, diversity and reach of the web is core to what is great about the internet, but it's also one of the reasons why interoperability remains a top concern. This morning, John is going to share some of our efforts to improve interop, as well as key investments we're making in platform performance and discoverability. The second is developer experience, and Dion's going to share some of the recent work we've done on productivity, frameworks, and open source. And finally, the Chrome browser itself. Parisa is going to share some of our investments in a more helpful, inclusive experience for our users. But more importantly, more than all of that, I want to say thank you. Thank you for all of you for being here with us this morning and for spending 2 very important days with us as you continue and we continue to invest in this broader community. As I said, the web is so much more than one company, one product, or one person. and it's about how we come together to move the platform forward. We're really grateful for a chance to share with you today, and so let's go ahead and get started with Platform.
Thanks, Anil. The most exciting part about the web is that it enables frictionless virality. You can share any experience through a link or discover it through a search result and go right in with one tap. The web's billions of users and millions of sites have been around for a while, so where do we expect the next wave of growth to come to the web? It's estimated that most of the new internet users globally will be coming online in countries like India, Indonesia, Mexico, and Nigeria. Users in developing markets across access the internet through smartphones with constrained memory and storage. So it's critical that web applications are lightweight and have great performance. And in both developing and developed markets, teenagers and young adults are growing up with smartphones and frequently computing cross-device. These users have very high expectations around the overall web experience. So it's important for us to equip the web platform with powerful app capabilities and to ensure the experiences remain smooth, responsive, and easy to navigate. We see big brands recognizing this shift. With 65% of their first-time users landing on mobile web, Airbnb recently built their website into a progressive web app, delivering better performance and user experience. Seeing the results that they and many of our partners have achieved by investing in the web inspires us to keep pushing the web forward and to continue making it more powerful. With this in mind, here are the themes of our recent and future developments to the web platform. We want to power fully capable web applications, deliver to users instant and responsive web experiences, and make transactions between users and merchants and payment providers seamless and smooth. Let's dive into the first one. To ensure the web apps ecosystem continues to thrive, developers need the same capabilities as those found in native apps. This includes application installation, discovery, integrations, and multi-language support to fully achieve feature parity. Install is a foundational feature of a progressive web app, and Chrome has supported install on mobile since 2016. With the web, you can focus on building your app, and the browser takes care of the details of how it will work on the user's device. And over the past year, we've taken it a step further with the launch of progressive web app install for desktop directly from the browser. You can now install on Windows, Mac, Linux, and of course, Chrome OS. To take installation and discovery of web applications to where your users truly are, earlier this year, we launched Trusted Web Activities. Web content has been part of the Android ecosystem for a long time via WebView. Trusted Web Activities offers a high-performance, more secure, and user choice-preserving way to build apps that use the web stack. This is our recommended way to upload and distribute high-quality PWAs for play. Partners such as Myntra, the leading Indian e-commerce brand, have used Trusted Web Activities to target their users on lower-end devices and increase conversion rate for these users by over 115%. Other early adopters include Latin-based publisher Terra and Indian affordable hotels chain Oyo Rooms. Oyo will be joining us later today to share their story. We're particularly excited about the cross-browser support Trusted Web Activities is getting. Our friends at Mozilla have confirmed they're experimenting with TWA in their Firefox Preview Nightly browser, and Samsung has committed to ship their own Trusted Web Activity in the near future. In 2015, we enabled notifications through service workers to allow meaningful re-engagement for web apps. Over the past few years, we've added many features to notifications, including action images, buttons, and most recently, notification triggers that give developers the ability to schedule notifications even if your user's device is on airplane mode. With this last addition, we believe that notifications have achieved feature parity with their native app counterparts. And what's even more exciting is that Trusted Web Activities get all these benefits by default. We're committed to improving the signal-to-noise ratio of notifications, and we'll share more through our CDS Lightning Talk series. We want web developers to create the best app experiences, and we've been working thoughtfully to bring APIs that unlock OS-level capabilities. Contact Picker API allows your users to share contacts and limited details with a web app, as you can see here in Twitter's PWA. We're putting a lot of care into the design and implementation of this API to ensure users have full transparency control, and we're working closely with some of our early adopters to get this right. Desktop apps, especially those focused on productivity, have long wanted to come on the web. But a major blocker has been a lack of local file system support. So I'm happy to announce that we're bringing the very popular native file system API to Chrome. This will allow web apps to interact with files on their user's local device. Great for photo and video editors, IDEs, productivity tools, and more. You can see it in action here with apps like Corel's Gravit Designer. In addition to giving developers powerful OS capabilities and deeper integration, we want developers to be able to port over their applications with greater performance and reliability. WebAssembly allows you to bring your existing mobile or desktop applications and libraries to the web without needing to rewrite them in JavaScript. It uses a combination of low-level primitives and strong static typing to deliver predictable performance. With additional features like threads and SIMD, applications can make full use of modern multi-core processors. We're seeing many web apps, especially those focused on desktops or large screens, taking advantage of WebAssembly to bring their apps to the web. We're announcing that the first WebAssembly Summit will take place at the Google office in Mountain View on February 10th, 2020, to discuss upcoming features and share more examples. You can join this public group to learn more. Moving on to our second theme, let's talk about what we're doing to make web experiences instant, rich, and more responsive. We're moving the web towards fast, beautiful, jank-free navigation and animations, as well as great offline and low bandwidth experiences. At I/O this May, we announced that signed exchanges, services that load your content faster through privacy-preserving prefetch, were available in Chrome to all users. We also gave a preview of an experimental API called Portals, enabling you to dramatically improve the user experience of navigations across your site. Portals allow you to create seamless navigation experiences by pre-rendering content and optionally embedding it. Unlike iframes, Portals give you the ability to navigate users into this content, and all at lightning speed. Early Portals partners like Fandango built this fun new transition style for their users while navigating within their site. Notice how there's no load time and the page rotates to the right, a style you don't see on the web too often. We're pleased to announce that the Portals API is available behind a flag for you to experiment with, and will soon be available in Origin trial for same Origin use cases. We are excited to get your feedback. With Portals, you can build amazing user experiences, but getting users to discover and try these new experiences can be challenging, especially on mobile. So we've been working on a collection of APIs and browser features designed to improve the discoverability of the web. Imagine you're building an app that periodically has new content, and you want to deliver this content even when the browser isn't open. For example, you could deliver that content while the user is connected to home Wi-Fi before they go for their commute, which might not have great connectivity. This is why we've been working on an API called Periodic Background Sync. This API can proactively cache content at regular intervals, making the content instantly available for the user. And to help users find the best content, whether online or offline, we've built the Content Indexing API. It allows you to make your offline-enabled and instantly available content visible to the user. And we're exploring showing some of this content on the new tab page and other surfaces in Chrome. Now, these readily available pieces of content are quite handy for discovery. But what if you want to make web loading disappear? Supporting completely offline users. What if you wanted your content or app to be flexibly distributed, including shared virally between users? A web bundle is a new platform primitive for packaging up a website or web app. It's blazingly fast to load, unlocks easier offline support, and is highly shareable. Developers can use these self-contained web bundles to solve a flaky connection issue for users. And a web bundle can change content distribution entirely. A bundle can be shared between devices over chat or email, on blogs alongside a review, or even on physical storage like a USB stick. In fact, we've bundled the web.dev website as well as Squoosh, an image optimization web app that we demoed at CDS last year, on a dino-shaped USB flash drive that you have in your swag bag. And we would love your feedback. Our Dino wanted a gaming friend, so we also threw in Prox, the Minesweeper-inspired web game that we launched at I/O earlier this year. Form controls have long been the bane of developers' lives, to the point where many build their own versions of controls that are already in the browser. We've worked with our friends at Microsoft to reskin and improve the accessibility of all form elements, and we're excited that these will be shipping soon in both Edge and Chrome. We're also continuing to land features that you need to improve the look and feel of your sites. Earlier this year, we launched Backdrop Filter, so developers can build new visual effects without having to hard-code images. And we're continuing our investments in Houdini, where you can now use the Register Property API to animate CSS variables that were previously impossible to animate. We've been working on making rendering and layout performance faster. Earlier this year, we landed the first phase of Layout NG in Chrome. Layout NG is a new implementation of Chrome's layout algorithm that promises much greater performance and reliability. It's optimized for modern, dynamic content and the wide variety of text languages now on the web. And most importantly, improves the speed of rendering emojis. Semicolon, close parenthesis. Display locking is a new API that can have a massive impact on rendering performance on the web. By locking an area of the DOM and stopping it from rendering, users can experience a much higher frame rate when scrolling through long documents. When a locked DOM isn't rendered, it is still searchable, which is great for accessibility, in-page search, and infinite scrollers. And the best part is, with display locking, you can now perform batch rendering updates. Moving on to our third theme, let's talk about seamless and smooth transactions on the web. One of the biggest opportunities we have to increase web developer success is to improve their overall transaction volume. We're reducing the friction between merchants and their users, making it easier for users to let us know who they are, to authenticate their identity securely, and to complete their purchases by assisting with payment handling and fraud prevention. WebAuthn allows hardware-secured second-factor authentication using biometrics like fingerprints or hardware keys like the YubiKey. WebAuthn continues to see great growth. Businesses like GitHub and many more sites, including Google itself, have integrated it into their authentication flows to vastly improve security for their users. We've also heard that many companies all over the world need a way to validate the user's phone number, especially in countries like India, where not all users have email. So we're pleased to announce this SMS Receiver API. This API allows you to verify a phone number automatically and with less user abandonment using the SMS verification codes that users input manually today. It's great to see early partners like India's food delivery service, Swiggy, implement it into their PWA. We're working on making payment on the web simpler and safer. 3 years ago, we launched the Payment Request API. We're now seeing great adoption, with over 15,000 origins using web payments to complete a transaction in Chrome. Even better, Web Payment API transaction volume has doubled since the beginning of the year. Our focus for the next year is to add more capabilities to Web Payments API and enable more sites and native apps to be able to process payments. The web's success relies on the principle of open source, transparency, collaboration, and most importantly, community. We launched Chromium as an open source project with the vision to allow everyone to contribute and anyone to share our foundations. And today, we're happy to see that almost every individual browser project is open source. We believe that working successfully with other browser vendors can unlock significant innovations on the web. Working with Firefox, Chrome was able to implement a difficult-to-ship feature, stale while revalidate, that, based on experimental data, has lifted publisher revenue by 0.5%, thanks to a 2% increase in early ad script loads and a resulting 0.3% ad impression increase. We're also excited to see the amazing contributions from our friends at Edge, who we recently welcomed to the Chromium ecosystem. They are already making major improvements to accessibility, scrolling, and media battery life. We want to continue working with our partners and browsers and ecosystem partners to bring many more wins for our developers and users. And to speak more about what we're doing to unlock developer success, let me invite Dion to the stage.
Thanks, John. I considered rebranding myself to Caps Lock Dion today, but probably shouldn't do that. Little cheap, I know. So, as we've heard, we think the open web is pretty special. John mentioned the low friction of links and how they get you immediately into an experience. And when someone browses from my site to your site, they feel the web as one. So how does the web feel in 2019? We use the HTTP archive to see how the web is built, and the Chrome User Experience Report, or CRUX, to see how it's experienced. And the story feels promising. Over the past year, we've seen positive growth in the percentage of sites with fast first contentful paint and first input delay, our core metrics for loading and interactivity. Now, it's great that the web at large is improving, but we also know there's a little bit of work to be done. And do you know how your sites are doing? One simple way to find out is just to enter a URL into PageSpeed Insights to get actionable recommendations for a single page. Now, if you need help identifying hotspots or potential problems across your site, good news, we just released a new speed report in the Search Console, which will give you insights by showing groups of pages and how they perform for each key metric as captured by CRUX. Now, we know that measuring user experience quality is multifaceted, and we're always working to integrate metrics to tell a fuller picture. This week, you'll hear us talking about some new metrics. For example, LCP, or largest contentful paint, measures how quickly users see the largest and often most meaningful content on a page, like a hero image or main text. LCP is built on top of the Element Timing API, which allows you to manually annotate elements that you care about. Now, we've all experienced this moment when a paint changes just when you tap. It's always incredibly frustrating. Happens to me probably again this Black Friday. So with CLS, or Cumulative Layout Shift, it measures the degree to which content may be shifting on the screen. This metric is built on top of the Layout Stability API, which enables you to identify and fix such issues. So each of these new metrics are backed with specs and web platform tests, allowing RUM providers to collect them. And we're really happy to see key ecosystem players such as Calibre and SpeedCurve integrating these metrics into their products. Now, we spend a lot of time diving into data from the HTTP archive and CRUX as it gives us insights on where to focus our platform efforts. This real-world data we think is really critical, which is why we ensure that it's fully available to you and the entire community. Now, it's also kind of fun to poke around in the data a little bit. For example, hypothetically speaking, maybe you're up late at night before giving a talk in a keynote, trying to think about things, and you find yourself wondering, like, what is the largest z-index value on the web? So you take a look at HTTP archive, and what do you think? Any guesses? 10? Maybe higher? Anyone? 1,000? 1,000,000? Would you be shocked at 780 digits? That's more than a Google of digits. That's a lot of digits. And so I just got thinking about how, like, there's some poor web developer and they're shouting at the screen, "Div, I need you on top." And then I had to, you got to take a look at the actual code, right? This is the actual code, and I love the important at the end, the exclamation important, make sure, and the comment at the top. Fixed, done, we're all done. It's fantastic. Love the web. So data is great, but insights lead to fixes and improvement. We're often asked, how do I actually act on this information? So we collaborated with experts from across the community to build what we're calling the Web Almanac. We're launching the first 17 chapters today on topics from markup to HTTP to PWA and many more. Now, I want to give a big shout out because there's tons of collaborators from across the industry, and I want to thank them for not only the amazing work they did on this project, but all they do for the web in general. So can we give a round of applause for the collaborators? Thank you. So many of you also go the extra mile to move the metrics in the right direction. And we want to reward you for the hard work that results in great web experiences. So we've been looking at how can we highlight and surface more quality signals to our users across search and Chrome's UI with speed as a core metric. So we've been playing around with UI explorations like this to make sure that we give you even more of an incentive to work on perf. We're going to be excited about this. So next up, we want to talk more about the ecosystem and the tooling that's going to help you create this great web content. I think it's pretty safe to say that no other platform has quite the same level of innovation in user space through frameworks, libraries, and CMSs, many of which have become household names. Adam Bradley from Ionic recently asked for feedback on the history of web frameworks, which sparked a typical healthy discussion on Twitter and a trip down memory lane. And we love how each framework innovates and learns from each other. We've been excited to see the innovation continue across the board, especially in the area of performance and developer experience. So this is very much true for Next.js, an impressive framework that gives React developers an end-to-end system to allow for scalable performance. We've been working with the Next.js team and thought it'd be fun to invite Guillermo Roche from Zai on stage to take us through the journey so far. Let's welcome Guillermo.
At Zeit, we have a very simple mission. We want to empower developers like you to build, deploy, and scale the best websites and applications. About 3 years ago, we identified an opportunity to foster this mission in the React space. We identified that creating a React website or application was very tedious. It required bringing all these different components together every time for every single project. But we had a very unique idea. What if it just took one command to start developing a React app, one command to build it, and your interface to the project was a very simple file system-based API, where you just create a folder and put a bunch of React components in there and get everything figured out for you. And I'm happy to report that that same idea that we had 3 years ago is still true today. So we kept that simplicity with a remarkable attention to backwards compatibility. This project, Next.js, has always been about that. We wanted to capture the spectrum of complexity and evolution of your projects. We thought that you needed to have an easy way to start, but then an easy way to evolve your project. That it should be good for an individual, but it should also be great for a team. And as well as capturing the complexities and intricacies of React rendering technologies, like going from static site generation to advanced server rendering. We've done this so well that every time you go on your favorite websites today, you're probably interfacing with Next.js. Sometimes it's in a small way, sometimes in a big way. We have customers that span from media to SaaS to maybe your favorite streaming service for music or video. If it's a static app or if it's something very complex, Next.js has found its place in a variety of different industries and use cases. And this has been possible, as Anil was saying, because we took this approach, which is the approach of the open web. We have an internal team that has seen a lot of amazing stewards of this project propel Next.js forward, but we've also included hundreds of contributors from the open source community and incredible partners, like companies like GoDaddy and Hulu that bet massively on Next.js, but then also decided to give back. If you're curious about how they're using our framework, I encourage you to check out the Hulu case study on our website. But my favorite partner is a very special and prolific partner. They're very, very productive people. So Google Chrome reached out to us earlier this year with an intention to make the web better. And they shared our key view that great developer experience has to marry great performance. And they know this better than anyone because they built the Web Inspector. But it's very, very important that just like Next.js goes from small to big, it has to be easy to use, and it has to be very fast for the end user. So we've been really busy working on a different set of features for improving Next.js. Some of them have to do with developer experience, like an easier way to import CSS into your React project. Some of them have to do with staying close to the cutting edge of the latest and greatest React features, like adding support for concurrent and strict mode. And some of them have to do with just bundling and compiling your projects better. So I'm really excited about these changes, in particular because earlier I was talking about great support for backwards compatibility. So some of the changes the Google Chrome team has helped us land, such as improved web bundling, have helped people in the real world. So one of our favorite customers, Barnaby's, they run an incredible search engine for arts and collectibles. And being in the e-commerce space, performance is of the essence. After they upgraded Next.js with zero code changes, thanks to the contributions that Chrome made, they saw a nearly 25 to 30% improvement in bundling, in size of the bundles of the main application, but that also translated into just a snappier and smoother experience that helped everyone that visited their website. This was possible thanks to those amazing contributions. If you want to learn more about what specifically went into making these improvements, please check out our session tomorrow at around 11 a.m., led by Hussein and Tim Nutkins, who are going to talk about all the internals of what it went into making and landing these improvements. Finally, if you're interested about Next.js and want to check it out, please go to nextjs.org/learn, where a 5-minute tutorial will just guide you through all the essentials, and you'll be productive building React applications in no time. Thank you.
Thank you, Guillermo. That's awesome. So we want to support as many ecosystem players to unlock performance wins by default and so much more. We announced the Framework Fund at the last Chrome Dev Summit. We've been really excited to see the impact that these projects are having, and we're really keen to fund more. Now, you live in content creation and app development tools all day. And the breadth of the tools that the web has are pretty phenomenal, from no-code to low-code to pro-code, whatever those mean. And of course, for Anil, Vim. Yes, any Emacs? Anyway, no, we're not going to go there. We want these tools to thrive and for them to get access to everything they need from the web platform and our data and insight tools. We also want to ensure that our tools are doing everything they can to help you. First, the metrics that I mentioned will now be reflected across our tools, including Lighthouse and Chrome DevTools. And to help you understand these metrics, we're adding clear guidance on web.dev, our primary developer website, which expanded today with great content. Now, in Lighthouse, we recently announced our very first stack pack. This one was for WordPress, and allowed us to extend the general guidance to include actionable WordPress advice. Today, we're releasing a stack pack for the open source e-commerce platform Magento, as well as expanding our coverage to include packs for web frameworks such as Angular, React, and AMP. Now, content platforms are actually powering more than half of the web, and we've been working really closely with dozens of them, in some areas investing deeply. At WordCamp US, just 2 weeks ago, we announced the 1.0 release of SiteKit for WordPress, which helps content creators by making it easy to set up and access multiple Google tools directly in WordPress. Now, we've also been working with the WordPress community to improve site health and performance by simplifying HTTPS migrations, prototyping image lazy load, using font display swap to accelerate text rendering, and much more. And then there's Shopify. We've been really impressed with the performance work that they've been shipping for all of their merchants. One example of impact at scale is how they rolled out WebP support across their platform and saw a 60% decrease in bytes served. In one extreme case, they saw savings of over 210 megs on a single page, which made me wonder, what are the z-indexes on that page? So we're super excited to see our tools become more powerful, integrated, and open to the ecosystem. In fact, let me stop talking for a little bit, and instead, please join me in welcoming Elizabeth and Paul to show some of the new features we've landed across our tools and highlight how you can use them together to make web development easier. Thank you.
Thank you, Caps Lock Dion. I'm Elizabeth.
I'm Paul.
And we are really excited to work for Chrome Web Platform team and be with you here today. So we've been working really hard to make sure that you have a really consistent experience across all of our tools. And we wanted to take a moment to walk through from diagnosis to an actual solution, what that fix workflow looks like for performance. So we also want to practice what we preach.
Yep.
So we're going to be using one of our own sites to try to optimize it, web.dev, for this demo. All right, Paul, you good to go?
Let's do this.
Okay, awesome. So the first thing Paul is going to do is jump into the audits panel in DevTools, where you can run a Lighthouse report locally on your own machine. So he's just going to run the performance category for now, right?
Just performance.
OK, cool. So it should just be a few seconds. And I was told to dance here, but none of you want to see me dancing. This is all bad. OK, all right. Cool. So the performance score is OK, but we chose a page that we know we can improve. So let's see. There seem to be a few images that are a little bigger.
Yeah, OK. Yeah, a few images here. They're just oversized.
Which one do you want to tackle?
Let's just focus on Spa Kittens, I guess.
Definitely Spa Kittens.
Yeah, like it looks like it's 79K, and it could be quite a lot smaller. OK, that's Spa Kittens. Good, yeah. All right, let's go check it out. So it's down here. Good. Yes. Image tag. OK, yeah. 1,800 pixels wide image, but shown at just 527 wide. So way oversized. OK, we could fix this. And so I think probably like the fix that we're going to do, we'll just use like responsive images, source set kind of a thing. And I cheated a little bit. I do know that there's already a responsive image on this page, so we're going to like just make use of that. So what I'm going to do is I'm going to take just the file name of Spa Kittens, and then we're going to go find this other one. OK, here, yeah, you can see like the full source set. And we're just going to edit this attribute and just replace this. Kind of Command D, paste, boom. OK, yeah, there we go. All right, now. We're going to take the HTML of this, and we're going to go and copy it over into use my favorite feature in DevTools, local overrides. All right, so now we're going to go down, and we're going to find the original Spa Kittens image tag, and we'll just delete that, and then paste in the new one, and then hit Control S, and then we should refresh, and let's just verify that that actually applied to the page. Yes, OK, good, yeah.
So can we actually rerun Lighthouse to see if it fixed it, though?
Yeah, sure, yeah, OK. So let's take a look at Lighthouse. We'll go back up and rerun.
All right, come on, Spa Kittens.
Hey, Elizabeth, how do you get a tissue to dance? Put a little boogie in it.
The sad part is I knew the punchline.
All right. OK. Ooh,
All right,
yeah.
cool.
Much better.
Amazing.
Good.
So, OK.
And then
Thank
check
you.
it out.
All right.
It's not even there anymore.
It's not there. So I know you pretty well, and I'm going to guess that you already have a PR ready to go that'll fix this in source. Am I right?
Yes.
Yeah.
Got
Fabulous.
a PR. Let's see. Let's switch over. Yeah, PR for web.dev. Just sort it out.
Yeah, you're so good. OK, so we want to make sure that we validate that the change is actually good, though, and convince the entire team that this is actually going to be a sustainable fix. So with that, we want to take a moment to introduce Lighthouse CI. It runs Lighthouse automatically on every single commit, and we're super jazzed about it.
Yeah. This is rad stuff. All right, so.
And we've already added Lighthouse CI to the GitHub repo, right?
Yeah. So let me show that. So if we just scroll down, we can see we have the integration right there in the pull request.
Awesome. And this allows us to do a few cool new things. One of which is actually being able to see an overview. So you can see the performance of all of your pages over time for all of the report categories. This is an automated collection of all of your Lighthouse report categories on every commit. That's including the state of audits, as well as the values of your performance metrics.
Yep.
So one of the main things we want to do is actually compare the quality of our PR against master to see if we've done anything that causes regressions, before the change actually goes live and users have to deal with it. So there has to be a better way to do it, though,
And toggling
than just
back and forth.
toggling between two reports, right?
Yeah. So we focused a lot on this kind of experience. What actually made a change here? And so let me show you kind of how that works. So if we actually just go back to that pull request and we click through on the status check. So this is the new diff view for Lighthouse CI. Let's bump this up. So we see the 3-point difference in the performance score, and we see all the changes that happen to all the metrics. They're all going down, which is an improvement. We like that. Let's go check out properly sized images. Looks like we have a change there. Yeah, OK, cool. So yeah, I made them all responsive, and so they're removed from the report. We have the potential savings is all gone, so we fixed it. And check this out. Yeah, for all the images on the page, we've reduced the total weight of images by 0.5 meg. So this is pretty cool.
Yeah, that's amazing. So if you would like to learn more about Lighthouse CI as well as other speed tooling updates, please join us later for our talk. But until then, thank you very much.
Yeah, thanks, guys.
Thank you. Super excited about the tool. The Lighthouse score, not so excited about, by the way. So thanks. I'm so excited about how we're working to improve the web and make you successful, no matter what framework you use, what CMS you use. What I really hope is that you set bold quality goals and use our tools and services to understand the experience your users are getting, and then create the high-quality experiences that we all want to see as a link on our World Wide Web. Now, finally, I do have something that I'm a little bit embarrassed to admit, and that's, you see all these Chrome Dev Summit URLs? I'm really angry. They don't actually work. Like, you put them in the browser, and they don't work. But to be clear, Chrome loves URLs. I want to make that very clear. And to tell you more about Chrome, please welcome Parisa from the browser team.
Thank you, Caps Lock Dion. Cheerio, old chap. He's going to tell me how far or close I am to Downton Abbey afterwards. Hello, everyone. Hope you're enjoying Dev Summit. As Anil mentioned, when we think about the future of the web, we're considering 4.5 billion users. And this isn't just users who are coming online for the first time in emerging markets. It's also young users who are primarily using their phones. Now, in Chrome, we really, really believe that every existing user and future user deserves an amazing experience. And so I want to share just a couple of the ways that we're trying to deliver on that experience. A lot of our focus has been around 3 key goals. How do we make the web perform better? How do we make the web more accessible? And how do we make the web more safe and trustworthy? So let's talk about performance first. Now, we believe that the web is for everyone, no matter what your device, what your internet speed, or what your purchasing power. And that's why we invest in performance with consideration for just a huge range of devices. OK, when it comes to RAM, we have seen your memes. All of them. And we laugh with you, but we also work hard to not give you as much fodder. And for memory, it's a really delicate balance, because sometimes when you use more memory, it actually can lead to a faster user experience via caching. And it also makes possible additional security mitigations. But we obviously know if you use too much, it can actually impact the user experience. We have lots of people dedicated to figuring out just what is the optimal usage for Chrome, given a user's available CPU and memory resources. And we've been investing more here lately. One of the things that we've done is developed automated tooling so that we can find memory leaks or UI jank in the wild and get engineers enough information so they actually can debug and fix those issues. And after a lot of work, and via the help of this tooling, we've made a couple achievements that we're pretty proud of. So what we've seen in the past year is an 8x reduction in UI thread jank in the main browser process, And we've also seen a 15% CPU reduction and 50% reduction in physical memory for background tabs in the browser. Now, that's pretty good. Thank you. We're proud of this work, but we totally know it's an ongoing effort, and this is something we're going to continue to invest in. So that's the browser. When it comes to V8, we've also made a number of memory reductions here. For example, we reduced renderer in the memory footprint by about 5%, and we actually expect further reduction of about 12% via V8 pointer compression, which is literally rolling out right now. So more cool improvements, but people want to see to believe. And so you can see from this video, within V8, we've massively reduced parsing time. And so now Google Sheets loads way faster. This is a comparison of Chrome today versus Chrome a year ago. And again, if you're into stats, this is about 33% faster. So thanks to V8. And at I/O this year, we announced a couple of improvements that developers just get by default. And I wanted to just give an update on those. So the first one that we're excited to share relates to image lazy load. And this is now going to be enabled by default for all Chrome Light Mode users. Now, lazy load is when the browser prioritizes loading images or iframes in the current view. And so it'll actually defer loading elements outside of the view until the user scrolls to it. This means that all Chrome Light Mode users are going to get even more data savings, and they're going to get even faster content in view experience. And so that's great for default users in Light Mode. Developers can also just enable this by adding one line of text. And then second update, and something that's coming in a couple months, is launching paint holding. Now, paint holding is where the browser will wait very, very briefly before starting to paint, so the page renders as a whole rather than jumping different elements around. And it just avoids kind of what is a distracting kind of white splash. And so, again, just by default, giving users a better, more smooth experience. So performance is one big area of ongoing investment, but access to the web isn't just about performance. It's also about making content accessible. For example, users who are blind or low vision are often using a screen reader or braille display. And unfortunately, these users will typically hear image, unlabeled graphic, or long, irrelevant file name read aloud whenever they're on a page that has unlabeled images. And obviously, this can be a pretty frustrating experience. So this is something that we wanted to help those users with. Now, we used Google AI to automatically generate descriptions of images. So now, if users turn on the Get Image Descriptions from Google feature, Chrome is going to automatically generate descriptions of unlabeled images. And so just as an example, if a user came on this image, then they might actually hear, appears to be fruits and vegetables at a market. So as you all know, it is still best practice for developers to actually add their own alt text to images because you know the context of your content best. But this feature is really just intended to help bridge some of the existing gaps that we know are present in the web today. And our team has set a goal for ourselves to just really meet the highest level of accessibility standards. And we've made a lot of progress on this. And in general, are just thrilled to see users finding improvements helpful in Chrome. Just recently, Chrome was actually named one of the most used browsers among blind users. And this was according to a survey by the Web Accessibility in Mind group, and something that we're proud of, just given all the effort into making Chrome more accessible. And also have a lot more work to do here, but very much driven by the mission to make sure that we're building helpful features so that really technology can empower everybody. Of course, in order to be truly empowered by the web, it has to be safe and trustworthy, not just for Chrome users, but for everyone. And so I want to talk a little bit about some of the ways that we've been investing in doing that. Internet-wide safety absolutely demands industry-wide collaboration. And together, and really, I do mean from people in the room and people in the live stream, I'm proud to say that we've made some huge progress on HTTPS adoption. Today, 90 of the top 100 sites now default to HTTPS, and that's up from only about 25 back in 2016. From what we see, 90% of all web traffic at Google across popular operating systems, both desktop and mobile, is now over HTTPS. And that's just a huge accomplishment. So as a next step, Chrome is investing in continuing to improve the security of HTTPS, and we're going to begin blocking all mixed content or insecure HTTP content loaded on HTTPS pages by default. And since we're asking developers to do some work, as we always do, we know this takes some time, and we're going to be rolling this out over the next 4 milestones. We're also experimenting with new ways to make DNS more secure. So as you know, DNS is the addressing system of the internet and just a really essential piece of how the internet works. Unfortunately, it remains one of the last non-encrypted channels. And this potentially exposes users to privacy leaks or phishing attacks or pharming attacks. And a lot of members of the web community have tried to improve this over time, but just nothing has really taken off until more recently. Now, the latest proposal from the web community is called DNS over HTTPS. As a browser, this obviously plays to our strengths, but DNS has been around for 35 plus years, and so changing it is just a really complex endeavor. And it's one that we are being really deliberately conservative about. So we're only going to upgrade Chrome users to DNS over HTTPS if we already know that their DNS providers support it. And we think that this is the right approach to balance user choice and control while also delivering significant improvements that we see for security and privacy. Now, if there's one topic that takes over most of the browser safety and trust conversation lately, it's privacy, and in particular, cookies. So earlier this year at I/O, we made some announcements that we're committed to making controls for third-party cookies just more usable and more visible. And we've already kicked off some early experiments. You can check it out in Incognito, which is our mode that we know a lot of privacy-conscious users will turn to. And in parallel, we're continuing to just make progress on plans to improve the existing cookie infrastructure. We recently announced that Chrome is going to start enforcing accurate cookie classification beginning in February. And in particular, looking for developers to be able to specify whether their cookies are to be used in a first-party or third-party classification context. And this is just going to make cookies more secure and also make our tracking controls more accurate. Other browsers have announced that they're joining us in this effort. And then one more thing I want to talk about on privacy, but we're just continuing to innovate on our privacy sandbox. And what this is a secure environment for personalization, including ads, and it also protects user privacy. So since the August announcement, we've announced 2 intents to implement, click conversion measurement and trust token APIs. Check them out. We'd love your feedback, and you'll hear a little bit more about these in the next talk at 11. Of course, you can't have privacy without security, and our philosophy in Chrome is that you shouldn't have to be a security expert to stay safe online. And so as much as possible, we try to build security in by default. So since the beginning, we've built in protections to just warn users of potentially dangerous sites that may try to phish their credentials or install malware, and then also really invest in regularly updating users with the latest security updates or features. And so I want to talk about just 2 things we're proud of from this past year. Passwords. Everyone knows about passwords. Compromised passwords remain one of the biggest risks to users on the web. And that's why we continue to invest in our password manager. Today, not only can Chrome users safely store their passwords, but they can also generate unique, strong passwords for all sites on either desktop and mobile. And what we'll be bringing to you by the end of the year is actually a Chrome that will proactively warn you if we detect that any of your passwords have been compromised. And this way, as a user, you can actually just take additional protections to protect those online accounts, which may be at risk. And then finally, another accomplishment is just bringing site isolation to Android. So site isolation is like the next major advancement in browser sandboxing, and it protects users from speculative execution attacks. You may have heard of Spectre, which got a lot of headlines 2 years ago. And bringing this to Android was actually only possible because of a lot of the memory savings that we made that I described earlier in the talk. And so kudos to the teams that have made this possible. Overall, we feel a huge responsibility in Chrome to continue to bring helpful innovation to just make the web perform better, make it more accessible, and stay ahead of users' expectations when it comes to security and privacy. And I cannot underscore that this would not be possible without the support of the developer community and just everybody who's contributing to the ecosystem. So truly, thank you so much. With that, I'm going to call Anil back on stage just for some closing words.
Reflecting back on my own story, if I could take you back to 1993 for a second, there is no way that kid growing up in Montreal on that Commodore Amiga 4000 ever thought that he'd be standing here with all of you today. And that is what makes the web so great. As an open platform, it opens up possibilities for millions of developers and billions of people all over the world. If you see a need in your community, all you have to do is build something on the web immediately, and you can push it live with no friction and no one having to approve anything. It's available for everyone instantly. All you need to do is give them a link. And that's the power of the web. And together, we can continue to move it forward. In fact, a great example of this work that I'd love to highlight of building powerful, accessible web experiences is Zlato, a startup that's using virtual incentives to make real-world economic impact. As we close this morning's keynote, let's listen to their story.
Growing up on the Cape Flats, youth unemployment is a huge problem. So we introduced Zlato. Zlato is a rewards platform that incentivizes young people to volunteer in the community and gain work experience. Just think of it like points in order to purchase things that you need. The web is of fundamental importance. It allows our users to access Zlato from anywhere. We realize that people might not have data for their cell phones, but there will be a device that they can connect with. They can hop from their cell phone to the computer and just go out and use it. And that's what the web allows us to eliminate that barrier of connectivity. It's our responsibility to make sure that people are empowered. I feel confident that Zlato can be used in almost any context. Your struggle doesn't disappear because your device changed, so we need to meet users where they are. We're going to invest not just in the lives of young people, but in the beliefs of young people. And we're going to trust them to solve the problem that they want to solve.
We're actually honored to have Alan and his CTO, Kurt, in the audience here today. So thank you, Alan and Kurt. So that's it for this morning's keynote. So thank you for letting me, the Chrome team, and Google continue to be part of this really amazing community. Here's to the we in web, and I really hope you enjoy the rest of the summit. Thanks, guys.
Hello again.
Are we doing big web quiz again?
Well, yes, kind of, sort of, maybe it's complicated.
I like how everybody knows what the deal is.
We
and, like,
bought the
bringing
domain.
The phone out.
We bought the domain, so we thought we would make more use of it, right?
Yes, but we're doing something slightly different. So in previous years, we've used a Big Web Quiz to test your knowledge of esoteric parts of JavaScript, CSS, and HTML. A little bit different this time, because it's going to be us asking you the questions. Wait, that's the same. Paul, I'm explaining this really badly. Can you take over?
You are actually doing a pretty poor job. Right, so if in previous years we've asked kind of knowledge questions, this year we're going to ask your preferences.
Just have an opinion.
Yep, you should bring your phone up, access the bigwebquiz.com.
Okay, now, the thing is, we're going to start with the most important question of them all.
And this is just a test, because like every year that we've done this, we hastily build the app, and it goes wrong every time. So this is just a sort of warm-up question, right?
Yeah.
But it
just
matters.
test the system.
I mean, it matters. I don't want to pretend it doesn't matter. This matters.
So again, grab your phones, go to bigwebquiz.com, because...
Right, seriously.
Oh.
Now, say no. This is legally binding. It's not legally binding, unlike some things, I'm saying. Anyway, so this matters. Whatever we go for here.
You have to stop using the other.
Yes.
This is for everyone in the room. You have to... what we designed here...
Not just everyone in the room, everyone.
In the
If
world.
you're on the live stream, you're now committed
I like how Potti and Ashley are showing us that there's a problem. We'll get to it. Wait for it, okay?
Are we ready?
Yes.
Are we ready? Are you ready to cast your vote, because your time...
It's not a vote.
Is now.
It's not a vote.
There we go.
There's a correct answer.
Which is space.
Spaces.
This is so much closer than I thought it would be.
Yeah, this was not what I was expecting.
How are 46% of you wrong?
By the way, I'm saying it right now. If any of the numbers here are the same as the Brexit vote, we're having another referendum.
That's it.
Well, some problem. Oh, it doesn't work on Firefox.
We tested this.
Well, Firefox Dev Summit, is it?
We'll check it. We'll check it.
We'll check it later. So the good thing is, the time is up anyway, and this is just the warm-up round, isn't it?
Oh, yes!
We made it!
Oh, I'm so happy right now.
Everybody...
I was nervous for tabs there, or nervous for spaces, sorry. I mean, that was the correct answer.
You see, I disagree. I mean, so my preference isn't actually represented on the screen, because I think it's genuinely okay to mix both.
Monster.
No, I agree. I agree with Jake, because you use tabs for indentation and then spaces for alignment.
So it means you can adjust the width of the tab for your preference.
No.
It's nice and accessible. Are you saying you hate accessibility?
Okay.
Are you on record saying you hate accessibility?
No, I'm saying I'm not mixing tabs and spaces.
Right, let's move on. Let's move on.
Anyway, so that was obviously the one that mattered. But what we thought we'd do is we would take 16 of the web platform features that have landed in Chrome in the last year, and we'd put them into a sports bracket and get your opinion on them, okay?
So throughout the day, each one of us will champion a couple of these features, and to decide who of us gets to champion which of these features, we're using a technically very sophisticated method of a hat.
Yes.
So we have to pull one of these features out of the hat at random, and we have to champion it to you and take responsibility for it, if you will.
For the first round, it is Paul versus Mariko.
Right, can you hold this so that I can kick this?
I want a good one.
Constructible style sheet.
Oh, good fun. Okay. All right.
A good start.
Yep.
I feel like... Okay, this one. I have Intel stuff.
Intel stuff. Nice and
That
vague.
is the official name.
Excellent.
In the back pocket.
Now, going through some of these features, there were ones that I hadn't heard of or ones that I couldn't quite remember in detail. So we're not expecting you to know everything about them. In fact, we're going to ask our champions of this session to give you a little introduction to them, starting with Mariko.
Right, how do I present this? Okay, let's go. Right, so CSS. You can now make custom style sheets, a snippet of it like that. So now in the const sheet is a piece of CSS that is already parsed and ready to go. And then if you want to apply that CSS to multiple places on the website or web pages, then you just do like that. You put the adapted style sheets and update it. But it's not just one. You know, you might have used that style on the different places, so you can have that on the different Shadowroot 1, Shadowroot 2. The good thing about constructible style sheets is that the first two lines, when you made it, it's already parsed and ready to go. So when you apply to the other elements, you don't pay the cost of parsing it again. So it's quite good for performance. And that's it.
Fine. OK.
Over to you,
Let's
Paul.
be honest. This is the winning feature, all right? It's an international conference. Internationalization, it's a thing. Anytime anybody's ever tried to put something like, 5 minutes ago or anything, you turn to a library for that. No more. The platform has you covered. You basically use Intel, and it's got various things on it. You're going to get a 3-for-1 in here. Just saying. All right, we got the relative time format, so you can say, basically, this is going to happen in 3.14 seconds. Is that pi seconds? That's good. Also, you can say minutes, whatever, years, and it will put it together for you, and that's fine. But then when you go to another language and you say, I want this in, say, Spanish, you get this, which I can't pronounce. Then you've got this for list formats. For example, we could say Paul and Jake, and by default, it's going to be a conjunction of the items in the list. For example, we have the same thing, a disjunction, where it's A or B, and it does all this for you. You don't have to do the thinking. And it gets this is in German. What would that be in German?
Sommer oder Bariko.
Perfect.
There's exactly one German word in there, just saying.
Yeah, but it was
Well, summer.
But it was, no, yes. And it was the way you said it. It just sounds so good. And then, of course, there's number formatting as well. So this is 2,000 seconds, or in German?
2000 Sekunden.
Perfect. You see how easy that is?
This is all I contribute to this team.
You don't have to do any of this. It does it all.
All right, your time is up, mate.
All right, fine.
It is time to get out your phones again. I know some people can't participate, but we will fix this in the break, as every year, when we find something.
Yep.
Because it is time to decide constructible style sheets versus Intel stuff.
Remember, CSS, really important for the website.
Are you ready?
Great. Intel, you
Go.
might use it on your site.
Internationalization. Yes.
Oh.
CSS!
Oh, boy.
Don't you write CSS? What is this?
I just put my CSS in my JS, really.
Oh!
Brilliant. I mean, are we going to really draw this out? Because I
This
think we've got our
is so
answer.
not fair.
I think we have found a winner.
Yes. Thank you.
Also,
Thank you. It means
not fair,
it means
not
more
fair.
than you know.
Okay, so that means that Intel stuff is going to go through to the next round, and we're going to whittle down all of these features, and then we'll find out an eventual winner at the end of the day.
Yep.
But like what we just saw happening over here was kind of like our jobs, explaining like features to an audience. So not only are we going to reward the feature, we're going to give Paul a point as well.
Yes.
Yeah.
Not fair. CSS is important.
I think I deserve one, but apparently we're not doing that.
There you go.
Okay.
So we're going to hear more about these points later on, right?
Shall we get back to session now?
Yes, we should. We should.
Right, so we're gonna start today with security topic, very exciting. Please welcome to the stage, Emily.
Hello, good morning. My name is Emily Stark. I'm a software engineer on the Chrome security team. And today, my colleague Michael Kleber and I are going to be telling you about what Chrome is doing to help people make safe decisions about what data they share with websites. If you're a web user in 2019, and I think most of you probably are, you've probably had some pretty mystifying experiences. You've probably had an experience where you're reading a news article on your work desktop computer when you stumble upon an ad for the exact pair of shoes that you searched for on your personal phone a week ago. No matter how many times you've seen ad experiences like this, it still probably throws you for a loop. How did this one website on one device know your search history on another device at a completely different time? And what else might it know about you? Or maybe you got an email, another mystifying experience, from your bank telling you to log in to verify a fraudulent charge or to unfreeze your account. And the email looks legit, the link looks legit, but how do you know? How are you really supposed to tell? And maybe even more importantly, how is a non-technical user supposed to tell? The fact is, it's not always easy to tell where you are on the web or what websites are observing about you. Chrome's goal is to help people with both of these problems. We want to help users make safe decisions while staying in control of their personal data. And we want to do this while preserving a thriving web ecosystem where content creators can make money through ads without invading users' privacy. We'll start by talking about what Chrome is doing to help people understand where they are on the web. What's the identity of the website that they're visiting? And particularly, is the site being misleading about its identity? As developers, this may be a problem that your users struggle with, or maybe even something that you sometimes struggle with yourself. Because even as expert users, even for myself as a person who works on a browser security team, it's not always obvious when a site is being misleading about its identity. In theory, the URL bar that's shown at the top of a web browser is your unambiguous clue to website identity. If the URL bar says google.com, you're at the real Google. And if it says evil.com, you're not, no matter how much the web content area looks like Google. But in practice, it's not always so easy to tell site identity from a domain, as you can see here with these examples. Some of these URLs might be hard for even expert users to notice and distinguish from google.com, much less non-technical users. And this isn't speculation. There's lots of research, lab studies, surveys, field experiments, showing that many users don't notice or understand URLs when they need to in order to make effective security decisions. In a study that we did with over 1,000 participants, we showed users a browser window where the website looked like a Google login page, but the address bar said tinyurl.com. When asked to identify this website, over 85% of participants said the website was Google, even though the address bar clearly said tinyurl.com. This presents a really hard problem. Lots of people use URLs for lots of really useful things. But there are also lots of ways that URLs can be used to trick or harm people. So what can we do about it? We're approaching this problem from a few angles. First, we're actively combating sophisticated spoofing techniques that abuse URLs to create unusually deceptive attacks. Second, we're trying to draw people's attention to the information in URLs that's most relevant for making security decisions. And finally, we're building specialized tools to support expert use cases so that we can help make URLs better security tools without interfering with experts' workflows. We've found that sites can be particularly misleading about their identity when they abuse internationalized domain names, or IDNs. These spoofing sites use non-ASCII characters in the domain to look remarkably similar to a legitimate domain. Suppose you were looking at example.com, as written here. You could do a very careful character-by-character comparison, and you would probably conclude very confidently that you're at the real example.com. There's no way this is a spoof. But it turns out there's a Cyrillic character that looks identical to a Latin letter A. So this isn't the real example.com. It's a completely different domain, even though it looks the same. The question that browsers are faced with is, when is it safe to display non-ASCII characters in a domain, and when does it create a spoofing opportunity like this? You can see that with a naive IDN display policy, or even with a sophisticated one, there are many interesting avenues for spoofing that can open up. To combat this kind of spoofing, in Chrome 75, we introduced a new warning, which we call the lookalike warning. This warning detects spoofy IDNs and shows this page to direct the user to the legitimate site when we think they might be under attack. Here's how this works under the hood. When Chrome encounters an IDN, an internationalized domain name, in a navigation, it converts it to a skeleton, using an algorithm that converts a representation of the domain, collapsing similar-looking characters into one. We then compare that skeleton against the skeletons of very popular sites, and also sites that the user has visited and engaged with in the past. If there's a match among one of those sites, we show this warning to direct the user to the legitimate site that we think is the site they actually want to go to. But of course, it's not only IDNs that are confusing and that present spoofing opportunities. Paths, fragments, and other components of the URL can distract from the domain name, which is the crucial indicator of identity that users need to scrutinize to make security decisions. You may have noticed some changes recently to how Chrome's Omnibox looks to help draw users' attention to the domain name. First, we did some user research on the extended validation indicator in Chrome. Extended validation is a special type of HTTPS certificate, which you can buy to tie your domain name to a legal entity. And when you do this, your legal entity name shows up in browser address bars, as you can see here. The idea is that this type of certificate relieves end users from having to understand site identity from URLs, because they should be able to discern it from the EV indicator instead. From our user research, though, we found that EV certificates don't really help people understand site identity today. For EV to be effective, people need to notice when it's missing, because that indicates a possible attack. But we found that they didn't. There have also been some recent proof-of-concept attacks showing that EV can even be abused to show actively misleading site identity information in the address bar. So in Chrome 77, we moved the EV indicator into page info, which is this UI surface that you see when you click on the lock icon in Chrome. If you have an EV certificate for your website and you're wondering where the EV indicator went, this is where. This is in line with our general philosophy on Chrome that users should be able to assume security by default and will warn when something is wrong. Rather than, we don't want to be presenting positive indicators and relying on users noticing their absence, because we've found that just doesn't work as well. We also recently launched a change to simplify how URLs themselves are displayed in the Omnibox. The scheme, HTTPS or HTTP, and the very common subdomain www don't add much information for many users. The scheme is most useful for telling whether the connection is secure or not, but we already represent that visually with a lock icon or a not secure badge. Besides, we want it to be so that you don't have to specifically check when a connection is HTTPS by looking for the scheme, because Chrome will warn you when it isn't. And for the vast majority of sites, the presence or absence of the www subdomain doesn't make a difference. It's just visual noise for a lot of users who have a hard time finding the security-relevant part of the URL. We now hide these URL components in what we call the steady state of the Omnibox, to make the UI simpler and to focus the user's attention on the security-relevant part of the URL, which is the domain name. You could imagine in the future other possible UI changes that might draw attention to the domain name even more. Should we hide the path of a URL until you click to edit in the Omnibox? Should we make the domain name stand out more by making it bolder or bigger? Should we animate in the path after the user has had a chance to inspect the domain on its own? There are lots of different possibilities, but so far we don't have strong evidence about which one is the best direction, if any, so this is still an open problem. In line with this philosophy, we plan to eventually remove even the lock icon that browsers typically show on HTTPS connections. We plan to present secure HTTPS connections as neutral, as the default, and warn only when the connection lacks security. As you can see here, positive indicators like the lock icon can be confusing to users and send the wrong message. We want to make it so that if you see nothing, you can assume it's secure HTTPS, because Chrome will warn you if it's not. However, we don't have a firm timeline for this change for removing the lock icon, because we need some more time for research and preparation still. Now, not everybody wants their URL display simplified. In fact, many of you in the audience might be power users who understand URLs perfectly well and are pretty good at telling when a site is being misleading about its identity. We want to build tools just for power users like you who understand the underlying identity system of the web well. Our first foray into this space is a Chrome extension called Suspicious Site Reporter. And it does a couple of things that might be of interest to people like you, who want to see the full details about the web pages they're visiting. So first of all, when you install this extension, you'll always see the full unedited URL in the Omnibox. It'll let you bypass any simplifications that we make to the Omnibox in default Chrome, with the aim of helping less technical users. Secondly, we think that experts play an important role in protecting the masses on the web. The extension gives you an easy way to report malicious sites to Google's Safe Browsing service, which scans the web for malicious activity. For example, if we go back to that suspicious bank website that I mentioned at the beginning of the talk, suppose that you, as an expert user, received this link from an email and noticed that it looks like a phishing site. Maybe it doesn't look like your bank's normal domain, or you know that your real bank wouldn't ask you to do something like provide your password over the phone. So in these circumstances, if you open up the Suspicious Site Reporter extension, you'll see some more information about that site, highlighting maybe that it's not a top site that users visit often, maybe it's a site you've never visited before yourself, and maybe pointing out some behaviors that suspicious sites typically exhibit. From there, if you decide the site is indeed suspicious, it's one click to report the URL to Safe Browsing for scanning. And if Safe Browsing finds that the site is indeed malicious, seeing evidence that it violates our policies on phishing or malware distribution or social engineering, it'll block the site for all users of Chrome. So as technical experts, you have an ability to stop malicious sites that non-technical people might not have, and you can use that ability to protect all users of the web. You can install the extension from this URL, or if you want to get even further involved, the code is on GitHub, and we'd welcome your issues that you want to file or any code that you want to contribute. Building usable security tools is a really hard problem. But Chrome is committed to helping people understand where they are on the web. We're doing this by combating spoofing, drawing people's attention to what they need to understand to make security decisions, and harnessing the power of experts like you. But web users today aren't just concerned about first-party website identity. They're also concerned with third parties and how their data flows among those third parties. I'll now hand it over to my colleague Michael to talk about limiting what data is being observed about you on the web while enabling a thriving web ecosystem. Thank you.
Hi, I'm Michael Kleber, and I'm a software engineer working on privacy and tracking prevention in Chrome. So let's talk about third parties on the web. As Emily says, when you're visiting a site on the web, the browser can do a lot to help you know what site you're on. But most sites aren't constructed in-house from the ground up. Just like most homeowners get a professional to do their electrical work, lots of websites have third-party experts to do their analytics or their video serving or other specialized functions for them. Third parties are great. And the fact that this is possible is pretty amazing. Composability is one of the web's superpowers. One huge role third parties play today is ads. Sure, Google and Facebook put ads on their own sites, but that's not what I'm talking about. Most ads on the web come from third parties. When you visit a news site, it probably has ads that were placed there. It could be by Google or Facebook, or could be by 100 other companies in the ad placing business. And that's great, too. Sites across the web full of important and useful content that people get to see for free support themselves with tens of billions of dollars a year from ads placed by third parties. But there's a problem with this system today, and I'm sure you know what it is: privacy. If you're browsing the web, then even if you know where you are, what site you're visiting, You probably don't know all the third parties that are involved, and it's unreasonable to expect you to. What's more, if you're a developer building your own site, you might not know all the third parties who could be pulled in when it runs. This is like knowing your whole supply chain. Transitive dependencies are hard. And even if you know who they are, you still might not know everything that they're doing. And the answer is it shouldn't matter. People should be able to browse the web without worrying that someone is collecting a dossier on them for what they're doing. And developers should be able to build sites without worrying that their infrastructure is compromising their users' interests. So, how can we get there? How can we let third parties do the hugely important things that they do today, including letting ads pay for content, without allowing specific people to be tracked across the web? We have a two-step plan to get to a flourishing web without tracking. First, we want to give third parties new tools to accomplish their goals. That's probably not what you expected me to say, right? But bear with me a minute. Third parties may want to answer some very natural and non-personal questions. Things like, how many different people saw my ad? Or how often do the people who click on these ads actually buy something? Or is there someone who can vouch for you being a trustworthy human web user? Answering all these questions today relies on a really powerful capability, global cross-site identity. And this is what can also be used to knit your browsing behavior together into a user profile. We would be much better off if it were possible to answer these questions with more right-sized APIs. We need a web that is powerful enough to support those vital third-party use cases without relying on a too large tracking mechanism that gives you way more information than what you really need. It turns out that support for some of these use cases isn't easy. We don't want the browser to share your activity with anyone else, not even with a trusted counting service or a spam detection provider. And that means we need to do things the hard way, with powerful machinery doing privacy-preserving operations behind the scenes. Privacy-preserving measurement and fraud prevention? Well, we've published proposals backed by cutting-edge crypto and secure multi-party computation research. Check out the private join and compute blog post and video for some related prior work. Even harder are the ways that the browser can support those ad companies who want to show you ads that you're most likely to be interested in. We have ideas here, too, built on top of on-device and federated computation and guarded by differential privacy protections. Check out Google's Federated Learning website for some more details. I know it's odd to think about something specifically meant to help ads being built into web browsers. But the browser is the place where we can offer privacy guarantees, and these capabilities turn out to be really important for the web to flourish. How important? Well, our friends in Google Ads ran some experiments on life without personalization or these sorts of new capabilities, and the results are pretty devastating. Websites got 52% less ads revenue on average, and news publishers got 62% less. I'm sure you all can imagine what losing half of their money would do to the websites you love. And that's why Chrome believes that this work is worthwhile and necessary to the health of the web. And look, I know some of you are looking at this slide and saying, oh, this is just about Chrome helping Google protect its bottom line. So let me be clear here. Google makes most of its money from search ads. And people only come to google.com to search for stuff because all the richness of the web exists. Helping the open web thrive is the mission for Chrome and is vital to Google, and I think is why we're all here today. So, part one of my plan was new APIs, and these APIs are built to support their use cases even in a world where there's no way to link up your activity across different sites. So once we've invented new ways for the web to flourish, ways that don't rely on tracking, what does that unlock? How do we move to a world where people who use the web are going to be safe and feel confident in their browsing? Recognizing users across sites has historically been based on third-party cookies. But as browsers have restricted access to those cookies, we've seen them replaced with other mechanisms. Covert browser storage, device fingerprinting, asking for user-provided information like email addresses. Those covert tracking techniques are a real problem. They lack transparency into who's using them and for what purpose, and often there is no way to reset them. We've started landing changes in Chrome to block some of these ways of tracking. To be honest, there are a lot of ways that you might try to track users, and so fixing them is going to be a long road, not a quick fix. And we'll be carefully watching the impact on good use cases along the way. Something like shared caches can be a tracking vector, for example, but they also help pages load faster. Speaking of good use cases, remember what I said about us being much better off if it were possible to answer questions with more right-sized APIs? This applies to the covert tracking problem also. Check out this code. What's going on here? Looks like someone is writing a string of characters to a canvas element and then reading the pixels back, maybe to fingerprint you based on your graphic stack, for example. No, it turns out this is WordPress. The writes to canvas are read back to check whether this string of emoji here, with 0 width joins in between them, renders as 3 separate characters like this, or as this one character added in emoji 12. If the web platform forces you to use high-entropy fingerprinting surfaces to perform mundane tasks like checking for emoji support, that's a problem that we need to fix. And then we want Chrome to notice it and stop it when a website is abusing a bunch of unrelated high-entropy content APIs as a way to fingerprint you. Our privacy budget explainer describes the multi-step process that we're working on. As for third-party cookies themselves, let me start with some upcoming changes that we announced earlier this year. Starting in Chrome M80, that's 3 months from now, if you set a cookie the way you've probably been doing it since the dawn of the web, that cookie will be available only in a first-party context. If you want that cookie when you're a third party, you need to do something new. For details, see the Chromium blog post linked here, or see the console warnings that are live in Chrome right now. But the quick summary is this. If you want a cookie available when you're a third party, you will need to explicitly set it with the attributes same_site=none and secure. And yes, that secure thing does mean that HTTPS is a must. There will be no third-party cookies on insecure HTTP requests. This is part of an IETF draft. We expect both Firefox and Microsoft Edge to ship this change sometime next year as well. This is the new world. OK, so what about third-party cookies over HTTPS then? I'm sure some of you are hoping that I will tell you the future, that I'm going to gaze into my cookie dough-flavored crystal ball and tell you whether cookies are going to stick around in their current form, or go away entirely, or live on with some restrictions that prevent their use in cross-site tracking. And I wish I had an answer for you. People's expectations are changing, and all of us in the browser community are watching those changes happen. And it's difficult to predict, especially about the future. Google as a company and Chrome as a browser cannot unilaterally chart the future of the cookie. We can make the current web architecture better by introducing more privacy-safe ways to do important things, and we can build for every eventuality. So what I can say is that Chrome wants to build a web that thrives even if third-party cookies go away entirely. And this is where we need your help. Help us imagine a world without third-party cookies or other tracking vectors. What other use cases are crying out for specialized browser support before we can land there? What new primitive capabilities does the web platform require to get as much utility as possible without allowing user tracking. The Chromium Privacy Sandbox page links to the explainers that we've published so far. And tomorrow morning, there's a talk by Chris and Yoav about the Blink process, what an explainer is, and the conversations that we have in public where we figure out what to ship to solve problems and what problems need solving in the first place. Please join us. There are hard trade-offs and difficult design problems here. Let's solve them together. Thank you.
Jake, come on out, Jake. Right. What did you do?
I broke Big Web Quiz in Safari.
And do you have anything to say to the people here?
I'm really sorry.
And would you like to tell them what happened?
Yeah, it's quite interesting, actually. So I've got a bit of code in there that makes the animations not happen if you prefer reduced motion. It's one of the new features that we're going to be talking about at some point today. And as per the spec, in Firefox and in Chrome, it returns an event target, but in Safari it doesn't. It returns a different kind of object. So when I called add event listener, it threw and stopped working. But it's fixed now. It's fixed now.
And just out of interest, why didn't you notice that?
I didn't test in Safari.
Sorry, I missed that.
I didn't test in Safari.
Right, okay. Well, that's all that sorted. But it is fixed now. So while Jake goes off to feel bad about himself for a little while, you're all entitled to a wonderful break. And you can do that by heading over to the forum area where you had some breakfast this morning. And our next session starts in here at 12:15. If you're on the live stream, do stick around. There's exclusive content for you there as well. So I'll see you back here at 12:15.
Hello there, my name is Mustafa, a UX designer at Google, and in this talk I'm going to be covering designing for speed and hacking user perception. So I'll go through some research and some design examples. But before I get into that, I'd like to talk through a story which will summarize pretty much most of the talk, and that's the story of the slow elevator. So people often complain to building managers that the elevator is running really slow. So this is like a big pain point. One potential solution is to make the elevator faster. So you can install a new motor, you can upgrade the motor, you can rip out the elevator, try different algorithms. The problem with this, though, is quite an expensive thing to do. And for legacy systems, this is really difficult. So this parable kind of describes the web. When new technologies or new techniques come out, it's really difficult to rip out old code and replace it with new code. So what can we actually do in these situations? Well, if we look at the problem and the pain point, the elevator is slow. Really, from a user point of view, it's not so much the elevator being slow, but it's actually the waiting being quite annoying. So if we reframe the problem, we say, okay, waiting is annoying. So what can we do to actually make the waiting feel shorter? So we say, okay, building managers will put up mirrors, they'll install a hand sanitizer, and perhaps they'll play music. And this distraction technique will actually make the whole experience feel much faster. So reframing the problem can actually help us think about how we can hack things perceptively for the users. Because speed is broken down into two things, real and perceived. So looking at some of the technical speed data, like we see like the Financial Times. So the Financial Times have this interesting algorithm called the tipping point. If the user comes to the website 5 times a month, to read 5 articles a month, they're more likely to subscribe to their site. And if they reach 9 articles a month, then they're definitely more likely to subscribe. So they have this tipping point the moment that a user starts accessing their site 5 times a month. So they'll start targeting and engaging with that user. But what they found was by making the website 1 second faster, they increased engagement for everybody coming to the website. So making the experience faster from a technical point of view is really critical, but also the opposite of true. For every 2 seconds for a site text to load, bounce rates go up by 50%. So it's really critical to make your sites technically fast. And from a UX point of view, when you ask users what's the most important thing on the page, they always talk about speed. As a matter of fact, the top 4 things here are all about speed and perception if you think about them. The bottom one, how attractive a site looks, is quite depressing for me as a designer, but on the mobile web, speed is really, really critical. But what can we do as a quick win? So we have an app called Squoosh that we released last year. This optimizes images on the web. Why is that important? Because average page content is images, and images are really heavy. So this is a PWA. You can drag and drop images and start reducing the size of the images. And we demonstrate this at Chrome Dev Summit 2019 and showed by taking the iOS homepage image, we reduced it by 83%. So we can all collectively start improving the experiences on the web just by making images much smaller. You can download the code here and also grab any of the components that are useful, such as pinch to zoom, so please do check that out. But speed on mobile web is important, but the perception of speed is just as important, because what we find is at least a third of users still feel experiences that are technically fast are actually feel really slow. So what can we do to actually improve that? Well, perception and recognizable UI. Making navigation front of center is one small thing that you can do, because if a button is recognized straight away, the experiences feel faster based on the research that we've seen. So another example is making buttons recognizable as buttons. So the blue button here looks like a button, it's more likely to be engaged with, as opposed to the text button, which it may be a button, it may not be a button. So if a person's looking around a page to see what they're supposed to tap or click on, the experience feels slower. So make your navigation items recognizable. Also, give feedback to the user. So the typical life of a button is a user will see a button, they'll tap on a button, engage with it, they get enraged because they don't know what's happening, and then they may tap on it again because maybe they didn't tap on it correctly the first time. So what can we do to stop this? Well, just giving back feedback mechanisms like the ripple that we have in material design can help, because on touchscreen devices you won't have a hover. So just giving reassurances to the user is a small thing to actually change the perceptive speed of an actual experience. Progression is really key here as well, giving users some indication how long something takes to load. One interesting thing in research that we find is ripples that animate towards the left feel faster than other forms of progression. So if you can see in this animation, they're all the same, but the one third from bottom feels faster. In YouTube, what we do is we'll stagger the progress bar across the top just a little bit because it gives this anticipation and hanging, so it feels like the site is loading. Again, this is a small perceptive thing that hacks the perception that the experience is actually in progress. One other thing that you can do is skeleton screens, which are placeholders for content. So one thing that you don't want to do in the scale of good to bad is a blank screen. You want to make sure you show something. The next thing along is an actual spinner. Spinners are better than showing nothing on an experience, but they still don't give any clear indication of what and when something's actually coming. A replacement of that would be the skeleton screens. Now, when you ask users about skeleton screens, generally speaking, they'll say grey boxes makes the experience feel broken. And there's this mass reveal, which isn't great, because conceptually it's the same as the spinner. What we really need to do is have metadata giving an indication to the user that what is coming above the skeletons. The moment we have content, we load it, and perhaps if images, we'll frost or show a pixelated version first and then load the actual full quality image. So you want to show at every step some form of progression so the user is reassured that something is definitely coming. Now, again, this is contextual to your own experiences. So in YouTube, what we do is we'll load the video first as opposed to the rest of the content, even though it's the heaviest thing on the page, because as part of the experience, the video is the most important thing. So again, you have to target which content pieces are critical in your experience and load them first. Because the transitions that we use, we want to give the feeling of progression rather than processing. So we don't just show a spinner and give no indication of what's going. We want to show content coming in slowly and coming out, because it feels like a much more faster, progressive experience. So in summary, you want to make sure you reframe the problem, you want to avoid blank screens, you want to show bold animations, making sure that you're progressing rather than processing, and keep navigation clear and simple. To find out more about the research on speed, you can download our ebook here called Brain Food, We can also check out our PWA ebook to learn more about progressive web apps. And I also have this course on Skillshare where you can learn about the process of UX to help improve your experiences. And with that, I'd like to say thank you.
Hello, everyone. My name is Minku Getchev. I'm a senior developer programs engineer in the Angular team at Google. In this video, I'm going to tell you how to improve the user experience of your app by using predictive prefetching. Imagine that we're in the subway, waiting for the next train. In the meantime, we open our favorite Wikipedia app and decide to learn more about cheese. Just around the time it gets tasty, our train arrives. We get into the car and depart. While sitting there, we decide to continue reading more, but we have a poor signal. We start angrily rage-clicking on the links, but it doesn't help. It just makes the situation even more frustrating. Let us see how we can use prefetching for fewer rage-clicking experiences. First, let us explain what is prefetching. Imagine a user is reading the cheese article from before. In the background, we can download and cache the content associated with other pages that are likely to be needed next. So when they perform a navigation, they can have an instant experience. There are different prefetching strategies. For example, we can prefetch all the assets in the app, prefetch only the assets associated with visible links, initiate prefetching when the user's cursor is above a link, or apply predictive prefetching. Predictive prefetching is a technique that uses methods from data analytics and machine learning to provide a data-driven approach. In order to use predictive prefetching, we need an app usage report that we can feed into a machine learning model, which enhances the app by providing a predictive experience. Microsoft's Office 365 uses predictive prefetching with Angular to improve the responsiveness of their lazily loaded components. YouTube is predictively prefetching content for instant user experiences. But you don't have to be Microsoft or Google to take advantage of this technique. Guess.js is a library that adds predictive prefetching support for apps using popular frameworks, and you can take advantage of it today. It ranks the possible navigations from a page and prefetches only the JavaScript that is likely to be needed next. Now let me tell you the story of Navid, who introduced predictive prefetching with Guess.js to his web app. Navid is building a popular web app with tens of thousands of users for finding jobs in Pakistan. He developed his web app with Angular using the Angular router and CLI. Let us compare how 3 different prefetching strategies would perform on Navid's website. If he was prefetching all the modules in the app, this would have consumed 2.56 megabytes of data for a single user visiting the homepage. With a more efficient strategy, if he was only prefetching the visible links on the page, this would have consumed 1.22 megabytes of data. With Guess.js, Navid's website consumes only 0.18 megabytes of data for prefetching when the user visits the homepage. This is 7% of the traffic consumed by the most aggressive strategy. With the tens of thousands of users visiting Navid's website daily, he saves gigabytes of traffic. The prefetching of Guess.js comes with over 90% accuracy. Combined with prefetching on mouse over, it can provide instant experiences for all the users of his website while saving their data. Additionally, Guess.js adapts its prefetching algorithm to the user's connection speed. It performs more aggressive prefetching for users on fast network and less aggressive for users on a slower network. Guess.js prefetches the individual JavaScript chunks depending on their likelihoods to be used. It calculates the probabilities for all the chunks to be needed at build time, so its payload could be reduced to the minimum. And finally, it does not block the main thread, since it performs prefetching only when the browser is idle. Today you can use Guess.js with Angular, Nuxt.js, Gatsby, and Next.js. The important takeaways from today are that predictive prefetching can speed up page navigation and improve the user experience. By doing so, it will increase user satisfaction and reduce their data usage. If you're using Angular or a popular React or Vue Meta framework, you can take advantage of Guess.js today. You can learn more about Guess.js and predictive prefetching on web.dev. Thanks for watching. Hello, everyone. My name is Miku Getchev. I'm a senior developer programs engineer in the Angular team at Google. Today, I'm going to show you a couple of tools that we have been working on to help you build fast Angular applications. In the presentation today, we're going to look into an existing app and optimize it by going through 3 steps. First, we'll introduce code splitting. After that, bundle preloading, and finally, we will deploy the app to production with a single command, following best serving practices. First things first, let us look at our existing app. As any Angular application, we can run it by using the ngserve command. Now, we can open the app and Chrome DevTools into the browser. Let us navigate to all the pages in the app while DevTools tracks the network activity. As the next step, we can open the Network tab of Chrome DevTools. Notice that the only network request there is triggered by the image from the first page we navigated to. This means that during the initial app load time, we're downloading the JavaScript associated with all pages, although the user needs only a subset of it. This is a good opportunity to introduce code splitting. In Angular CLI 8.1, we added a lazy module generator. It accepts a module name, a route name, and a parent module name. Let us use it to move the About page into its own JavaScript chunk. All we need to do is run ng g for generate, m for module, with a name about, route name about, and parent module app. This command generated a definition of an ng module, declaration of a lazy route, declaration of a default route in the lazy module, and a component that the default route will render. Now, let us go to VS Code to remove the eager route and switch to the newly generated lazy one. First, let us remove the eager route itself. Next, we can delete the eager component import and declaration. As the next step, let us move the definition of the eagerly rendered component to the lazily rendered one. Finally, let us remove the files we're not going to use for this particular example, as well as the eagerly rendered about component. Now we can preview the result in the browser. Notice that the navigation to the About page triggered a network request which downloaded the About module. We improved the initial app load time by delaying scripts which are not immediately needed by the user. This, however, may introduce latency when navigating across pages. A technique that can help us to fix this is bundle preloading. As a next step, we can install the NGX QuickLink module and save it into our dependencies. NGX QuickLink is a preloading strategy that will detect when a router link is visible in the viewport. It will wait until the browser is idle and prefetch it unless the user's browser is in data saving mode. To introduce QuickLink to our app, we first need to import the QuickLink module and add it to the list of imports in the app ng module. After that, we need to import the QuickLink strategy and add it as the preloading strategy of the Angular router. To observe the result, let's go back to Chrome. Notice that when we open the site navigation, in the background, Angular downloads the About module. Finally, let us deploy the app to production following best serving practices. In the console, we can type ng-add angular/fire. This command will install Firebase tools and perform a couple of transformations on top of our project. If we are authenticated to Firebase, it will also fetch our project list and allow us to select one by using fuzzy search. With the latest deployment capabilities in the Angular CLI 8.3, we can add a package from a cloud provider and run the command ng-deploy to push our project to the cloud. Now let us run ng-deploy in the terminal. It will first build our app, performing the most optimal build possible. After that, upload the production assets to Firebase hosting. Finally, it will output a URL that we can use to directly preview the deployment. The cloud platforms with direct support for Angular CLI are Google Cloud and Firebase, Azure, and Zeit. Community partners also implemented support for GitHub Pages, Netlify, and directly publishing libraries to NPM. In this video, we looked into 3 simple optimization techniques. First, we introduced call splitting to our app by using the Angular CLI and schematics. After that, with NGX Quick Link, we added efficient prefetching of chunks associated with visible links in the viewport. Finally, we deployed the app to Firebase hosting, enabling best serving practices, such as CDN and content compression. You can learn more about all of these techniques at web.dev/Angular. Thank you for watching.
welcome back.
Yes, okay, so we're going to do some more big web quizzing, right?
We're going to do some big web quizzing.
So should we bring up the old
We're gonna, so we were...
board?
We have found one competitor, but we are going to go over to the next one. So
Yes.
why don't you go ahead and pull your feature out of a hat?
I shall pull a feature out of a hat, and the one I'm going to pull out of the hat is blob reading.
Blob reading for Jake.
Thank you.
I will now do my part. I will get my feature. And for me, get one from the back. The ones in the back are usually the better ones.
Yep.
Form elements.
Interesting.
Wow, that was already like a sigh of pity in the audience. Wow.
This is a strong round, this one. We've got two very interesting things that we're going to talk about. Okay, I guess I shall go first and tell you a little bit about blob reading. Well, okay, so I don't know if you've used blobs before. You can get them from fetch. You can also get them from input elements like this, if it's a file input. Reading them, though, to get the text used to be a real pain. You had to do stuff like this with file reader.
Beautiful API.
Yeah, it's like a horrible old thing. So what I used to do in order to work around this horribleness is I would use the response objects like fetch, because it will take a blob, and it has these lovely little convenience methods in order to get like the text and other kinds of data. The people in charge of the blob specs saw that and thought, let's just have that. And so you can do that with text, you can do that with stream. Oh, thank you, excellent. I did no work on this, I'm just presenting it. I'll take the applause though. Okay, and so you can do it with stream and array buffer as well. And that is the feature.
That's it. All right, on the other hand, no applause for that feature, come on. Well,
you're going down.
Well, that backfired. So this is a feature for Monica Dinculescu, really, because there was a time where we used forms on the web. We still use forms on the web, but we now have custom elements, and sometimes use a custom element because they look nicer, they have a nice feature, but they cannot participate in how the form works. And what you would have to do is you listen to the form data event and then manually shuffle the data out of the custom element and into the form data.
That's all nice and new. That was this year, so.
Oh, that's also already new, apparently. I didn't know that. But what is really exciting is that you now can actually write custom elements that can participate in forms. In that you say, this element is form associated. You have this one a little bit weird thing. It's called attach internals. And on this internals thing, you are basically able to declare what is my value in the context of the form, is my current value valid, and do all these things. And with that, you can build your proper own checkboxes, input fields, whatever you need as actual custom elements.
It's exciting, but it's not as good as the blob stuff. So, but I would like to hear what
Get the phones out, bigwebquiz.com in case you have forgotten the URL. And then you press the button that says form element. Are you ready? Because
hit the button.
It's your time to press the button of your choice.
Oh, this is quite close. I'm not liking where it's going. Yeah, come on, come on, but back.
Oh, wow.
Oh.
This
no!
is... I just want to say... This is 500 votes so far. 500 people have cast the votes. We have to turn around and press the button. Otherwise, no, you don't press the button. You turn around. We cannot look at the screen.
Should we hang on? Yeah. Should we sit down, and so we can't see the screen? Come on, join me. And should we just decide to do a count? Yeah. Well, stop shuffling away from me. What's wrong with you? Right. Okay. 3, 2, 1. Close.
Where did it go?
Did you clear the vote?
I don't think I did.
I think you pressed the clear vote button.
I don't think, no.
What was the number before it?
Well, we need a second referendum.
I'm going again.
Get out your phones! Vote again!
Right, okay, we'll do a countdown, and I'll press the button this time, because
Apparently I can't be trusted.
I don't have big, stupid hands that can't press the right buttons. Okay, 5, 4, 3, 2, 1, and results.
Wow. Wow. Wow.
I'm a bad winner.
With a bad feature as well.
Yeah, I know, it's horrible, isn't it?
Wow. All right, so I guess in terms of the grid, this means that I have to press the declare as a winner button.
If you can figure out where that button is on the screen, excellent.
I did it right!
Congratulations.
As that does mean, though, that as a result, I get to be the judge or the moderator for the next matchup. That is Intel stuff versus...
Honestly, you got a complete nothing feature against Intel. Let's do this.
I think you'll find it just very clearly and concisely won a vote. Against an interesting form feature, I think. So,
you know the features. You know the champions.
I trust you.
It is your time to make yet another impactful decision on how this conference will continue. Go.
Think of how painful blobs have been. That's the best you've got.
But now they're not
You are my people.
You disappoint me. Which way would you vote on this?
I think it's really close, Jake.
So personally, I think I would vote Intel stuff.
So we have to sit on the floor and stare at each other.
So I don't think
so
this
close.
Nah, I'm calling it. This is it.
All right.
It seems to be like everybody. So I just want to tell you, Blob Reading got 70 votes.
Yeah. Okay. Yeah.
The other one got 500.
I enjoyed a brief moment of victory. It was good, and then I was torn down.
I love Intel as well. I'm like, I'm so happy.
So Jake, just for information, this is what it could have looked like.
Yeah.
But in fact, it looks like this. Should we move on?
Sorry, do I get a point? I think I get.
Oh, points. I guess Jake actually does get a point.
Yes, thank you.
But Paul gets 2.
So we're giving 2 points for the second round. And there is actually, should we explain
we briefly explain this.
So, because, our bread and butter is explaining features to an audience, as you've seen, we feel that we had to come up with some sort of forfeit for whoever didn't win this contest.
The 3 who don't win.
The 3 that don't win. The 3 that are not as good at DevRel as the other one.
Indeed.
So we wanted to make sure that those 3 were marked in a particular way.
I'm feeling so happy right now.
And we've decided to the rest will have to, tomorrow, for the whole day, wear this T-shirt.
Oops.
It is our life. Yeah. So
remember, the later rounds give more points. Nothing is decided yet.
Absolutely, Mr. 0 points. Right, we should leave and introduce the next speaker.
Yeah, who is it, Jake?
Here to talk about signing on the web. Give a huge round of applause for AG.
Where is the clicker? Oh, here. Hello, everyone. Are you enjoying Chrome Dev Summit so far? Yeah? I'm pretty sure we have amazing MCs. Yeah, so my name is AG. I'm a developer advocate working on identity on the web at Google. So do you have a phone today? Right? Every one of you here should have a phone. So owning a phone means that, I assume that, sorry. Owning a phone means that each of you have your own personal phone number. Interesting thing is that even if you own a phone, maybe you're not making a phone call every day, right? You still call it a phone. And the phone numbers are still playing a very important role in your daily life. For example, phone numbers can be used as a digital identifier and a personal communication channel. Some web services use phone numbers to create online accounts or to build social graph. As a personal communication channel, of course, you make phone calls, and you can send text messages. And there are a lot of online services that heavily rely on phone numbers, especially as a way to send SMS text messages. These services are using SMS to let users sign up, help users recover their accounts, increase user security with two-step verification, or confirm payments. This kind of SMS usage is very popular, especially in countries like India, but also worldwide. In a typical user experience, an SMS is used to deliver a one-time password OTP. The user verifies ownership of their phone number by passing the OTP back to the service. But the challenge is, this can introduce some friction to their user experience. To enter an OTP, the user has to open the SMS app. Then remember or copy the OTP from the message, go back to the website, and enter that into the form. It's so easy to make mistakes, and sometimes you have to request a resend. That's why we are proposing a new API called SMS Receiver API. Web developers can use the SMS Receiver API to let the browser receive the SMS message, extract the OTP, and enter the OTP on behalf of the user. For end users, entering the OTP can be as simple as one tap. And we have a few websites that are experimenting with this API already. Swiggy, India's largest on-demand food delivery platform, achieved a sign-in success rate of 88%. This number is on par with that of their native app. Myntra, a fashion e-commerce player in India, decreased the drop-off rate while signing in by 38%. Oyo, a hotel booking service, succeeded in reducing time to login by 42%. These are all impressive numbers, and there are more companies trying out this API. Now, let me talk about the code. Before the website can receive an SMS, you have to know the user's phone number so that you can send a message. If you are using an input tag, my recommendation is to use autocomplete = tell. That way, the browser can help the user autofill their phone number. Giving your website the ability to send an SMS might seem a bit scary at first. What if someone builds a bot and spam random numbers? To mitigate such abuse, you can use a service like reCAPTCHA, especially with reCAPTCHA v3 that lets you identify bots without requiring the user to check a box or solve a puzzle, like picking traffic light images. To send SMS messages, you can use your existing infrastructure or just rely on a third-party service like Twilio, Nexmo, Telesign, or another SMS gateway. Using the SMS Receiver API itself is as simple as one line of code. When you call Navigator SMS Receive, the browser waits for an SMS. Behind the scenes, we are using Android's native SMS Retriever API to access the incoming message. Chrome is one of the consumers of the API, and the message will not be delivered to the website unless it meets certain conditions. The text message needs to include the URL of the origin to which the SMS is sent, Chrome's application hash, and the OTP. However, as we are experimenting with this feature and the API design is subject to change, I won't go into detail about how to format the SMS. You can check the format, latest format in the article I will show you later. When an SMS is received and meets all the conditions, a bottom sheet appears in the browser. And the user can grant the browser permission to access the text message. This permission is required for every receipt of a new message. This means the browser won't be able to read SMS messages without the user's explicit permission. In the current API design, you will obtain the entire text message. So you can use a regular expression to extract the OTP. After extracting the OTP, you can either enter it in the form for the user to submit or post it directly to the server-side verification. To learn more about the SMS Receiver API, please go to Google/SMS Receiver API. The article has details about format conventions and how to implement the API. The SMS Receiver API is still experimental. You can use it under Origin trial, which means you need to submit a request to whitelist your domain, accepting that the API may change in the future. The article has information about how to sign up to the Origin trial. I bet you have tons of questions about this API, and I hope we have successfully addressed most of them in this article. But let me highlight one outstanding question. Is it safe to use SMS as a way to authenticate a user? It's a great question. The short answer is be careful. Browsers enabling this API doesn't mean that we recommend you to stop using the existing way of authentication. The reality is that many websites already use SMS as a way for their authentication with their users. However, phone numbers are known to be hijackable and to be recycled by phone carriers. In some cases, users have been the victims of SMS phishing attacks. We recommend using SMS as an additional factor for something else, for example, a password for authentication. But in a world where you can expect many users to have a biometric sensor on their device, we suggest something even better, which is Web Authentication API. In other words, WebAuthn. We covered WebAuthn at Google I/O this year and last year. But I would like to recap a little bit about it in case there are people not familiar with it. WebAuthn is a standard browser API that enables strong authentication on the web. It's supported by all major browsers, at least partially. By using a piece of hardware, which we call the authenticator, end users can register for and authenticate with a service much more safely than before. WebAuthn is based on a public key cryptography. A user can register an authenticator with a website by generating a key pair, keeping the private key in the authenticator, and handing the public key to the website. Upon signing in, the authenticator can generate a unique signature so that the user can prove to the website that authenticator is present. In the previous session, Emily showed you how Chrome tries to ensure the user is on a genuine site. WebAuthn allows you to provide an extra layer of safety for users. Because the key pair is bound to the website's origin, even if a user ends up on a phishing website, that phishing website will not be able to make the user generate a valid signature, which saves their users. Now, I would like to talk about two primary user experiences using WebAuthn. They are two-factor authentication and re-authentication. Let me start with two-factor authentication. Because an authenticator can prove your presence by combining it with a password, you can perform two-factor authentication for users. That's the basic idea. Let's have a look at a real-world example. GitHub offers two-factor authentication as an option. You start by entering your username and the password. When you see this screen, get your security key. A security key is one form factor of authenticators I mentioned earlier. Click the button, and you'll see a browser's native dialog. Use your security key and perform a gesture on it. The gesture depends on the authenticator you are using. But for typical security keys, simply touch it. If the security key is already registered to the service, you are signed in. Imagine how it compares to entering an OTP manually. It's much easier. So how do I register a security key? To register one on GitHub, go to the security page. You'll be asked to name the security key you are adding. Name it and press Add. Then you can register your security key by touching it. Now your security key is registered. You may add multiple security keys as backups. So naming it helps you find the right one. Imagine if you lose your security key, or break it, or even lost. You can revoke the key from here and invalidate it. So how effective are second factors? Here's a comparison between SMS OTP as a second factor and security key as a second factor. As you can see, SMS OTP is not perfect against targeted attacks, while security key protects users completely. Targeted attacks are a specially crafted phishing email aiming at a certain company or an organization, for example. So two-factor authentication with a security key works quite well. Now, how do we implement two-factor authentication using WebAuthn? The first thing you should do is to check whether WebAuthn is available on the browser. You can do so by checking if public key credential is available. To register a new credential, call navigator-credentials.create. This will cause the browser to start waiting for user's gesture on the connected authenticator. Upon the authenticator's response, you will receive a credential, which includes a public key and an ID for the credential. Send the credential to the server and store it for future authentication. Now that you have your user's authenticator successfully registered, how does the authentication work? After the user enters their username and their password, you will ask for second factor. Use navigator-credentials.get for authentication. For this call, you must retrieve all of the user's registered credential IDs from the server and provide them to the browser in Allow Credentials. That way, the browser can detect which authenticator to use. Again, the user performs a gesture on the authenticator, then you will receive a credential that contains a signature. The most important part of WebAuthn is to verify the signature on the server side. You should use a FIDO server to do this validation on the backend. I would recommend that you use a trusted third-party service or a FIDO certified server. I will come back to this topic later in this session. I have mentioned authenticators many times in this session so far. But what exactly are authenticators? And what kind of authenticators do you need to have on hand for development, or assume users might be using? For two-factor authentication, users can use authenticators that are marked as U2F or FIDO2. As I said, security keys are the most typical form factor for two-factor authentication. They are also known as roaming authenticators. Roaming authenticators can be hooked into your computer or smartphone using USB, BLE, or NFC. One caveat about security keys is that many of them come with a metal plate on it. Some people might think that this plate is a fingerprint sensor, but in many cases, it is not. When you are buying a security key, please be careful about that. By the way, how many of you here have a security key? A lot of you, but I see some of you don't. You learned about WebAuthn today, and you're excited to try it, right? But you don't have a security key. You need one, don't you? So, a good news is that we have this security key to give away. Please visit the Developer Sandbox. There's an identity, security, and privacy Developer Sandbox. So you can go there to pick yours. Thank you. And there is another kind of authenticator built directly into your computer or smartphone called Platform Authenticator. Platform authenticators are more consumer-friendly than roaming authenticator or security keys because you don't have to purchase a separate device. You don't have to worry about carrying it around. And they are a part of the device you use every day. And many platform authenticators come with a biometric sensor, such as a fingerprint sensor or a facial recognition sensor. Users can also use the platform's screen lock feature to verify their identity. Some people may worry that this means that their fingerprint is sent to the website and may somehow be stolen, right? But don't worry. Important secrets, such as biometric data or screen lock patterns, are stored only locally, which means user verification is done entirely on the device. We call this local user verification. This also means that every new device that the user signs in on must be registered. Platform authenticators that have the local user verification ability, or I would say most of them, are specifically called user-verifying platform authenticators. So the second use case of WebAuthn is re-authentication. Re-authentication is a user experience where a user is already signed in, but gets a request to authenticate again when they come back to the website after the session is expired, or when a sensitive operation, such as changing a password or making a payment, is being performed. A common way to perform reauth is to ask the user's password again. But with WebAuthn and user-verifying platform authenticator, the user experience can be really snappy. Let's see how Yahoo Japan integrated reauth user experience. When you are signing in, start with your username. After you submit your username, the browser's native dialog pops up. The user can verify their identity locally with a fingerprint sensor, for example. Once verified, you are already signed in. This fancy UX is also preceded by a registration. Because Yahoo Japan is already passwordless, I'm signing into their service using SMS OTP without a password. After successfully signing in with your username and an OTP, you will be prompted to register the device. Again, perform local user verification. Just like we did for the two-factor authentication with GitHub, the service asks you to name the device so that you can identify it if you need to remove it later on. And your device is registered. Moving forward, you can use this device to log in to Yahoo Japan using local user verification. By the way, how have you got a Pixel 4? Some of you, right? Pixel 4 has a new shiny facial recognition capability. And some of you might have tried it with WebAuthn, with Pixel 4, and so that it doesn't work yet. But the good news is that starting from Chrome 79 and an update to the Google Play services, it will be possible. And I'm going to demo it for you right now. OK, so what I'm going to show you is a reauth user experience at passwords.google.com. Passwords.google.com is a page where you can view the password you stored to Chrome if they are synchronized with your Google account. As you open an individual password entry, you'll be asked to do a reauth. And if you're using a user-verifying platform authenticator, like Pixel phones, you will do a local user verification. So let me try one of the passwords here. By pressing it, intentionally, I'm not going to show my face at first, right? So by pressing, it's asking to verify my identity. By pressing it, it shows a fancy UI with face. But because I was away and not showing my face, it failed. But let me try again with my face revealed to the phone. See, that guy winked. It's cute. And I'm confirmed and successfully able to view my password. OK, go back to the slide, please. Yeah. So it's really nice user experience. You don't have to type much, right? You don't have to type your password. And with local user verification, we have seen about 63% improvement in time to login, comparing to that of re-authentication with a password. It has significant user experience benefit for end users. And here's how to implement this feature on your website. After feature detection, check if a user has a local, user verifying platform authenticator using a function called is user verifying platform authenticator available. That is very long function name. I believe this is one of the longest, not one, the longest function name in browser API. But anyway, with this check, you ensure that the user's environment is capable of the reauth user experience you are about to perform. Call navigator credentials.create to register the user verifying platform authenticator. This is the same function you called to register two-factor authentication. But you need to specify a couple of specific options. Set authenticator attachment to platform. This restricts registration to platform authenticators. Roaming authenticators won't be registered. Set user verification to required. This ensures that the authenticator being registered is capable of local user verification. As soon as the function is called, the browser starts to wait for a gesture on the platform authenticator, in this case, local user verification. When you get the returned credential, send it to the server and store the credential, just like you've done for two-factor authentication. To allow the user to re-authenticate, you also need to store the credential ID on the client side. You can do this with using a cookie or local storage, and the registration is done. When the user comes back, run the same feature detection as you did during registration. However, in this case, make sure that the user can fall back to use other means of user verification, for example, using a password. To authenticate the user, call navigator credentials.get. For this call, set the option user verification to be true. And in allow credentials, include the credential ID you stored locally during registration. As soon as you receive a credential, make sure to verify it on the server side. Once verified, the user is successfully signed in. This is how you implement a re-authentication user experience using WebAuthn. You can start learning about web authentication from Google/FIDO. If you're interested in more nitty-gritty about implementing WebAuthn, there's some awesome documentation written by folks at Duo Security at webauthn.guide. If you're interested in implementing the reauth user experience, go to Google/WebAuthn reauth code lab, which I hope it will help you ramp up with learning WebAuthn. Regarding the FIDO server, there are quite a few solutions available in the wild. You can check FIDO Alliance certified servers on their official website. Also, there's a list of open source servers and other resources as well. We'd like to also collect your interest in a cloud solution for FIDO servers. Please drop a line on sso@google.com or just visit the developer sandbox and let us know. Let me recap. In this session, you have learned two technologies. SMS Receiver API eliminates the friction of entering SMS OTP. It's under Origin trial. We are looking for your feedback on the API. We recommend two user experience flows using WebAuthn. One is two-factor authentication, which works best with security keys or roaming authenticators. The other is re-authentication, which works best with user verifying platform authenticators. I and a bunch of experts on this area will be waiting for you at the developer sandbox. Please come and say hi, and please give us a feedback about our APIs and ask questions, not just to pick up the security key. I hope you'll enjoy the rest of Chrome Dev Summit. Thank you.
We are back.
Yep.
And that can only mean one thing.
Brand new features time.
Get your phones out, be ready. But before there's a vote, we of course have to pick what we are going to champion. We have found our first semi-finalist. So I'll go first. I'll pick.
What have you got?
Please be a bad one. It doesn't feel like there's enough features in here. I have native lazy loading.
Oh,
people already know this one. I like it. Yeah, that's my face. Native lazy loading.
We've had
my feature.
We had that one. That was media keys. I don't know how that got back in the bag. I've got backdrop filter.
Oh. All right. So in case you don't know, it seems like you all do know, native lazy loading is the ability to only load images and iframes once they actually scroll into view by adding the loading equals lazy tag. And that's it. It's so simple, yet so efficient.
It also works for iframes as well, right?
Why am I helping you?
In case you didn't notice, I did say that.
Oh, I'm sorry. I wasn't listening. I was getting ready to show them my feature, which is...
Doesn't work for iframes.
In which case, Surma was misinforming you, and let's talk about my feature, which is simply this. Anybody who does creative work knows that there are times where you want particularly, wait for it, not sepia. I mean, that's fine, don't get me wrong. Invert, sure, who wouldn't? But blur, look at that one. Now that's good. That's good, because we all know you bring a modal up front and you're thinking, oh, it'd be great if I could blur out the background. Now you can. What an amazing feature. Bring
And then
it
your
on.
web app janks, and it's not a good feature. It's
Don't-
not a
don't-
good feature.
You're the one that said about iframes. Anyway, let's to clear.
Go. Do it.
There we go. Native lazy loading versus backdrop filter.
You
Let's
ready?
begin.
Cast your votes. Oh, that's. Did you say it doesn't work on iframes?
I'll be honest with you,
Because
Surma. I'll be honest with you. I think.
I don't think I care.
I think you're onto something here, pal.
I think it works on images, and that's good enough.
I can't hear you.
You know what?
It's climbing. It's climbing. It's climbing. It's dipping. It's climbing. It's climbing. Keep going. Keep going. Keep going. It's a late run.
Oh, look. Oh, it's over. Not enough time. Oh.
I mean, to be fair, I was never going to.
I mean, maybe if we waited long enough and people got so angry that they had to wait, maybe. But we're not going to do that. Instead, we're going to look at the grid and we're going to press a beautiful button called Set as Winner. Delicious.
Okay, do you want to add yourself a point?
I am going to go to the champion scores, give myself my very first point of the day. That deserves an applause, apparently. Yeah, well done. So, enough of our faces. We are now going to talk about DevTools and all the new things coming there, and Lighthouse and all others with Paul Irish and Elizabeth Sweeney.
All right.
Awesome. We're really happy to be here again. Thank you for having us. So I am Elizabeth, and I'm a product manager on the Chrome Web Platform team.
I'm Paul. I'm a software engineer. So we didn't really know what to talk about up here.
Yeah, so when in doubt,
We just ran Lighthouse. Yeah, ta-da! Gave us an agenda.
what an all-in-one tool. Yeah. So at I/O this year, Paul and I laid out a comprehensive blueprint for your performance success.
So it had 15 steps, everything that you need to successfully measure, optimize, and monitor the performance of your sites.
Yeah, and today we're really excited to take a subset of that blueprint and dive a bit deeper. So we're going to use web.dev as our example throughout the talk today. And
Cool, let's get started.
Cool.
So the first thing that we're going to do is take a few minutes to measure and benchmark quality, sharing some of the newest metrics that we've been working on and updates coming to the Lighthouse performance score.
Yeah, then we're going to jump right into how to use our tools for production monitoring and how to diagnose and fix problems.
We're not going to forget Lighthouse plugins either.
No. And we'll finally talk about our newest addition to the Lighthouse tooling family, Lighthouse CI.
Okay.
So let's get started. Measuring the quality of a user's experience is not always obvious. And we know you've heard it before, but some things never change, and that's the fact that there are two really critical elements to measuring the performance of your page. So lab data, which is synthetically collected in a reproducible testing environment, is critical for tracking down bugs and diagnosing issues before your users see them. But field data allows you to understand what real-world users are actually experiencing, conditions that are kind of impossible to simulate in the real lab. The real world is messy, with permutations of devices, networks, cache conditions, the list goes on and on. Either set of metrics taken in isolation aren't nearly as powerful as when they're taken together and combined.
So you have easy access to both lab and field data in tools like Lighthouse, PageSpeed Insights, Chrome UX Report, Search Console. So these tools allow for local measurement as well as production monitoring, which we're going to get more into in a bit.
One thing I wanted to address was why metrics change. As we know, there are a lot of different aspects of performance that can frustrate or delight a user. You know, waiting, uncertainty, hipster pineapples. Okay, hipster pineapples are great, but things that take them away from me are not great. So without having a clear way to accurately measure the nuances of a user's experience, it isn't really possible to quantify the impact that they have on your bottom line or track improvements and regressions. That means we need to have our metrics evolve as our understanding and ability to measure user experience develops. Here is where our metrics have been. Across lab and field, we're trying to capture load holistically as well as the interactivity of a page. But there are gaps, and there are opportunities to more accurately and comprehensively represent a user's experience. So you can remember when we used to focus on metrics like DOM content loaded or onload. They were measuring very technical aspects of a page, like when a DOM tree was fully constructed, and they don't necessarily correlate to what a user actually experiences. And as we evolve our metric story, we want to fill in as many gaps of our measurement of user experience as we can.
There are a few major shifts here that I'd like to call out. The first one is the reduced emphasis on first meaningful paint and first CPU idle. We're excited to have metrics available that better capture when a page feels usable, which leads me to the second major call out, which is the new metrics you see added. Now at I/O this year, Paul and I did share that these metrics were coming, and they were on their way, but now they're here. So largest contentful paint, total blocking time, and cumulative layout shift are all out and available. These new metrics help to fill some of the gaps in our measurement story. For instance, when time to interactive does a good job of identifying when the main thread calms down later in load, total blocking time aims to quantify how strained the main thread is throughout the load. So they complement each other and provide that balance. So let's explore the new metrics themselves. Largest contentful paint aims to measure exactly what its name sounds like. What is the main largest content visible for the user? When is it? Metrics like first contentful paint are helpful, but they only capture the very beginning of a loading experience. And LCP helps to flesh out how quickly a user is able to see the meat of what they expect and want on a page. So, yay, I expect to see my dog, Annie. It's actually my dog. And so as soon as I can see her entire cute little face, that's the value of my LCP. Then there's this. It's not as cute as my dog, is it? No, not as cute. Just a few pixels moving can be the difference between happiness and complete mayhem. So cumulative layout shift measures an aspect of a user experience that we're excited to build out over time in addition to our load and interactivity metrics. And that's predictability. Cumulative layout shift measures the amount that the elements within the viewport move around during load. CLS is trying to measure things like prepending an ad to a list in a way that increases the chances of accidental clicks, like this one, or having a new page in which the story's photo shifts down the page when it fully loads, all that kind of stuff.
All right, so that brings us to total blocking time. I'm going to take a second on this, and we need to do a quick refresher on how event handling happens in the browser. So let's say we have a main thread, and then the user taps on a button, right? So we have some input. Now JavaScript has to react to that. So we have an event handler, touch start, click handler, whatever, some JavaScript. Then we're going to have, recalculate styles, layout, paint. We ship a frame. So that's just kind of the basic normal flow. But let's say that we take a main thread, and there's something happening on it already, just some JavaScript that's doing things. But the user still clicks on that button in the middle of that task. Well, in that case, we have to kind of wait a bit. And then we can do the event handling and ship the frame. But so there's this delay here, this input delay where we're waiting. And of course, if it's just a little bit of input delay, the user shouldn't even notice. And a little bit would probably be about 50 milliseconds. Up to that, user won't even pay attention. But if it's over that, the user is going to start to notice. So what we're interested in here is kind of quantifying that risk of how much this long task might potentially impact any sort of user interaction that could come along at any time. So if we kind of zoom in, and let's take this task. So it's 150 milliseconds long. So basically, the first 50 milliseconds is kind of free, because if all your tasks are under 50 milliseconds, you're good, no problem. But once we get above that, it's a problem. So the 100 milliseconds at the end, we call this blocking time. So total blocking time, basically, if we take a main thread that looks like this, we have 270 milliseconds in total of tasks on the main thread, and 60 milliseconds of that surpasses that kind of 50 millisecond overage. So that's our total blocking time. So the TBT is just the blocking time summed up, all of it between the first contentful paint and the time to interactive. That's TBT. OK, so we covered a few metrics. They're available in various places. Pretty much all the lab metrics are available in Lighthouse. First input delay only really makes sense in the field. So then when it comes to field metrics, you can see most of them are available in Chrome UX support. Other than them, you can collect yourself with a performance observer. And you can check out, actually, the documentation for all this in web.dev/metrics. Brand new landing page, which summarizes all these metrics and also how to measure them yourself. Cool.
So I know what you're all thinking. And OK, this is all fine and great, but how do I make my Lighthouse score better? So ultimately, optimizing for the metrics we just went over will allow you to move your scores from stuff like this to this. So
let's take a minute to make sure that we know exactly how the Lighthouse performance score is actually calculated. We're going to be updating the Lighthouse performance score soon. We're still working to ensure that all the scoring curves are finessed and our metrics are mature, but we're going to ship roughly in January. This is what the current V5 score looks like. It has 5 metrics that are weighted and blended together to form the 0 to 100 performance score that you see then populated in the gauge at the top of the report. The new V6 score that we're working on now replaces first CPU idle and first meaningful paint with largest contentful paint and total blocking time. So let's take a look at that change.
All right, got a little animation. We got to pay attention. Ready? Ready? All right. Now, take those ones away. Bring in the new ones, and then reweight.
It's so beautiful.
Okay. So that's the change we're making.
It took us hours. You can see that we aren't just updating the metrics to reflect TBT and LCP, but we're also adjusting the weights to be more balanced between phases of load as well as interactivity measures. Cumulative layout shift is still being finessed, but we plan to incorporate it eventually. So let's jump right into some of the tactics to actually improve these metrics. Just a quick cool new feature in the interest of allowing you to measure the user's experience as accurately as possible. We've added a reanalyze prompt to PageSpeed Insights.
So for sites that are redirected to a new URL, you're prompted to rerun the report on that post-redirect URL. So you get a full kind of accurate picture of, OK, from the redirect, what is the story of that page? So you can go to the PageSpeed Insights report to benchmark. It's a great place to start. But we also want to know kind of how things work over like a historical perspective and see what the trends are. So the PageSpeed Insights API itself, that is underlying the web app, and it's free to use and allows you to scale up your monitoring across multiple pages and domains. And the cool thing is you can just hook it up to a cron job, ping it daily, drop the results to Google Sheets, and chart it. And I actually did that here with web.dev. Was able just to do that, a lot of conditional formatting. Love conditional formatting. And then got these charts, right. And so this is actually like 2 weeks of data from web.dev homepage collected by PageSpeed Insights. The homepage, and then also one of the articles that I found. So interestingly, first contentful paint, it's about the same in both cases, but then the speed index and TTI are quite a bit higher on the article. Like the homepage is fast, cool, but the article...
We should probably investigate that at some point.
Yeah, we'll get back to this.
OK, cool. So it's exciting to see what our partners have been able to do with the production monitoring capabilities that the PSI API offers. This is a snapshot of a dashboard that VRBO created with the API, and they're able to track their long-term performance trends and ensure that their page speed performance remains on par or better within the travel industry. Another way to track and improve your metrics is with Search Console's new speed report. It was just formally announced last week, which is kind of cool. The speed report allows you to get a sense of your overall status of the site and is powered by data collected from the Chrome User Experience Report. You're able to then go to PageSpeed Insights to get the actionable recommendations that are surfaced in the speed report. And we're making it rain with origin coverage. OK, yeah, it's a stretch, but I had to find a reason to use this because, oh my God, it's a pug and money and pink. Come on. But OK, in all seriousness, every time Paul and I get up here and do a talk, the Crux team has done an amazing job and expanded coverage to even more origins. So typically about 1 million jump every time. That's really exciting. It does provide us with the ability to better understand the current state of the web in a really comprehensive way.
And as of this month, we made a change to the Lighthouse Chrome extension. So it will no longer run locally on your machine. Instead, you just hit a button, and it's going to go ping the API PageSpeed Insights and run on our infrastructure instead. If, of course, you're testing something on localhost or something that's not publicly accessible, then just open up DevTools and run it in the audits panel instead. I wanted to briefly touch on the reproducibility of Lighthouse numbers. So you might have noticed that they change sometimes. And we see this as 2 kind of separate concerns. So first, running Lighthouse for the same page in different environments, say like DevTools, PageSpeed Insights, Lighthouse on Web Page Test, you might end up with different results. So we are investigating a calibration method that might be able to mitigate this somewhat. But in general, I'd say it's fair to expect that different conditions and hardware will lead to different measurements for now. So variability, on the other hand, is the issue when you see numbers and they're moving around, even though you're on the exact same environment. So this is a hard problem that all engineering teams that measure performance struggle with. We're always working to mitigate variability when we can. And while we have more work to do, We're sharing some documentation on the sources of variability and suggestions with what your team can do to implement them. OK, so now we're on to how Lighthouse can be expanded and extended as a platform. So we want to make sure that Lighthouse is tailored and actionable for you. So we're making a few, it can take a few minutes to talk about how you can leverage it for your own use cases.
So there are two primary ways that you can build on top of Lighthouse, depending on what your goals are. The first is with stack packs.
There we go.
Thank you. Stack packs is a feature that allows for stack-specific advice to be served within the report itself. So Lighthouse automatically detects whether or not you're on a CMS or using a framework, and then it will provide you with guidance that is specific to your stack. These stack packs take the core audits of the Lighthouse report and layer customized recommendations on top of them that are curated by community experts that know the CMSs and frameworks. We're excited to be launching stack packs with frameworks and CMSs like Angular, WordPress, Magento, React, and AMP. We're actively wanting to encourage you to create a stack pack, so please do check out the repo and work with us on it.
So the second way that Lighthouse can be extended is plugins. So Elizabeth and I announced them earlier this year at Google I/O. We're excited to see the community start to build their own.
Yeah, and so let's just take a second to kind of refresh our memory on the impetus behind plugins. There's a lot of quality checks that aren't currently covered by Lighthouse core audits, and that's for a few different reasons. One is that we want core Lighthouse audits to make sure that they're applicable to all web developers. There may be really great audits that, for an e-commerce checkout page, for instance, patterns that you definitely want to follow, but those checks wouldn't be relevant for everybody. There are also a lot of really valuable audits that are relevant to all web developers, but the Lighthouse team just hasn't gotten around to doing them yet. So this is where Lighthouse plugins come in. They allow you to implement a new set of checks that will be run by Lighthouse and added to the report as an entirely new category. Whenever Lighthouse loads a page, it collects a bunch of great stuff and all sorts of data about its elements, network records, and just so much more. It's a complete wealth. So these artifacts can be leveraged for plugins. Once you know what data is available to you, you can think through what your goal is for creating a plugin and how actionable, consistent, and valuable it would be for a user to be presented with that information.
OK, let's make a plugin. All right.
We saw something earlier.
Yes, right. That page, that article page on web.dev that was quite slow. We looked into why it was slow. You know what it was? It was a YouTube embed. Well, I do like YouTube. It's
great.
I watch YouTube. It's good. But you know what? Those little iframe embeds,
Show them.
yeah, this is my desktop machine. This is a very powerful machine. And it took half a second, of main thread. The main thread was just taken up doing things just as the iframe was loading. Just show me the thumbnail and the red play button.
Did you try it on mobile too?
I didn't. I'm scared. It would be a lot more. So that's not the best. There's a few people that have looked into this too, and the quick hack is essentially, well, you just take the thumbnail image and put a red play button on it, just like ones that you created, and then when the user clicks on it, just throw the iframe in there and have it autoplay. Kind of straightforward. So anyways, I made a stupid little custom element that does the exact same thing. Really straightforward. And the nice thing is it takes 500 milliseconds of main thread time down to 0, and what is it, 600K of network activity down to 1. So a nice overall win. So let's write a plugin that just identifies these normal costly iframe embeds. So it's basically, we start out with this, we just name it. And the only important thing here is required artifacts. So we're just saying, OK, Lighthouse, we want the data about iframe elements, and we're going to work with that. So the actual implementation's here. We take that iframe elements artifact, and we just look it over. And basically, we're just looking to see where it's coming from YouTube. That's roughly it. And we're essentially going to fail the audit if we find iframes. Otherwise, we'll pass it because we're good. In a plugin, you can then decide how you want to score things, because it's your own category. You have a 0 to 100 score. You can decide how things are weighted. You got to have a lot of control there. We did this, packaged it up. It's really straightforward and small little plugin. And you get a nice, this is a failure state, of course, but easy enough to just identify, OK, yeah, there's a YouTube embed here on the page. It's not optimized. We should probably go implement it. So I ran it against web.dev, found the failure, and then I was like, well, let's just apply my little custom element hack to the page and make it faster. 400 times, I mean, but faster, probably. Yeah.
Marginally.
And that works really well. Like, I feel confident about it being a much better thing for the page. But at the same time,
I mean, yes, ditto. I trust you too. But we need to make sure that the plugin and the Light YouTube embed is, that the fix is viable and sustainable, and we can show that to our teams.
Yeah. So.
And so that's when Lighthouse CI comes in.
Yeah.
So you can now run Lighthouse on every commit before you push to production.
Yeah. And so we really want to be able to provide that kind of confidence for the entire team and that transparency. So for every single pull request, what sort of change are we looking at here? Yeah. So brief kind of architecture look. So inside your CI, where you're doing your unit tests and your linting, you can run the collection agent. So essentially, it's just going to run Lighthouse a few times for each URL that you're interested in. Maybe you're going to assert some things against a performance budget. You can then update GitHub and then post the data to a server. So Lighthouse CI server kind of stands on its own and has a nice front end that we're going to take a closer look at now. So the setup is basically, like, if this is your travis.yaml, then you're building your site, you're running your own tests, and the last line is basically, let's run Lighthouse CI as well on a couple of URLs. You can set it up just on your own like this. There's also an option of using a new GitHub action, the Lighthouse CI action. We've been working on this with our friends at Treo, and it kind of packages it up and runs it inside of GitHub's CI machines as well.
And so you're able to see your entire project overview, how your branches have performed over time against master. And the trends for your Lighthouse categories are all there and visible to the entire team.
And so the integration with GitHub, you'll see on a pull request, is in the little commit statuses, pointing to every URL that's tested and what the results are.
And thank goodness, gone are the days where you're having to toggle and compare between two Lighthouse reports side by side, trying to find the differences, and you're actually able to see the diff view. Now you can see the changes between the two reports in a single view. Now, not only are the differences in the performance metrics visible, but also.
Yeah, so actually this right here, this diff is the diff of the page, the article page that I measured that was very slow before, has the YouTube embed.
Plus 20?
Yeah, that's a plus 20 performance score. I felt good about that. That was not so bad. Yeah, so this, I will admit, it has the YouTube embed fix and the image optimization, the responsive image optimizations from the keynote. So both those two. And so that's good. So performance score went up. We can see what happened. All of our metrics dropped, which is great. We can scroll down, see the summary of everything else that changed. So if anything stayed the same between master and this pull request, it's just not shown. It's only presented with what's useful. And what's nice here is also you can just click in on a few of these. So for instance, total number of requests and bytes for everything. Well, we see that images, we have 1.6 megs less images on the page. Fine, I think that's fine. Main thread work, our script execution, we're doing, 2 seconds less, a second and a half less of work on the main thread. And also third party, you can see the YouTube line where we drop 600K of YouTube's bytes from the page. So in general, feel good about that.
Yeah,
I'm all right with
that feels like a win. So how excited is the team actually about this?
We're pumped.
Yeah, we're really excited. So we are launching the 0.3 alpha of Lighthouse CI today. And you can check it out in the repo, set it up. But please let us know what you think of it. It is early stages, and we definitely want your feedback.
Yeah.
And now we're to key takeaways.
Yeah, we're at the end. All right.
So first, we want to make sure that everybody's benchmarking with new metrics, the ones that we discussed today. We also want you to take advantage of Lighthouse extensibility with stack packs and plugins.
Yeah, try out Lighthouse CI. Give it a shot. Tell us what you think. And keep an eye out for the changes with Lighthouse V6 that are coming out. We're going to be making changes with the perf score, introducing new metrics, deprecating some older metrics. So keep an eye out. V6 should be finalized by January, but we'll have an alpha release of it for you to try for the node module pretty soon. Cool. That'll do it. Here's all the links that we were showing before. And thank you guys very much.
Thanks.
Jake, could you come out here a second? What did you do?
I said that lazy loading doesn't work on iframes, but I was thinking of...
Sorry, what did you do?
I said that lazy loading...
Stormed out on stage.
Stormed out on stage, said lazy loading doesn't work on iframes, but it does. I was thinking of it. I was thinking of...
No.
I was thinking, yeah.
And have you got anything to say to Surma?
I'm sorry.
So, while Jake goes off to fill...
Actually, one thing.
Oh?
You went to the hat, picked out a feature.
It was media keys.
And you went, no, I don't like that. I'll pick another one.
It's because it was media keys. We'd had it.
It came up in rehearsal.
You cheated.
Do you have anything to say for yourself?
No, I don't. Yeah, no, I don't. No. I'm sorry.
How many points should we dock?
We could have a vote on how many points to dock. Let's not do that now, though.
No.
But while Jake and I go off to feel bad about ourselves...
I release you all to lunch.
Indeed, and we will be back here at 3 o'clock. If you're on the live stream, do stick around. There's plenty of amazing content for you, and we will see you all back here at 3.
Hey folks, welcome to another episode of Ask Chrome. We're here at the 2019 Chrome Dev Summit, and we're ready to answer all of your web development questions live. To get started, we've got a list of questions that we've already asked on Twitter. But don't worry, if you're following along in the live stream, send us a question there, and we will do our best to get to it, either today or tomorrow. I'm Jason, by the way, and this is not Rob Dodson. Hi, Sam.
Hi, good to see you. Yeah, sadly, Rob could not make it today, so you've got me instead. Anyway.
Well, it's great to have you, Sam.
Yeah, it's nice to be.
Without further ado, let's jump straight into our first question.
Yeah, so Giuseppe asked about the future of HTML. Now, this is a big topic, as we know, and actually Nicole Sullivan from the Chrome team and Greg Whitworth from Microsoft will be giving an entire talk about this on day 2 of the summit, so make sure to check that out. But without preempting their stuff, just a little high-level overview of kind of 4-part plan really looking into this. And firstly, thinking about accessibility, ways to make the web more accessible by making some changes with HTML and HTML implementations. Stuff like focus outline. Now, this is kind of a little outdated. It doesn't look great. It doesn't work really well anywhere. Yeah. We have some sort of basic problems like, for example, in Chrome, you have like a blue outline and, well, if the background is blue, that just doesn't work very well. So, we want to be able to improve, in this case, outline without people hacking stuff like getting
the whole outline thing,
which is like everywhere on the web now.
Not great for accessibility.
No, we want to avoid that. We want to avoid that. Thinking also about styling. So we want to provide some new hooks for styling elements. Starting with, well, relatively simpler stuff like checkboxes and radio buttons, and then, getting into more complex UI like select elements. Cool. Now, for this, we do actually have to do some work on the DOM to make sure we got elements there for them to be stylable. But yeah, find out more from the talk tomorrow.
Sounds interesting.
The third part of this plan, thinking about behavior. Stuff like, the way you interact with, you imagine like if you've got an email app and you want to add like email addresses, you get these nice little autocomplete thingamajigs. And, we're thinking about new ways to kind of get really nice behavior with those component parts.
Right, so maybe ship a component on the platform that is basically an email to field or something
like
that.
Yeah, something like that.
That would be nice.
Yeah, and actually speaking of new elements, this is another kind of pillar of this. So yeah, thinking about like useful new stuff that corresponds to existing UI patterns. So, think of things like infinite list. Yeah, so I've been a bunch of great stuff there.
Sounds hard, but enjoyable.
Yeah.
Cool. Yeah, so we got another question from Giuseppe on Twitter, and he was asking about potential tooling in the accessibility space relating to some of this work that we just talked about. So I found this interesting because the Chrome team has been actually thinking a lot about improving the accessibility debugging tools that we make available. So simulating different types of assistive technology and that type of stuff. And I don't have a ton of information on this now, but I'm really hoping that we do see some cool stuff coming really soon that makes all of this easier. That way we can start building applications with an accessibility mindset rather than having to tack it on at the end. Also, in talking to them, they brought up a really interesting point. They've been having to work on the accessibility of DevTools itself over the past year or two, and this is a joint effort between Google and Microsoft. And it's been super interesting because DevTools was not originally built in a way that made accessibility particularly easy. So Rob Dodson highlighted a guide that he wrote on web.dev. If you just do a quick search for web.dev, accessibility DevTools, it's actually a whole guide on how to navigate DevTools using assistive technology, which is super interesting. And they've prioritized like some of the most heavily used things like the Elements panel and the console. Everybody spends their time there. So yeah, super interesting guide.
No, that's amazing. That's just a great news story, I think. The idea that you can backport, so to speak, accessibility into a really complex app. Yep. That's fantastic. If they can do it, well, I feel like anyone can. Yeah. We've had some great questions from Giuseppe and others. Thank you, Giuseppe, about like new accessibility features. And like you say, there is some really interesting stuff in the works. So first up, one thing we definitely wanted to talk about is the Accessibility Object Model, the AOM. Now, you know, assistive tech has always had this kind of concept of the accessibility tree.
Right. The tree behind the tree.
Yeah. So for those who don't know this, this is a way to represent the content on a site so that, you know, maybe like gives, you know, assistive devices access to the content itself, which, you know, may not be so obvious from the DOM.
Right.
Now, what the AOM does is to provide new, like, developer-facing APIs that give, you know, more direct access to, like, to inspect and manipulate this data structure, the AOM.
Right, so instead of only being able to get the accessibility tree from the Elements panel and DevTools, like the sidebar thing, there's actually, like, an API for this now.
Yeah, no, that's right. I mean, you can see the accessibility tree in the Elements panel at the moment. Yeah. The problem is that without the API, you know, you can't use like tools to test what's going on there with the accessibility tree, and also, you know, you can't manipulate it as well. The kind of core concept here is that, I don't know, you might want an accessibility object model that's different from the DOM. You know, you might want a different structure. You might want to be able to do stuff like add what we're calling virtual nodes. For stuff like a rich text editor. Now you think about this, you're building an app that's, say, using Canvas.
Right.
You know, like, what does the DOM look like? And
there isn't one, right?
No, we need something different.
Yeah.
Now, like, yeah, the accessibility team here, we're pointing out, you know, you can use fallback content, but, you know, that's just not very pleasant. And that's kind of inherently a hack.
Cool.
So with the AOM, you can create a virtual accessibility tree that describes the content and also can change dynamically, which is really, really cool. You know, that helps assistive technologies announce changes to content and provide like spatial navigation and so on.
It's almost like a second DOM.
Yeah, exactly.
Yeah, that's super cool.
Yeah, so this is a huge deal. So quickly just running through, there's like 4 phases in this. This is a long project, you know, this is as someone just said to me, it's a marathon, not a sprint, definitely.
Yeah.
First up is just some kind of simpler stuff in a way, bringing parity between properties and ARIA attributes.
Okay. Like ARIA role kind of thing?
Yeah, exactly. And some work on web components and so on. Secondly, thinking about events, accessibility events. I think the example that you were discussing earlier was, you know, if you have a user who's actually using the volume control on a mobile device.
Right, for switch access.
Yeah. Or like to, you know, like move a input range, stuff like that. So, you know, how do we work with events there, but also like continue to minimize the fingerprinting surface?
Right, because right now I think if you use the volume rocker on a phone, to like operate a slider, it just doesn't send any events.
Yeah, so that's terrible in terms of accessibility. Right. It's a mess anyway. You know, I mentioned virtual nodes before, and this is a huge thing. You know, this concept of a separate accessibility tree that does not have to mirror the DOM. Right. You know, the structure of the DOM, which is, you know, a huge leap forward, I think. And also the other thing we mentioned, which is, you know, runtime inspection for the accessibility tree.
Right. So this would be like you have a page that like isn't using AOM, but you could get the equivalent accessibility object model for the page.
Yeah.
And like futzwit or whatever.
And this is a huge deal for testing, of course.
Yeah, I can totally see why that's useful.
Yeah.
So when we reached out to Chrome's accessibility experts, they were super excited about a bunch of other APIs that are coming down the pipe, but the one that caught my attention was Focus Visible. So Focus is sort of obviously an important part of browsing the web, especially when you're using assistive tech. But it turns out that managing focus is extremely hard. And also, it's sort of sometimes at odds with how we want to design things.
Yeah, I mean, this is a core part of accessibility, isn't it?
Yeah.
Focus is a huge deal.
It's step zero. So if you think about something like a text field, when you focus on a text field, we have to have a visible indicator because we need to put the cursor in that field. You are going to continue interacting with that field. Versus if you think about a button, oftentimes when you focus a button, it's from clicking the button, and then you're done interacting with the button. So we don't necessarily need to have a permanent visual marker that the button is highlighted. And so Focus Visible is like Focus, but only in cases where we want to keep that focus indicator around.
Right.
Yeah, so there's a trick that Rob was telling us about when we asked him about this, where if you're on a mobile phone with a soft keyboard and you tap something, if the soft keyboard comes up and stays up, that's something that is going to be focus visible.
Yeah,
So we want to persist focus there. If you tap a button on a phone, we don't pull up the keyboard.
Okay, yeah.
So that's sort of like the little limerick. So I thought that was a really interesting way to remember it. So another accessibility concern was providing alternative text for content that is produced in CSS. So we all know, the image tag has an alt attribute. You can provide fallback text there. We don't have alt for CSS, or at least we didn't have it until the CSS alt text API. So this would be if you have like an icon font or images that are being defined in CSS, you could provide fallback text for those images without having to breach into your HTML to do that. We're still working on the compatibility story because right now it's a parse error in older browsers, but there's ways to work around that too.
Yeah. There's some fallback code. We can share that. Yeah. No, that's cool. I mean, there were some kind of semi-functional solutions to this, you know. But, again, like the aim of all this stuff is to avoid kind of hacky approaches and to recognize the real way that web developers are using the web and using HTML. So, no, it's great to see that. Another question we had actually from Pim DeWitt on Twitter, thank you very much, which is asking about, like, I have a drawer with nav items that is initially inert. Will its content still get picked up by crawlers since it is semantically hidden? Now, the concept here, right, is a menu that may not be displayed initially until you tap on something like what we might call a hamburger menu icon.
Burger, hamburger.
Yeah, whatever they're called, the thing with no name. Now, anyway, now, like some of you may not know, but HTML recently got a new attribute on HTML element that makes it possible to mark an element as being uninteractive. And that attribute is inert. Now, from an accessibility viewpoint, this is really useful.
Oh, super useful.
Yeah, because it's a way to make parts of the DOM like clearly be avoided for anything that's like acting on behalf of the user. You can actually try this out. If you go to Chrome and get the flag sorted for this, you can actually try it out. It's quite impressive. You can see the way it changes your interaction with the page. The example that Pim gave was something like an accordion menu that's closed.
Right.
And the problem there is you've got this content which is actually present in the DOM tree.
Yeah, but it's semantically inert, right?
Which is like a pain for especially thinking about accessibility and navigating that content. So the inert attribute just makes this really simple and I think kind of intuitive as a way of marking that content as something that is uninteractive.
It's there, but it's not tab navigable or whatever.
That's right.
And so he was asking basically, like, if I use the inert attribute, if I do the good thing, is something like Google Search or whoever going to pick that up?
Yeah. Now the good news is that search will still see your stuff. This doesn't make it go away as far as search crawlers are concerned. Of course, like web crawlers do benefit from semantic markup, but they aim to discover as much content as possible.
Right, so if you put your whole navigation in something that's inert, we're not going to not crawl it.
That's right.
It's still there.
Yeah. So the answer to your question, Vim, is yes, search crawlers will see stuff even if it's inert.
Yeah, continue to use inert.
Yeah.
So I put out a call for some performance questions, and I got some really interesting ones, a lot of them from Greg.
Yeah.
So thank you, Greg.
Thank you, Greg.
So he was asking a lot about networking performance. And his first question was, with regards to multiplexing in HTTP3, is there an upper limit to shared resource connections? So let's say you had 100 separate style sheets for 100 components or something along those lines. Would you face a time penalty or performance penalty in time to first byte or other metrics for having so many style sheets? And this it's a pretty easy answer. There is still per request overhead in HTTP3. So the protocol has advanced, we have multiplexing, we can stream things concurrently, but there is still headers in the request and the response for each request that you make. And so HTTP 3 reduces the amount of overhead, but it doesn't eliminate it. We can't fully eliminate it.
Yeah, a
so-
request is a request.
Yeah,
right?
you would still have to have headers. If there's cookies, you still have to send the cookies.
yeah.
So there will still technically be a penalty. It might be that the thresholds that you'd be working with here for like number of style sheets you'd want to ship on a page are higher, which is it's a useful thing to have in the back of your mind, but they're not gone. So a second one that he asked was with regards to push headers and resource hints. What are they good for? Do they work? Do they help the user in any specific way? So push headers are pretty useful. There's a new spec called resource hints that essentially lets you ship indicators of resources that you would like the browser to download before you ship the rest of the request. And the primary thing this is useful for is if you are preparing a page, let's say you're doing server-side rendering, but you already know before you're finished the rendering that there's a couple resources the page is going to rely on. Maybe your CSS that you inlined has some external assets, or you are doing server rendering of a single page application and you want to start loading your JavaScript bundles. So you can either send a push promise for this in HTTP2, or coming down the pipe with this spec, you can send early hints with a link header that would tell the browser to go out and download that resource. And so this is just a way for you to get those hints out before you start streaming the response and the browser has to start doing rendering work and whatnot. Just sort of moving the entire network waterfall forward in time.
Yeah.
At least that's the goal.
Yeah. Fantastic.
Yeah, so then he was asking, so HTTP switches the underlying protocol from TCP to UDP.
Yeah.
And I'm not probably the person you'd ask about the internals of that.
Yeah.
But he was asking sort of, are there specific situations in which UDP is better or TCP is better, or is there a clear winner for both use cases? And since he was asking this in the context of HTTP 3, really the answer here is that HTTP 3 is doing a lot of the work that TCP was being relied on before. So, ensuring order and priority and making sure that all the packets get through and are accounted for. And because the higher level HTTP protocol is handling these things, we don't really need the lower level protocol to also handle them. And so by switching to UDP, we've sort of reduced the amount of overhead at the TCP versus UDP level for things that are already being handled nicely at the HTTP level.
Yeah.
So that's sort of the gist of it. There's a ton of details here. There's a really interesting books you can grab on this. High performance browser networking is one that I've read that was really good. So something to look into there.
Oh, let's talk of protocols. It takes me back to my WebRTC days.
Oh, yeah.
If you have questions about WebRTC, please ask them on Twitter.
He's the guy.
We have a whole nother session tomorrow.
Yes.
But in the meantime, we do have some more questions about performance, actually in relation to tooling in the DevTools.
Yes.
Mahesh asked, is there a way to black box scripts in the performance tab? Now, people may have used this approach to debugging, where you can black box scripts to avoid doing stuff like stepping into third-party scripts and getting into this whole, bogged down in.
It can get very messy.
Yeah, just spend 20 minutes stepping through stuff you're not actually interested in.
Not my code.
Exactly. Anyway, the short answer to Mahesh's question, I'm afraid, is no. You can't black box scripts in the DevTools Performance tab. What you can do is that you can group performance entries by URL or domain to get, something like that approaches this, or at least, you get a better view of stuff to separate out the
So if you
components.
only wanted to look at your scripts, you could group them by origin and just look at your origin.
Yeah, exactly. So you can just check out the stuff from first-party resources. It's a little hidden actually in the UI. If you select bottom up or call tree in the bottom panel of the performance tab, you will see this. Anyway, check that out. So it's just a great way to do this, to be able to focus on first-party stuff. And of course, for third-party scripts, you can actually block requests in the network tab.
Right.
And that won't load, so it won't be in your profile anymore. But yeah.
Cool. Good to know. I guess we probably have time for some more questions.
Yeah.
So Andrew Willard on Twitter asked, when can we run lit element in a server-side rendering environment? So I was actually just talking to the people who maintain lit about this, and then kind of circled back with them again in response to this question. They are working super, super, super hard to enable web components rendering on servers. And for them, that's actually even broader than it might be for somebody like me.
Yeah.
They are doing this for non-Node.js environments as well. So in cases where, I guess you'd probably have to run JavaScript on the server, I assume, but not necessarily Node. So this is super exciting. The goal is obviously to make it so that both lit element and lit HTML run seamlessly on the server.
Yeah, nice.
You don't have to, have a whole separate runtime there or
crazy,
whatever. So that should be really interesting, and obviously this is going to be something good for the entire web components ecosystem, not necessarily just lit or lit HTML.
Yeah. Oh, that's really good to hear. Yeah. We've had some good questions. Thank you on the live stream itself. So yeah, a question here about the proper usage of will change.
Much debated.
Yeah, and like this is particularly in relation to hover animations, according to the question. Yeah, thanks for the question. And to be honest, the basic rule is, use it sparingly, use it as a last resort. There is actually a really good article about this with more information on MDN. We will add a link here to that. But yeah, the short version is as a last resort.
Cool.
Yeah.
Should we go to some questions from the live stream?
Yeah, no, let's take a look there.
Yeah.
I got one for you, because I believe you might actually be able to answer it. A question from Bitmotions with some long name. What
is that actually in their name?
Yeah, I think
That's
so.
amazing.
It's pretty cool.
Way to go, Bitmotions.
Yeah. And thanks, by the way, for all these questions on the live stream. So the question here is, what is the longest method name in the browser API?
So before, I would have said get bounding client rect.
Okay.
Which is long, but easy to remember. But no, IG actually just announced a new API that I think takes the cake for this. The API is called Is User Verifying Authentication Platform Available?
Okay.
Yeah.
Let me get my head around that.
Does what it says on the tin.
Yeah, okay. Yeah, I sort of read it right to left, yeah.
Sounds like one of those German things where they take a whole phrase and they make it one
it's got
word or whatever.
massive portmanteau words.
I want it to be that the API has no capitalization. It's just all one word. I think it is thankfully capitalized.
Yeah,
But.
that's quite impressive though.
Yeah.
Oh, wow. I know one thing you were going to talk about actually was just mentioning about the Chrome Serial API.
Right, yeah. Somebody had asked, can PWAs with Service Worker access Chrome.Serial API? Does this have the same or better ability to handle fast communication and the same sort of conditions that Chrome apps had? And my understanding is that the idea is that the Web Serial API should be able to handle everything that the Chrome Serial API handled.
Yeah.
And this is really important. It's like we want the web platform itself to have all of these great capabilities, not just Chrome. That's a very important constraint that we place on ourselves. So I think there's a talk at Chrome Dev Summit about Web Serial.
Yeah.
And I think I actually spotted over in the sandbox there was some Web Serial stuff.
I mean, if you're at the event, and apologies to those who aren't, but there's some really nice demos. But there's actually a code lab that goes with this.
And you could do the code lab anywhere.
Yeah, exactly. And it's really nice. You work with some components which are pretty easy to come by, and yeah, it's beautiful. Cheap.
It's the USB cable that you've got sitting on your desktop.
Yeah, it's like so we'll add a link to that code lab so you can have a go with that.
Definitely.
Also, GPUs. Did you want to talk about that?
Yeah. So Batman SMK, excellent username.
Yes.
So they asked, GPUs are a huge part of the future of computing. That's a given. With WebGL2 support lacking on the Apple and Microsoft ecosystem, what is the tentative timeline for WebGPU? And so I'm not super in the know about the details of the players in this space.
Yeah.
But I do know that WebGPU is something that a lot of people, at least at Google, are interested in. I know that the spec is moving forward, and I believe we have a prototype implementation out there. It has a cool name that I can't remember. But if like I just typed into Google like what's our status on Web GPU, and there's a whole bunch of discussions around this. So it's it's something that is evolving. There is a lot of standardization stuff with GPU computing to agree on.
Right.
Shader languages, that type of stuff.
Yeah.
These are very fine-grained details that matter to the developers that are using these APIs.
Sure.
So I think the status is moving forward. Hard problem. Everyone's very excited about it. So I guess watch this space.
yeah, that's cool.
In the most corny way possible.
Well, that's always a good thing. Now, we also had a question about CSS transitions. Do you know the answer to this?
I don't know. So
we might have to get back to you about this one.
Yeah, we might have to. I mean, Greg Whitworth is actually here. He's giving that talk with Nicole on day 2.
Yeah,
So he would be a good person. For context, Edge had CSS gradient transition support. You could transition from one gradient to a totally different one, which always looks super cool. Although I'm always confused when it does like the rainbow thing.
Yeah.
Never know whether it's going to rainbow or transition the colors. That's never clear to me, but I also haven't read the spec. So.
Right. Yeah.
But yeah, it's something to ask those folks. Obviously, Edge supported it. Chrome doesn't currently support it.
So the future in Blink,
Yeah, so I guess it would just be a question of, we got to figure out what the priority of that is, how many people want to see it, because there's a ton of CSS features that are sort of in flight that we have to prioritize things against. So.
No, sure.
Yeah.
So, one last question.
Time for one last question?
Yeah, one last question. And I noticed this on Twitter earlier from Liz.
Right.
It's actually a question we've been asked a lot.
Yeah, this is a super important one.
Yeah, we get asked about this like many times.
Every day.
Every day, at least once or twice. So the question is, where did you get all those sweet sweaters?
Right. Yeah. So for context, if you did not watch the opener, Mariko and Paul and Surma and Jake have a lovely matching
beautiful
set.
matching sweaters.
Gorgeous knit sweaters.
What we call jumpers in other parts of the world.
Sorry, jumpers.
Yeah.
So the secret here is that Mariko actually knits them herself. She is like a professional knitter.
She has a machine. She's a knitting machine, you could almost say. Yeah.
Knitting machine.
Literally.
Yeah, she's a complete pro. I'm trying to convince her to knit sweaters for the rest of the team, but I don't really have anything to offer her. So, go and bug her and tell her to knit me a sweater.
And actually, we will put a link here. She has an amazing app, which is called Knit. Yeah, it's called Knitlify. And as in, knit with Lify on the end. And you can use that to take an image and create a knitting pattern with it, which is actually apparently what she used for the stuff that's here. So you too can build your own kind of little dinosaur logo jumper.
This is if I had the skill to be able to do knitting.
Yeah.
Which I don't, but I would like to pick up.
A minor problem. Yeah, Mariko is
She's
a pro.
She's a pro knitter.
Yeah, she is.
So that about covers it. Looks like the show is about to resume here. So please keep sending us your questions on Twitter. Use the hashtag AskChrome. We're actually going to do this again tomorrow on the live stream at lunch. And we'll loop back, sort of do our best to answer any questions that we get between now and tomorrow. And we'll see you tomorrow. I'm Jason. This is Sam.
And I'm Sam, and thank you so much.
Thanks.
Yeah.
Hi, I'm Sam from the Developer Relations team here at Google. And I'm here to tell you that it's okay to abandon all hope, to give up, and to go back on your plans. Let me set the scene for you. As you plan your next release and you look at your code, it's very easy to fall into the trap of improving your code base rather than moving forward. You might consider having faster build times, more readable code, or to upgrade to the latest web framework that everyone's talking about. This happened to me back in November 2018, in the lead up to releasing Santa Tracker, which is a holiday-themed experience for all ages. We were in the middle of a rewrite, mainly because our build times were enormous, and we wanted to use Google's new web components library, LitElement. But we made a hard decision to give up on our tech debt and to ship our old codebase, because Santa only comes once a year, and by being busy refactoring our codebase, we just weren't checking off our task list fast enough. So let's talk a bit about what we were dealing with. Santa Tracker, at its core, is a shell which hosts lots of smaller games or scenes, like this fun snowball throwing game here. And on December 24th, we unlock the tracker itself, where you can see Santa traveling around the world on his journey, delivering presents, and finding out when he'll arrive in your town. Some of these games have code that is years old, and as much as possible, we want to avoid throwing these games out in a rewrite. So in 2018, we decided to migrate about 50 different games to work on this new platform. And fundamentally, the rate we were getting through migration tasks just didn't equal our December 1st release date. And this is why we gave up. So we've now successfully migrated for 2019 and beyond. But what did we learn in the process? The first learning is the old idiom of don't let perfect be the enemy of good, as it applies to developer experience versus user experience. I imagine that Santa Tracker would somehow be infinitely better for our users if we had a faster build time and a more modern stack. But the reality is that an upgrade would mostly help my team and have very little benefit to our end users. Keep in mind, of course, that sometimes your technical choices are changed from underneath you. And in our case, we were using HTML imports, which shipped in Chrome, but never really got wider adoption. The truth is, though, there's often really fewer reasons than we think as developers to change the stack. Secondly, we learnt the value of allocating time to prototyping before you decided on a new technical stack. This can save you a lot of grief and technical debt. Technical debt is where you're on a tight deadline, and instead of properly solving some problem, you're patching over it and leaving it for your future self to solve. And of course, all software has technical debt, but it's even worse when you're blazing new paths, like we were, into a totally unknown framework or library. And for us, we didn't really allocate time for prototyping. We were on a tight schedule. We'd bought into this vision of a new amazing developer experience, but in practice, Santa Tracker, like every site, has edge cases that we didn't really plan for and didn't fit into the mold of this new stack, which we'd chosen, which caused us to incur this technical debt. Software always has innate knowledge. Our old Santa Tracker codebase had years upon years of hacks and workarounds, and in any rewrite, it's enticing to skip these weird code paths. But in the end, they were there for a reason. By building a working prototype in a new stack, you can test these edge cases to see if they still matter to you. Because we skipped this step, we hit all sorts of challenges way late into our development cycle, when it was just too late, and we had to give up on the refactor. In hindsight, we should have built out all these tricky nuances of our site in a full prototype before attempting to replace the entire tech stack. What we ended up doing was using what we built in 2018 as the prototype for what you now see in 2019 and beyond. Don't get me wrong, in 2018, we still shipped some of the best parts of the prototype, and that leads me to the final learning. Ship early and ship often. You always want to validate your technical choices with real users. So we'd written a whole new game, ElfMaker, entirely on the new stack. It wasn't part of the old codebase whatsoever. So we felt comfortable testing it with real users. And in fact, if you look closely at how that scene loaded in 2018, you could see how we introduced a bit of magic, deferring to an iframe with a small shim between the code bases. We had to concoct a Franken build system to make this work. But as part of that, we forced ourselves to have an end-to-end build process of the new prototype, even though we weren't shipping it wholesale. And this meant that our rewrite wasn't just wholly turned into just a prototype, and we got a small slice of the new code in front of real users to show that it could work. We're hoping to open source the new version of Santa Tracker in early 2020. It's not perfect, but it is a real website with a bunch of build tooling, legacy code, and necessary technology choices. I hope you'll check it out and get some insights into how to best structure your next project. Remember, don't let perfect be the enemy of good. Your users don't care how the sausage is made. Ruminate on your technology choices by building a prototype, And if possible, try to get the safest parts of your code in front of real users, even if your whole refactor isn't done yet. Thanks for watching, and I'll see you next time.
Hi gang, my name is Matthias and I work on Chrome. Today I'd like to highlight a handy little JavaScript performance trick that's a little bit surprising and somewhat counterintuitive. JavaScript applications, and in particular web apps, commonly use large objects to represent state or other data. The example we're looking at right now is fairly simple and small, but on the web it's surprisingly common to see objects of several kilobytes in size, especially for web apps built using frameworks such as React or Redux. Unfortunately, web apps often depend on this data for their initial render. In such cases, this large JavaScript object ends up on the critical path, and so users end up staring at a blank screen until all of this data is loaded, parsed, compiled, and executed by the JavaScript engine. How can web developers make this faster? One approach is to use server-side rendering. You serve plain HTML that already contains the processed form of the data, and therefore no JavaScript is required for the initial load of your app. This way, you can avoid the need for the large JavaScript objects entirely. But what if you can't use server-side rendering? Is there anything else we can do to improve performance? It depends. In many cases, this critical data doesn't contain anything that cannot be unambiguously represented in JSON. There's no date objects, no bigins, no maps, no sets, and so on. And in those cases, instead of having an object literal in the JavaScript source code, you can serialize the object as JSON, turn it into a JavaScript string literal, and then pass that to the built-in JSON.parse function. This technique produces an equivalent object. Now, which of these two techniques do you think is faster? As it turns out, the JSON approach is significantly faster. This is a little surprising and counterintuitive. The JavaScript object literal feels like the more direct approach, whereas JSON.parse feels like an additional layer of indirection. Yet somehow JSON.parse is much faster. Why is that? Part of the reason is that for JavaScript engines, the JSON example is super simple to scan and parse. Think of it this way. To the JavaScript parser, this code snippet is little more than a call expression with a single argument. The large blob of data is just a single string literal token. On the other hand, the equivalent object literal consists of many more tokens. Each property name is an identifier token or a string-like literal, and in this case, each of the values is a numeric literal, but they could really be anything. They could be nested objects or arrays with properties and values of their own, in which case there's even more tokens. So compared to the JSON.parse example, the JavaScript parser needs to work harder just to tokenize this script correctly. Another reason why JavaScript object literals are harder to scan and parse is because you don't know ahead of time that they're object literals. Let's unpack that a little bit. Pretend you're a parser for a minute, and you're looking at source code character by character. In JSON, as soon as you see an opening brace, there's only two possible options. Either this is the start of an object, or this is invalid JSON. Two options, that's it. In JavaScript, however, there's many more possibilities. An opening brace could be the start of an object literal, but it could also be a number of other things. Let's walk through some examples. Here we have an opening brace on the second line. What do you think? Is this an object literal or not? And what does the X on the second line refer to? Does it refer to the binding on the first line, or is it something else? Turns out it's not even possible to answer these questions without looking at the rest of the code. In this case, the second line creates an object literal. X refers to the binding on the first line. But in this case, it's an object destructuring, and the X doesn't refer to the first line at all. And then there's this scenario, where the second line contains an arrow function with a destructuring parameter named X. In that case, the X also does not refer to the first line. The point I'm trying to make here is that parsing JavaScript is tricky because its grammar is context sensitive. JSON doesn't have that problem, and so parsing JSON is much simpler. And that's why, Especially for large objects, it's faster to use JSON.parse than to use a JavaScript object literal. At this point, you're probably wondering, how much faster is it exactly? We measured this for an 8 megabyte payload on cold loads with no caching and found that in V8 and Chrome, the JSON.parse technique is 1.7 times as fast as the object literal. And the speedup applies to other JavaScript engines and browsers as well. In Safari and JavaScript Core, the difference is even greater. There, JSON.parse is twice as fast. Okay, you might say, that's just a synthetic benchmark with a very large payload. How does this affect real-world web apps? Well, Henrik Joritek applied this optimization to a Redux app he was working on and published a case study about the results. There was an 18% improvement in time to interactive, and the app's Lighthouse performance score went up 8 points as well. That's not bad for applying a single optimization. How can you start making use of this optimization? I wouldn't recommend doing this manually. In source code, you still want to use object literals since they're just more readable. Instead, tooling can help you to automatically transform large object literals into JSON.parse as a build time optimization. Webpack already applies the JSON.parse technique if your codebase uses JSON modules. There's also a Babel plugin that can apply the transformation on other code. For more JavaScript performance tips, check out The Cost of JavaScript on the V8 blog. And that's it. Thanks for watching, everyone.
Hi folks, my name is Tom and today I want to talk about dark mode. I'm not sure when you have entered the world of computing, but for me it was during the dark era of MS-DOS. And you know what? We've actually gone full circle with dark mode. If you've used a computer in the 1970s or 1980s, you probably have used dark mode before. Well, dark mode became a thing. In that time, when screens oftentimes were monochrome and color screens incredibly expensive, dark mode wasn't a choice, but simply a fact. Only when color monitors became more affordable and what you see is what you get desktop publishing evolved, the idea of making a virtual document resemble its physical printed end product became popular. And this baseline assumption of dark text on light background was carried over to the very first, earliest web designs. The epoch of those heavy cathode ray tube monitors with massive desktop PCs that we consumed these very first web pages on is long over, and nowadays, more often than not, we use mobile devices with light, LCD displays or AMOLED screens that also have enabled completely new usage patterns. For example, I often browse the web while in bed, and because it's easier on my eyes and less likely to wake up my better half, I tend to turn on my phone's dark mode. I've done some user research on why people use dark mode and under which circumstances. The results are pretty interesting. While the majority of the surveyed users unsurprisingly said dark mode was easier on the eyes and just looked beautiful and elegant, the third most mentioned reason for using dark mode was that it consumes less energy. The Android team have looked into this and found out that on AMOLED screens, dark mode can save up to 60% energy. This is why on Android Q, when battery saver kicks in, we automatically activate dark mode. And finally, some people say they require dark mode as a true accessibility tool, without which they can't get their work done. Interestingly, dark mode usage correlates less than expected with the surrounding ambient light situation, meaning a lot of people, like me, use dark mode permanently. So how do you activate dark mode in the first place? On macOS, it's a setting in the System Preferences in the General section. On iOS and iPadOS, you can toggle dark mode in Settings in the Display and Brightness section. On Android, dark mode is called Dark Theme, and you can activate it in Settings in the Display section. For Windows, dark mode can be activated in Settings in the Colors drop-down menu in the Personalization section. And finally, for the various Linux distributions, activating dark mode typically involves setting a dark desktop theme. Now that we know how to enable dark mode, let's see how we can actually support dark mode on our web pages. The secret is a user preference media feature called Prefers Color Scheme. It has 3 possible values: dark, light, and no preference. The simplest possible dark mode implementation is to just invert the background and the foreground color in the case the user prefers dark mode. You can see how the page reacts when I toggle the macOS color theme between light and dark. Switching the entire operating system's color scheme can get really annoying, so in Chrome DevTools, we now allow you to emulate the user's preferred color scheme. So back to the theme per se. While it works, already in this basic example, you can see how in practice things are a lot more complex than that. The default purple user agent style sheet color of a visited link has a contrast ratio of only 1.9, which isn't enough. We can fix this by adding some more CSS, and now it slowly starts to look okay. But you can see where this is headed. For a production website, we'd have hundreds or even thousands of cases like this that we'd need to cover. So rather than one by one, we need something better: semantic color definitions. We can do this with CSS variables. So instead of using hard-coded colors on the various elements, we use variables like text color or background color, and then define these variables dynamically based on a preferred color scheme. As I said before, already for the toy example, we need quite some CSS, and even more for production web apps. But here's the thing: if you have dark mode enabled, you shouldn't be forced to load CSS that is only relevant in light mode, and vice versa. We can deal with this by splitting our CSS into 3 files: dark CSS, that contains all the dark mode relevant CSS variable definitions; light CSS, that contains all the light mode relevant CSS variable definitions; and style CSS, that contains the common CSS where these variables are being used. Like that, we make sure that in the critical rendering path, only the CSS that's needed for the preferred color scheme gets loaded, with the highest priority and the rest with the lowest priority. If you have to deal with older browsers that don't understand the preferred color scheme media query yet, we require one last trick to make sure the default CSS, for example light CSS, gets downloaded with highest priority. Therefore, we manually insert the light CSS style sheet with the good old insert adjacent HTML method to force its download with the highest priority. The ugly string escaping is to make it work even on browsers that are only compatible with ECMAScript 5. Alright, with all of this out of the way, let's have a look at how you can actually design for dark mode and what to keep in mind. As we've seen before, getting all the contrasts right, making sure the design conveys concepts like elevation in both light and dark themes, and still incorporating your brand's colors and accent colors is incredibly hard. Material Design can help your design team bootstrap a design that respects all the best practices Material has established. On material.io, you can find a number of resources, including a code lab, to get you started. One last tip: remember that not everyone who has dark mode activated on the operating system necessarily wants websites to be dark too. It is a nice gesture to provide users with a dark mode toggle for your site that initially respects people's preferred color scheme preference, but then allows them to temporarily or even permanently override it. You can easily support this use case with a custom element that we've developed right for this purpose: dark mode toggle. All you need to do is load the custom element script and then include it on your page. You can find out more about this custom element on GitHub. And with that, thank you very much for watching. You can find links to all the features, articles, and code samples from this video in the description. See you next time, and enjoy dark mode.
Hi, I'm PJ, and this talk is about getting permission. Patterns for making fluid permission requests. The web is expanding in exciting new directions and as a platform. With powerful apps like G Suite, Google Earth, or AutoCAD all running in the web browser, more is possible with the modern web than ever before. For example, we have location access, camera, mic, push notifications, offline, WebAssembly. These are just a few examples of modern capabilities that have arrived on the web in the last few years. And there's a lot more coming too. But this new power often relies on underlying device capabilities. The web is a sandbox that's designed to let users safely run untrusted code on their computer, enabling users to quickly and safely use websites and web apps from untrusted sources with a tap of a finger or click of a mouse in the browser and without downloading and installing software is one of the web's superpowers. The W3C developed a set of ethical principles for the web, and there's two that especially apply to powerful web capabilities and permissions. First, the principle that security and privacy are essential, and second, that the web must enhance a user's control and power. It's tricky to balance the trade-offs between user empowerment and safety. Access must be controlled from the web sandbox to any feature that could be used to violate the user's security and privacy, but browsers must give users control and power to allow access when it's safe to do so and in ways that facilitate their goals. Many advanced web capabilities are effectively letting users open up gateways in and out of the sandbox. To adhere to the W3C principles, browsers need to err on the side of user safety. But browsers can't know what a web app will want to do with a given permission. So browser UI for permissions is context-free by necessity. Web developers need to help users understand what access their application is requesting and what it will be used for to help users make empowered decisions. First, only ask for permission you really need. Trust and fluency are everything in the modern digital world. If a user doesn't understand why you're asking for permission, you've risked your trust with that user. Worse, you may have interrupted their workflow with a prompt, increasing their cognitive load, distraction, and the chances that they won't get value out of your offering. Second, be clear and specific about what you need and why in advance of prompting. Don't assume that your users know what your brand is or what your app does. Explain to them clearly, or make sure the usage is fully aligned to the user's gesture. Third, prompt at a contextually relevant moment in the user's journey. Don't ask for permissions up front. Fourth, degrade gracefully. If a user ignores or blocks a permission, make sure your experience still works. Fifth, if a block or ignored permission is needed to use a feature of your app, make this obvious to your users, but don't get in the way of other features that don't need that permission to work. These principles will not only make your user's journey more pleasant, they'll contribute to better business metrics as well. Users hate being interrupted, and they hate getting broken experiences. Keeping these principles in mind in your app design makes for a better user journey. Let's do this by example. Don't ask the user if they want to allow push notifications as soon as they land on your website. In the future, Chrome will minify the push permission prompt for sites with very low push accept rates. You can already test this feature out in Chrome Canary by enabling the quieter notification permission prompt flag. Please do prompt for notification permission when there is a clear benefit and a context to the user. Don't prompt for location permission without user context. For example, users may not know why they're being asked for their location if there's no map or location UI visible in the page or if it's below the fold. Please do prompt for location permission after an explicit user action. Please don't prompt for mic or camera access without explicitly indicating how it's going to be used in advance. Do make use of mic and video permissions where appropriate. Either explain the upcoming prompt in advance or associate the permission prompt with obvious context, such as following a user gesture to start a video or chat session. Please don't fail silently if a user ignored or blocked necessary access for a feature they're trying to use. But do explain why your feature won't work without access, and let your users know they'll need to enable access if they want to use that feature. To recap, these are the principles of good permissions request UX. First, only ask for access you really need. Second, Be clear and specific. Third, prompt at a contextually relevant moment. Fourth, degrade gracefully. And fifth, when a blocked or ignored permission is needed, make that obvious. Thank you so much for listening. If you have any feedback or questions, please reach out to me on Twitter at B1TR0T.
If you've seen a talk at Chrome Dev Summit, you already know that much of the web is too slow, too heavy, and inefficient, making sites hard to use for people on slower connections or lower-powered devices. Your site may work great on your $1,000 phone in your major metropolis, but someone in a rural area or another country may find your site frustrating or simply unusable. What if you could keep your site's look and feel while making it accessible to everyone? What if you could make your site more elegant, leaner, and more maintainable with less code? This is why AMP was created, to make it simple for all developers to create fast, lean sites for all users. So, what is AMP? First, fundamentally, AMP is a web components library. Working on all major browsers, it provides new HTML tags that do the work you'd normally do with JavaScript. AMP is also a set of guidelines on how to create fast sites for everyone. It requires HTML attributes that enable accessibility. It stops you from including too much CSS, and JavaScript can only be used in contexts where it can't harm the user experience. Sites that follow the rules of AMP get a bonus. Caches like Google's store AMP pages so that they can be loaded from search in less than a second, even on 3G. While it's most known for pure content sites, AMP also provides tools to create interactivity. We'll talk about two ways to do this. The old way, which we'll call AMP Classic, and AMP Script, which we'll just call, well, AMP Script. We could also call them JavaScript Lite and JavaScript Pro. So first, AMP Classic. For this, we'll use some examples from our AMP Camp demo site, and some that aren't. Let's say that when a user taps this button, we want to open a menu. For this, we use AMP Events and Actions. AMP processes browser events into AMP events and exposes those to you, the developer. For example, when a user clicks a mouse or taps a touchscreen, AMP fires an event called tap. AMP Actions allow you to change things on your page. For example, to show a DOM element, we'd use an action called show. To toggle its visibility, we'd use an action called toggle. And that's how we open the menu. Notice the form here, on equals tap, sidebar toggle. Tap is the event, sidebar is the ID of the element we're acting on, and toggle is the action. Next, how about server calls? When a user visits our site, we want to call an API to find out how many items are in their cart and then show this on the screen. For this, we use two components that work well together, AMP List and AMP Mustache. AMP List sends an XHR request to an endpoint. The data returned gets formatted through a Mustache template. Here's how this works on AMP Camp. On page load, AMP List calls the endpoint specified in the source attribute. Our API returns JSON that contains the number of items in the user's cart. AMP then plugs that JSON into this Mustache template. If there's a count, that gets displayed in a span. If the count is 0, we display nothing. Simple. Finally, to change what's on the screen in response to user actions, AMP lets you store application data in HTML state variables and bind expressions to DOM elements. Here's a simple example. We start with a state variable called team that contains an object with one property, star, whose value is initialized to Yao Ming. Now here's a p tag with something unusual, an attribute called text in brackets. These brackets let AMP know this is a bound attribute. We've bound this to the expression team.star plus is tall. When that expression's value changes, so will the content of the p tag. Now, remember actions and events? Here, we're saying that when this button is tapped, go into our team state variable and change the value of star to Yao Ming in Mandarin. And here's the result. You tap this button, and the text on the screen changes. Now, let's put all this together. We can use data binding to change an API endpoint. On our site's product listing page, our user can filter and sort results. Each time they make a selection, we call our API to retrieve the appropriate JSON. When the user makes a new selection under sort by, AMP fires an event called change. Then, we store their selection in the filter property of a state variable called products. Meanwhile, we've bound the source property of this AMP list to an expression that calculates the query string for the API. So when the user makes a selection, the products object changes, and the expression is recomputed, which then triggers a new server call. And presto, new products appear. You might be excited to try out these techniques. Or you might just be saying, why can't I just use JavaScript? The AMP team loves JavaScript too, but part of the promise of AMP is that JavaScript isn't allowed to block the main thread and slow things down for the user. Fortunately, now there's a solution. You may have heard talk about workerized JavaScript. It's the new hotness. The nice thing is, JavaScript in a web worker runs in a separate thread, so it doesn't block the main thread or user interactions. The problem is, workers can't access the DOM, so how can a worker control web interactions? AMP script provides a clever solution. It maintains a copy of the DOM in the worker itself. When something changes in the real DOM, AMP script changes the copy in its virtual DOM, and vice versa. This makes workerized JavaScript easy. To preserve AMP's performance guarantee, scripts can only run after a user interaction, not on page load, and your code can't exceed 150K. AMP script is pretty exciting, but it's so new that at the time of making this video, we haven't yet had time to include it in our AMP Camp site. Hopefully, by the time you see this, we will. I urge you to try these techniques. If you don't like them, by all means, create your interactive site in another way. You don't have to use AMP. But I will say it's still hard and rare for non-AMP sites to be as fast and lean as AMP sites. It takes effort and discipline, and especially on larger teams, it's simply hard to avoid excessive JS and CSS. AMP can be your product manager, your scrum master, urging you onward. So why not give this a try? Check the links in the video description for more information and for documentation, as well as for links to the AMP Camp demo site and the AMP Camp code on GitHub. Thanks for watching, and see you next time.
Hi everyone, my name is Vincent Rabod. I work on image compression research at Google. This coming spring marks 10 years since we developed the WebP image format. This video talks about WebP, how it's being used today, and what we're developing next for the web. Some of you may be familiar with our previous videos on image compression, which you can find on the links below. WebP is an image format designed to save bytes on the wire for the web. Getting better visual quality in fewer bytes means faster load times, reduced data usage, and increased user engagement. Compared to the best JPEG encoders, WebP can reduce file sizes by 20 to 30% at the same visual quality. The lossless WebP mode sees similar savings over PNG encodes. On the animation side, WebP can produce even greater savings over GIFs. The format is open source and free, so you can try out WebP today by checking our developer site. So what has changed for WebP since the format was first released? Well, all along, the encode and decode libraries have continued to improve not only in compression performance, but also in CPU and RAM efficiency. Last year, we released a 1.0 version of libWebP, with future updates focusing only on maintenance and bug fixes. Huge thanks to all the open source contributors, bug filers, and testers who helped make libWebP the code base it is today. Another recent change is native browser support. In the last year, Firefox and Edge started shipping with WebP decoders, adding to long-standing support in Chromium-based browsers and Android. WebP has never been available in more places, reaching 80% of web users according to caniuse.com. For browsers without support, like Safari or Internet Explorer, check out our prior video on the picture element for JPEG fallback. You can also use WebAssembly to add a decoder to browsers only when WebP content is being served. For more information, check out this video from Google developer expert Kenneth Christensen. The web ecosystem has also expanded for WebP, with new options for essential image toolchains. Most recently, our team launched WebP Shop, an open source Photoshop plugin for importing and exporting WebP images in Adobe's Creative Suite. This is on top of existing support in Google properties like Android Studio and Squoosh, as well as open source tools like GIMP and ImageMagick. WebP has never been easier to use on your site. You won't be alone, since more developers are using WebP than ever before. Beyond success stories at Google brands like Shopping or YouTube, companies like Shopify, Vox, and Pinterest have detailed how WebP improved their site's quality. Now that we've accomplished so much with WebP, what's next? Well, as future work, we're exploring new algorithms that can bring an extra 25% size reduction, as well as a wider color space, hence enabling HDR display. Of course, we're keeping the features that make WebP a great compression format for the web: animation and lossless, interruptibility, meaning you can display something even if your image is not fully downloaded, no need for dedicated hardware, and of course, low CPU and memory footprint. Thanks for watching, and stay tuned for updates.
Hello, I'm Mariko from Chrome's web developer ecosystem team. I'm part of the small team that build a web application like Squoosh and a web game like Prox. So, whenever we were starting these projects, we start with design and think about responsive design. Think about desktop and how it looks like on the smartphone. And you think about the click interaction and touch interaction. And this is all great. This is a common practice, and it's so great that you're thinking about responsive design, but many other users might be interacting with your website using something other than mouse and tap. For example, other users might be accessing your website only using keyboard or other assistive technology. Or other users might be accessing your website using screen readers and listening to what's on the screen. Other case, user might be accessing your website using feature phone with tiny screen, or on the smart TV using giant screen and using a remote controller as a mouse. So whenever we build a web application, we need to think about those different devices and all of the users using those devices and making sure that nobody gets left behind. Let's think about this small web application that has a menu, you click on it, some new content load in, and then you need to click next. This seems very simple. It's only 2 clicks, but for users using keyboard, this might be different. So for the same website, user might have to tap the key many times to select the menu, and then once the page is loaded, they have to click many more times on the keyboard to get to the next button. And this is not great. So in this case, we as a web developer needs to do a little bit of focus management. See, the browser, if they found a focusable element like button, then it focus on it. But as a web developer, we can add an attribute called tab index and set the value to -1 to tell the browser that this element is not focusable. Using this attribute, we can do a technique called roving tab index. So let's say the website have a collection of items that is selectable. You put tab index of 0 to only one item and set everything else to -1. In this way, there's only one item that is selectable in the collection. And if the keyboard user wants to move away from the collection, they just need to tap tab key and then go to the next button easily. If they want to interact with the collection, then they can use up and down arrow key to navigate those collection. In this case, we add a little bit of JavaScript to listen to those key events and move the tab index of 0 to where the focus should be and move the focus. And speaking of focus ring or focus highlight is really important. In many cases, this is the only way users know which element has a focus and which one get clicked when they hit enter. And this one comes in handy too when user is accessing your website using tiny screen like feature phone. Of course, if you prefer the mouse and touch user to not see those highlights, you can look into focus visible attribute on the CSS to control those. And speaking of focus, we sometimes need to proactively manage the focus too. Here's a common user interaction we see on the internet today. You click on the hamburger icon, and then the menu slide up. But where did the highlight go? Well, highlight is still trapped in the background. So even though user open the menu to interact with the menu, they cannot get to the menu item. In this case, you need to move the focus to the menu. So click on the hamburger icon, menu shows up, you need to move the focus into the button inside of the menu. And don't forget, if user click on it and close the menu, then focus should go back to the previous element that had a focus. If you want to know how we use these techniques in the real-world web application called Prox, you should check out my talk from Google I/O called Building Fast and Smooth Web Apps. Thanks for watching! Hey, welcome back.
Hello. Oh, I like the low energy whoop there from everyone who's just had some lunch.
Did you have a good lunch? Did you make new friends? Good. Huh?
One person made a friend. The person they made a friend with wasn't shouting. So, shall we do some more feature quizzy, whatever we're calling this? So it's going to be me versus you.
Yes.
So do you want to from the old hats there? What have we got?
Which one do I get? Oh, object from entries.
Object from entries. Excellent. Okay.
Did you put the...
I need to put the thing on the screen, don't I? That was very unprofessional. Let's, here we go, and let's zoom into there. Right, we got from entries on there.
Yeah.
And so I will have all settled.
Ooh.
Promise all settled. So we've got a couple of JavaScript features here.
Oh, yeah. That'll be
Going
interesting.
against each other.
Am I presenting first then?
Yes, go for it.
Okay, so from entries. Ta-da! So, you can make a list from object using object.entries, right? But up until now, bring it back from nested array of things to the object you have to iterate through to make the object. But now, all you can do is object from entries with list. And then you can put that back. So I don't know if you know, but I used to do data visualization.
Okay.
And all you do on the data visualization is changing the form of the data. This makes the life super easy. Thus, I should win.
Okay, fair enough. Well, I guess I should present this promise all settled thing. Okay, so when you use promise.all, you pass in a series of promises, and it will resolve once all of the promises resolve, and it will give you an array of the values that it fulfills with. However, if any one of them rejects, it immediately rejects, and you lose all of the rest of the data. That is in contrast to all settled, where it will wait for all of the promises to either fulfill or reject, and it gives you an object that tells you all about all of the stuff. And this is actually really useful. So if you're doing a load of fetches and you want to know when they're all done, if you fetch 9 chapters of a story, but one of them fails, you don't want to lose all of the rest of the data. Whereas you would with promise.all, here you get all settled, it'll tell you the exact one that failed.
Yeah, but once you get that data, you have to, change the form of it with my object.fromEntries. So.
This is something people have been asking for a long time. I don't think anyone cares about JavaScript objects, to be honest.
Oh my God.
Should we have a vote then and find out what the audience thinks?
Yes.
So, you know what to do. It's bigwebquiz.com. What we're going to find out is what you prefer. Is it object.fromEntries, which is rubbish, or promise.allsettled, which is
Which you don't really have a use for.
Amazing. So get the votes in.
Oh, God.
Enjoying this?
Remember if you made a sweater?
Oh, sorry, yes. Oh, Mariko made all the sweaters that we're wearing, by the way.
I did.
So,
I should get points for that?
Yeah, you get some points for that.
Oh, thank you.
I mean, not in the game.
Thank you.
I'm going to close the voting.
Oh, God.
3, 2, 1.
I literally have no points so far.
Really?
Uh-huh.
Oh, I'm kind of sorry, but then also I'm getting points,
It's
so
the
that's
way
fine.
it goes in tech, isn't it?
Oh, I see. Trying to divert. No, it's just a better feature, so I'm going to set myself as the winner of that round. But we have some more voting to do, because we can now go to the next round, where we're going to face off native lazy loading alongside all settled. Oh, hello there.
Hello.
How's it going?
Good.
I
heard you want to face off against my feature.
Okay, I like the way you put it. Yeah, we're going to do that. So let's create. Do you want to do a one-line description of what we're going to be talking about for you?
Image tag loading equals lazy.
And just remember how much you loved promise.all settled before. Hold on to that
By the
as
way,
you're voting.
My feature also works on iframes. Oh, look at that.
This is not going well for me, is it? I mean, I don't know. We're just going to call this early, aren't we?
Yeah, call it.
Are you driving?
I'm not driving.
Okay,
I'm holding
fair
the
enough.
phone.
I will call it here. Native lazy loading is
Pretty strong.
That's
Thank you, everybody. You made the right choice. Well done, you.
Oh. So there we go. We can set Mr. Summer there as the winner, and I lose out.
Now
look
that-
who we have here.
Look, seriously, you're my people, right? So
Well, like, I have no chance of winning this game now, so I should, like, pick a team. I'm going to pick Intel. I'm going to pick Team Intel.
You're picking sides, are you?
Yeah.
I'm going to hang out with
we're an international team.
Mr. Summer.
Team Intel.
Should we, just to be safe, should we award points to me first?
I have already done it.
Oh.
It's okay. Been in the background.
Okay.
Don't
Right.
worry. You've not been forgotten about.
It's important to me.
Been doing the points.
Very competitive.
Because we've been doing 2 points for that bracket, but this one is going to be worth 3 points to the winner.
Yes, it is.
And it is Intel stuff.
Up to you.
Paul, do you want to do a line about what we're, just to remind people?
Internationalization.
Important.
It's a thing. It's
Very
really hard work. This makes it so much easier.
What do you like better, people with hair or without hair?
You don't want to...
Vote for me now. He's just done it.
This might have backfired.
Actually, I have the best hair.
Let's just, should we make that official? So, what we're saying, it's no hair, is it?
Are you
just typing this
the
in
vote?
right now. And
What are you doing,
voting
Jay?
is hair?
Yeah, so you can, whatever sways you more.
I am aerodynamic.
Okay.
I am really good.
I'm sorry,
I thought you were Aero
this
Twist.
team.
Aero Twist is aerodynamic. It's in the name. And also, it's like it doesn't take me very long to get sorted.
Hang on, actually, as a man who's losing his hair, I've now had to switch sides. So you're on your own, mate.
I'm not losing my hair.
Yeah,
Wait,
there we
I'm
go.
really confused.
Yes! No, come on.
Oh, this is...
Intel, yes, Intel.
Now, you see, this is confusing me because I thought, like, the native lazy loading...
No,
it's-
because...
No.
Yeah, but you can solve it with other things. Intel, you can, but it takes so much code.
So what you're saying, with both of them, you can solve them with other things.
You
That's
can,
a great summary.
but the amount of code that Intel actually saves you is genuinely interesting. It's genuinely good.
So
It's
you tell me.
genuinely
So you
amazing.
tell me. Should we close it out? If anyone wants to change their mind.
Wait, just
3, 2,
come on,
2,
change your minds. You know
1.
you want to.
Oh, moving a little bit.
Closing it.
Yes!
So there you go.
Thank you.
That is not how I expected that to go, to be honest.
I
So,
really thought...
we have just found our first finalist.
Yes, and for that, Paul, you're really sort of running away with it. We're going to give you, what did we said, 3 points for that, didn't we?
Yes.
I have 0 points.
Yeah, just do better, Mariko.
I did all the work and I have 0 points.
It's all to play
Can't you
for.
just give me 1 point for Sweatos?
Do we do 1 point? Yeah.
Yeah.
The pity points.
Okay. Right, well, we have been on stage
Far too long.
far too long now.
Thank you.
Definitely.
So here, our next talk, here to talk about all things performance-y.
Oh, and C.
Performance-y.
Okay.
That's a word.
Yeah, okay.
Yeah. All right. Go on, just because you've got a point now. Please welcome to the stage, it's Addy and Nate.
Hey, Chrome Dev Summit. My name is Addy Osmani. I'm an engineering manager working on Chrome.
And I'm Nate Schloss. I'm a software engineer at Facebook working on web performance. Today, we're going to talk about performance patterns for building inclusive web experiences. Let's kick things off with Addy.
Cool. So any user can have a slow experience. It could be the site, it could be their hardware, or it could be the network. Now, have you ever watched someone that has poor network service? They usually like be staring at their phone, and then their arm just slides to go up and up and up and up, almost as if they're trying to pierce some force fields that will give them 4G. Now, I personally think that I probably have the worst network service here. If I go from one part of the stage to the other, if I just twirl around a little bit, I go from 4G to Edge. Edge being both my network connection type, but also my mental state. Now, we've all had user experiences that are fast and also plenty that are slow. So to support a web ecosystem that's inclusive of users who are both on low-end and high-end devices and networks, as developers, we need to start doing something. We need to start respecting the user's hardware and network constraints. You see, these characteristics really matter. Your user's hardware and their network type can massively impact the experience that they're going to have with your site. So let's talk about why that is. What are components that can contribute to that? Well, what's in a modern smartphone? We've got a CPU, memory, storage, a screen, and battery. Phone hardware can vary quite a lot. The hardware that's in your pockets right now can probably vary by quite a lot compared to the stuff that your users are accessing your sites on. L1, L2, L3 caches, all of these things can have an impact on the overall experience in pretty noticeable ways. Now, let's quantify this problem a little bit. Here is a visualization of the performance gap on mobile. What we can see here are the top 10 highest-selling smartphone sales for the first half of 2019. And what you'll see is that there's a huge gap between high-end devices and everything else. Like, it's about a 2 or 3 times slowdown if you're talking about the other hardware. Now, device characteristics matter quite a lot because one of the things we're doing is putting JavaScript increasingly into our sites today, a lot of it. And given that JavaScript is inherently single-threaded and more single-threaded than the rest of the platform, this stresses things like single-core performance. And so we need to care about things like the CPU. So if you're making sites that are only going to work on high-end hardware, you might be excluding some of your users. So this is something we've said for multiple years. If you want to build a fast site, use slow hardware. Alex Russell's been on the stage plenty of times saying the same thing, but I just want to remind you that that's one of the things that we need to just make sure we're constantly doing. Now, I talked about smartphones, but this problem of variance applies equally to desktops as well. There's a huge performance gap on desktop. Over here, we can see the CPU performance. This is using Geekbench data, same as the other slide. This is using Geekbench CPU performance data. And it shows us the highest-selling laptops on Amazon. And at the very bottom, I have a modern popular developer laptop, a MacBook Pro. And what you can see is that the devices that we're building our experiences on are so much faster than the devices that people are actually out there buying en masse. You can have old hardware that sticks around for years and years. People tend to have longer refresh cycles for desktop hardware. And there's just generally a huge performance disparity between low-end and high-end. So a question that Nate and I would like to pose to you today is, do we need to deliver the exact same experience to every user? We think that the answer is no. In a world with widely varying device capabilities, a one-size-fits-all experience doesn't always work. Sites that delight users on high-end devices can sometimes be very unusable on low-end ones, particularly in emerging markets and on older hardware. Now, we think that responsive design was a really good start, but we think we can maybe increment on it a little bit and improve it. So today we'd like to introduce this idea of adaptive loading. Now, adaptive loading is this idea that we build to support low-end devices first and progressively add high-end only features on top of it. This allows users to get a great experience best suited to their device and network constraints with fewer frustrations. So one core experience, everybody. People on high-end networks and devices get something that's just a little bit better. So let's chat about a few ideas in this space and how we can make it easier for everyone to give users a good experience on low-end devices. We're going to kick it off with a demo. So let me switch over real quick. All righty, let's see if this is working. Cool. So Paul, Irish, and Elizabeth earlier today, they mentioned this really neat YouTube lazy loading element that Paul had built for improving performance. And I thought it would be neat for us to actually try integrating that into an app and show you a few ways that we could improve on it. Before that, how many people here know what styled console logs are? All right, it's like 40% of the audience. So they basically look like this. They let us create these nice, fun, funky console logs. One of the really nice things about styled console logs is that we can also kind of abuse them to create our own console messages. So in my case, speaking after Paul Irish and Elizabeth Sweeney, but we're going to try to give you a decent demo of this idea. So here what we've got is basically a reimplementation of YouTube. It's using live YouTube data. And I'm going to keep the network panel open over here. We're going to navigate to a video. So let's go to this one real quick. And what we see is that 514 kilobytes worth of script are loaded for this experience. Now, imagine we were to swap out the core video experience here for something a little bit lighter. Now, I want to do something real quick to to show you what we're going to do. So we've got this little window debug thing. What we can see in green is the core content for this experience. In red, we've got all this extraneous stuff. We've got recommended videos. We've got comments. And I thought it'd be interesting to think about, what if you're on a slow network or a constrained device, something with low memory or fewer CPU cores? What if we were to do something where, we can navigate back to the main experience? We can emulate this. Let's go into fast 3G, right? And if we now go to the video page, what we see instead is that we've actually used that lazy loading element from Paul Irish earlier, and it's only loading up 3 kilobytes of script. But we're being very intentional with only shipping this down to users who are in the worst conditions. So we're going to talk a little bit about these ideas. I'm going to switch back onto the slides right now. Now, there are 3 or 4 key signals we'll be looking at for adaptive loading today. First of all, we've got network for fine-tuning things like data transfer to use less bandwidth. We've got memory for reducing the amount of memory consumption on low-end devices. CPU for limiting costly JavaScript execution, and reducing CPU-intensive logic. And we'll talk a little bit about client hints, and we'll talk about JavaScript APIs for doing some of this stuff. Now, to make all of this easier, today we're releasing a new experimental set of React hooks for adaptive loading that you can go and check out. If you're using React to build experiences today, whether it's React on its own or Next.js, you can use these hooks for everything from network, memory, CPU, to employ some of the ideas that we're going to be talking about in just a second. And by the way, all of these are built on top of Web Platform APIs. And so if you're using a different framework, if you're using Angular or Vue, Svelte, Lit, any of these things, you can still employ these techniques. It's just that we're going to be focusing on React for now. Well, thank you. Thank you, one person. So let's kick things off with adaptive media loading. Now, this is the idea that we serve low-quality images and videos to users, reducing bandwidth and memory consumption. So picture, I've got a site where maybe I'm shipping down videos to everybody, but do I need to? Maybe I could be shipping down lower-resolution images instead if your network can't handle it, if your device can't handle it. So you could picture a photo gallery application that's shipping those lower-res images or using less code-heavy carousels. You could imagine a search application where maybe you're limiting the number of media-heavy previews. You could imagine a news-oriented site where you're omitting some popular categories that maybe have preview images in there as well. And the way that we can determine network connection information on the platform is using the Network Information API. So the NetInfo API summarizes performance of a user's network connection. And on the web, it's what allows us to deliver experiences based on how slow or fast a connection is. Now, you can use this API via the web platform, and you can also use it for things like conditional resource loading using the React hooks that I just mentioned. So let's actually take a look at a quick demo of this. We're going to switch back over to the other machine real quick. And here we have an experience called React Movie. By the way, for all of the demos today, we're integrating adaptive loading on top of existing apps built by the community. None of this is just stuff that was written from scratch. You can employ these ideas in your apps today. So here we have an app called React Movie. And this is a sort of a movie discovery app. I can see all movies that are out at the moment. I can click through, and I can browse sort of thumbnails for them. But what you see is that this core experience is currently shipping 2.7 megs worth of images if I'm any casual user. We can employ adaptive media loading techniques and actually deliver an experience where if you're on slow 3G, so let's actually clear this out. This might take a hot second to load up, given it's so slow. But the idea that we're going to be trying to represent here, if it ever loads up, is that you can still offer the users an experience with slightly lower resolution imagery in a lot less bytes. So it's taking its time, Okay, it's getting there. But these are all lower resolution images. The overall payload size is significantly smaller than what we were showing you before. And it actually didn't take a lot of code to do this. We're just using 2 or 3 lines of additional code after importing in that network hook. And everything works the way you'd expect. So the next thing I wanted to show you, let's switch back over to the slides, please. So the next thing I wanted to show you was data saver aware resource loading. So the Save Data Client hint is something that is a request header that lets you deliver lighter experiences to your users who opt into data saving mode in their browser. And when a user has this feature on, the browser can request low-resolution images, it can defer loading some resources, and this is available as a JavaScript API, but is also something you can use via client hints. So once again here, you see we're using our React hook in order to achieve conditional resource loading. A company that's using data saving as a mode, they've got a custom mode quite effectively today, is Twitter.com. So Twitter is designed to minimize the amount of data that you use. They've got a really nice data saver mode. And when you opt into it, you can get anywhere up to 80% reduction in overall data usage for images on the web, and anywhere up to 96% if you're including things like disabled video autoplay. I thought it would be neat for us to try re-implementing something like the Twitter data feed. So we're going to go and take a look at another very quick demo. So here we have the Twitter feed. It's a simplistic version of it. I can scroll through this feed. I can see plenty of tweets, plenty of resources. And the overall payload size of this is something like 6.9 megabytes overall. So this is including high-resolution images, videos, anything else that's supported. Now, using this hook, or using just the web platform APIs for data saving, I can go and I can toggle this. And what you'll see is that we've switched out those high-resolution images for low-quality image placeholders. I can scroll through this feed pretty quickly. I don't have to be fetching the original images at full resolution. And if I want to see the full resolution image, I can just tap and get that same experience. Now, scrolling back up here, there is actually a video that has its autoplay disabled. This is by Mr. Doob, and I thought I'd play this for you. So this is basically what it looks like when we as developers have a nice payday. You're just like doing all your... I love that so much. My version of this is unfortunately a lot worse. Oh, great. Okay, live stage fail. Let's try this out again and see if the guys. Okay, all right. Okay, this is me. Cool. Very, very accurate. So let's switch back up to the slides for a second. Now, for a while, people have been asking for a media query for your Save Data. And although one doesn't exist just yet, there is an active proposal that's been made about introducing this idea of a user preference media query, prefers reduced data, that would let you design data-reduced variants of your site for users who express that preference. If you're interested in something like this existing on the platform, there's a link here where you can get involved in the discussion. I personally love to see something like this existing. Next up, let's talk about memory. So the device memory API adds navigator.deviceMemory, and it returns how much RAM the device has in gigabytes, rounded down to the nearest power of 2. Now, this API also features a client hints header device memory that reports the same value. And similar to before, it's relatively straightforward to use the memory hook in order to conditionally load different types of experiences. Now, I thought I'd show you a demo that's slightly different using this. Let's switch over to the other machine real quick once again. I discovered this really awesome website called Dixie. And Dixie do a bunch of consumer electronics. One of the things that they do is they sell mechanical keyboards. And on their site, they have this really nifty model viewer usage where you can kind of go and check out. This is nice. You can like spin it around. It's really pretty. But one of the downsides to this is if we go and we load up our dev tools, we go to the network panel, and we try to reload this experience up, is if we organize things by size and just go to the very top, you'll see that this 3D model is actually almost 5 megabytes in size. Now, in addition to that, it also uses quite a lot of memory on low-end devices to get something like this running. On high-end devices, on desktop, it's perfectly fine. But for users who are on those low-end devices, what if we were to do something like, let me reload this page real quick. What if we were to do something like use memory signals in order to decide whether or not to just send them down a static image? Like, we'd save on multiple megabytes worth of resources being sent down to those users while still giving users who are on high-end devices a really, really slick experience. I personally love these 3D models, love Model Viewer. Let's talk about JavaScript. So adaptive module serving is something I'm excited about. And this is this idea of shipping a light, interactive core experience to all of your users, and progressively adding high-end features on top. So if a user's device characteristics and network can handle it. Now, it's this device awareness that takes progressive enhancement to the next step. So on high-end devices, we can conditionally be loading more highly interactive components or more computationally heavy operations. You could imagine servers of the future being smart enough to use client hints and other signals that come from the web platform to decide like what code to send down to their users. So bundles that are the core experiences versus bundles that are a little bit heavier. In this example, we're looking at something like an e-commerce site, where the core experience represents sort of the product images, the cart experience, and the higher-end ones can include things like zooming into images, related products, videos, an AR version of the experience. You go crazy. I wanted to demo a slimmer version of this idea, adaptive code splitting and code loading. So actually, before we go into that, some of you might be familiar with React.lazy and Suspense. These are basically primitives that help you do things like add code splitting to your React apps and then define fallbacks for that content as it's loading up. And you can, in fact, extend React.lazy so you can get network-aware or memory-aware or data saver-aware code splitting. So in this pattern, what we're doing is we're basically doing a check for the user's network information effective type values. And depending on those values, we're able to generate different chunks for people who are on 3G, people who are on 4G, maybe a light experience, a slightly heavier experience. I wanted to show you an example of this real quick. So eBay are a company that are exploring this idea of adaptive serving. And they're able to conditionally turn on and off features like zooming if a user's hardware or network conditions don't necessarily support them well. So let's switch back over here. We decided to implement a version of this. And what you can see is this is a lot like eBay on desktop. And if I hover over this product image, I can see this in very high resolution. I've got this nice additional magnifier dependency that's being pulled in. But overall, we're shipping down about 62 kilobytes of JavaScript to our users. Now, picture that I wanted to, look at what this might look like if I'm on a narrower viewport site. So let's imagine we're in this situation, and I'm loading this back up. Now, in this case, we're actually only loading 45 kilobytes worth of overall script. We don't have that same magnifying experience on mobile. What we're doing is we're just shipping users down an experience that just shows them the image, and at most, maybe we show them a modal. So people who are on those higher-end situations, they can get the slightly more enriched version of this. And next, let's talk about CPU. So desktops and smartphones can have multiple physical processor cores in their CPU. And each core can run more than one thread at a time. So a 4-core CPU might have 8 logical processors. And in order to determine this insight from the platform, you can use the Hardware Concurrency API. Now, there's a hook available for this as well that allows you to use conditional resource loading, very similar to some of the others. And one of the downsides to this, one of the values of this is that you can use it to do things like determine, the optimal worker thread pool if you're using web workers in your application. The platform does have, however, limited information about CPU. And I think that it's interesting to consider, should we have more? Could that unlock other use cases? Another pattern is adaptive data fetching and prefetching. So whether it's on the client or the server, reducing the quantity of data that you're sending down to users can decrease overall latency. And adaptive data fetching can use signals like the slow network to send fewer results down to your users. Now, we've been talking about a bunch of different patterns today. And you might be wondering, OK, well, we're seeing a few folks who are using these in production. Is anybody using most of these in production? And one example of a company that is Tinder Web. So Tinder Web and Tinder Lite are using a number of these patterns in production to keep the experience fast for everyone. If a user is on a slow network or has data saver enabled, they disable video autoplays. They limit route prefetching, so prefetching the additional routes the user might navigate to across the experience. And they're also able to do things like limit loading the next image in the carousel, so they just load one at a time when you're swiping. They've seen some really great stats off the back of this, great improvements in things like average swipe count. So for Tinder Lite, they saw 7% more swipes in areas like Indonesia off the back of using some of these signals. And finally, we've got adaptive capability toggling. Now, this is this idea that instead of serving animations down to all of our users, for people who are on lower-end hardware, maybe we consider not shipping those animations at all or throttling the frame rate in some way. So what we're going to do is demonstrate using this with client hints. Now, client hints are something I've mentioned a little bit in other parts of this talk, but they're a mechanism for proactive content negotiation. The client advertises a set of hints via HTTP request headers, and the server provides hints that adapt to the served resource. And it can be extended to a number of different use cases. Now, one of them is helping automate the negotiation of optimal resources based on the client's data saver preferences. And I've got a quick demo using Next.js and client hints that I'm going to switch to right now, just to show you this idea in action. So here we've got adaptive animation. Imagine that we've got a blog site or an e-commerce site of some sort where we've got a number of different cards worth of content. Now, me on my high-end device, lots of memory, I can probably handle things like nice navigation transitions pretty okay, and they look relatively smooth. But if I'm on a low-end device, I've tested this out on Moto G4s, you can end up with pretty choppy experiences. Maybe it doesn't make sense to animate on those devices instead. So one thing we can do is we can simulate all of those conditions that client hints allow us to do. And if I now try transitioning, I just get a very simple, basic navigation, the same type you're probably used to seeing in many single-page applications. But we're still able to give everybody an experience that best suits their hardware and network characteristics in these cases. So I'm really excited about that. Now, I'm going to invite Nate to the stage in just a second. He's going to talk a little bit about how Facebook uses these patterns in production. And one of the areas that we don't have a great solution for on the platform just yet is this idea of device class detection. So you might have noticed across some of these ideas, we've been basically bucketing things into, you were on a slow site, you're on a slow device, or you're on a fast device, you're on a slow network, you're on a fast network. Now, one thing we could do to build like an ultimate solution around this stuff is have a setup where we're taking a look at the user agent string, determining like what is the hardware we think you're on. We could connect that up to Geekbench performance data, and then we could decide based on thresholds, is the combination of your RAM, your CPU, and your CPU score considered low-end or high-end? Now, this is very difficult to duct tape together in a way that makes a lot of convenience today. But I'm really excited, actually, for Nate to talk a little bit about how Facebook tackles this problem in a little better ways. So please join me in welcoming to the stage Nate.
Thanks, Addy. So one thing Facebook recently announced is a redesign of the website. We're calling this FB5. One of the cool things about going through and redesigning the site is we've been able to take a lot of the things we've learned over the last few years about adaptive loading and different types of hardware and making sure the site responds correctly to that and really integrate that into the core of FB5. One of the core principles we considered when trying to go through and design FB5 is we didn't want to just build a site that responded based on screen size. We wanted to build a site that actually adapted based on the user's actual hardware. So actually changing what loaded and how the site ran based on what hardware it's on, not merely responding based on changes in the screen size. There were a few steps that we took to implementing this. The first step is we actually needed to define consistent buckets for how we were talking about different types of hardware and how we were considering our hardware classification kind of across the site, across different teams, across different products. The next step was integrating these buckets into all of our logging, looking at it in our performance logging, our general metric collection logging, our engagement logging, and really making sure we were able to see a holistic picture of how things were working based on these different types of hardware. Next, once we actually can see the full, complete picture and understand what's going on for different users in different situations, we can actually adapt loading and change how the site runs, how it loads, what happens based on the hardware. So on mobile, grouping hardware is not that so complicated. The mobile UA actually just tells us what this device is. And then there's tons of public data sets where you can actually plug in which type of device it is and get information about the CPU clock speed, how many cores, things like that. And then we can use this predefined concept of year class. Year class is a very popular framework on native. You can use it basically to figure out in what year would this device have been considered groundbreaking. So by looking at year class and by looking at kind of the public information about a device and specifically what this model is and how fast it is, we're able to have like a general way to talk about different devices across both the web and native. And that's pretty powerful. So on mobile, we can just look up exactly what this device is and kind of get all of its hardware and performance information. However, on desktop, things aren't so obvious. Sure, the user agent tells us, all right, is it a Mac? Is it a PC? Is it 64-bit? What browser it is? Most of the time, everything is 64-bit nowadays. It doesn't really tell us much about the actual hardware that the user is on right now. So what do we have? Well, we have navigator.hardware concurrency, which tells us generally how many CPU cores. And many browsers also give us navigator.device memory, which tells us how much RAM. So maybe on desktop, there's a way we can use these two fields and figure out some generalized buckets that we can apply consistently across different devices and different metrics. So the first step for doing this is to actually log hardware concurrency and device memory everywhere. Once we actually have these in our tables, we can build metrics and understand how things are different based on these devices. So once we have done that, the next step is actually group by hardware concurrency, device memory, OS, when looking at our different metrics, and basically come up with charts to really understand what the full picture is like. Once we did this, we start to see natural bands for different types of hardware and how they're performing and kind of different barriers. So at Facebook, once we did this, we came up with 5 different kind of classifications for devices, and the heuristics we use for them actually vary across different OS and browsers. So this is something that we did some analysis to figure out where the natural bands were. Once we figured out the buckets based on the groupings, we're able to apply it kind of like deep in our data sets and log it everywhere, and actually have a consistent way to talk about different performance and different device types across different metrics and across different teams. And this is pretty cool, because when integrated into performance logging, this hardware class reveals a much more complete picture. We can actually see everything that's going on, understand how the experience varies for different types of users in different situations much more holistically. So take, for example, this chart. So if you're just looking at the average, it looks like basically your performance stayed the same. Maybe it got slightly worse, but overall it looks like things are fairly consistent in performance. But when we break stuff up by hardware type, we can see that maybe on the 6th we had an improvement ship for low-end devices. However, there was a large regression for mid-range devices. The way low-end devices and mid-range devices are going to load your site is going to be very different. Low-end devices are often going to be blocked on parsing JavaScript, actually executing the JavaScript and just like execution. Well, maybe mid-range, they might be blocked on network or other different bottlenecks. The way users interact with your site is going to be very different on both types of devices, too. Low-end users might do different, engage with your site in different ways in different spots than mid-range users might. So you might see your metric shift as your mid-range users end up in a slower performance class, but you won't actually know why. So by breaking stuff up by different hardware type, you're actually able to see and pinpoint where your regressions are happening. The other thing that this can help you with is shifts in user population. Let's say that a low-end device suddenly goes on sale in an emerging market, and all of a sudden you have a lot of users on your low-end device. If you're just looking at the overall average, you might think, oh, I have this big regression right now, when in reality, there's just more users taking advantage of the promotion on a low-end device. So by breaking stuff up, you can actually see if you're loading consistently or not, and kind of counteract changes in just populations on different types of devices. So once we have this kind of core, this core metrics, and we're able to break it up and have a consistent way and understanding of what different types of hardware are, we can actually consider this in our core frameworks. One of the first things we did is we looked at animations. Animations take time to render. The browser will attempt to paint a frame, then if it can't, it'll just throw out all that work. But every frame the browser is attempting to paint something and render an animation, it could be doing something else and actually helping you load your page. So on low-end devices, animations kind of looked like this. They were somewhat janky. They would render like a frame, wait a while, show another frame, and eventually stuff would load, but it's not a good experience, this kind of animation. One of the first things we did is we just stopped shipping animations in many instances on low-end devices. This enabled many more users to finish loading the page and actually engage with the site much more, because they already weren't getting much benefit from the animation that wasn't really loading. And now that wasted work is no longer happening, and they're actually able to see the page much quicker. Another thing we do is on our mobile website. Our mobile website, we have a totally different site for Android phones and iPhones that have like touch screens and have powerful CPUs that can run a lot of JavaScript, versus feature phones that maybe don't have as many powerful CPUs and can't run JavaScript as well. Our feature phone site is mostly static HTML, a little bit of CSS, very few images, and it's really optimized for this like low-powered device case. Even when the feature phone screen is big, even when the feature phone has a touch screen, this is an instance where we're not just scaling the site based on screen size. We actually have two totally different experiences based on the underlying hardware and really optimized for that hardware. One of the cool things we're doing too, and especially on the FB5 site, is we're actually taking advantage of the fact that there's this trade-off right now on the web between loading quickly and responding quickly. When you're loading your site, often you get advice to chunk up your JavaScript that's needed to load the site into different chunks and yield to the browser in between each chunk so the browser can dispatch any events that might happen. So if the user clicks on something, you don't actually have to wait for the entire load to finish. You can respond to that event as soon as the click happens. On high-end devices, yielding to the browser after each chunk is fairly cheap. The browser will quickly see there's no event and just go back to running your JavaScript. However, on low-end devices, this can be somewhat slow, and it can often take quite a bit of time. So there's a trade-off right now where you want to chunk up your JavaScript into small chunks, but on low-end devices, if you make two small chunks, you're actually going to slow down the overall experience by quite a bit. So one thing we've been able to do is in React Concurrent mode that Adi talked about earlier, one of the core things is this concept of a scheduler. Now, this is an experimental API. It's almost definitely going to change. But one thing we're doing right now is if it's on a low-end device, Scheduler has this concept of forcing a frame rate. Generally, Scheduler in React is going to try to schedule each frame and run at whatever the browser is currently running at, so 60 FPS, 30 FPS, something like that. However, by forcing a frame rate, we're able to basically tell React, all right, ignore what the browser is trying to do right now and just take longer. Run at 15 FPS and actually run more JavaScript each frame so the user can actually load more of the site before we check for each event. So yes, some events interactions become slightly slower, but overall it's a much better experience for users because most users are just waiting for your site to load, and this can happen now much, much quicker. One interesting thing here too is that hopefully eventually this trade-off goes away altogether with this new API isImp appending. Eventually, we hope isImp appending will kind of ship everywhere. It'll just be a quick, cheap way to check, is there input right now? So then this trade-off will be gone because we can just run all of our JavaScript during loading, and we don't actually have to block stuff up. We can still be interactive. Hopefully, this gets integrated into React too. So if you're using the latest React, and once this ships, you should just be able to kind of get this for free. So by using consistent definitions for our bucketing and our logging and adapting based on those definitions consistently, we're actually able to share this understanding of how the site works across different teams, across different orgs, and really figure out like what is this overall picture that we're seeing. So when metrics change based on something one team does, we know that it's based on this kind of consistent hardware definition, and it's a lot easier to pinpoint changes and see what's going on. Now I'm going to invite Adi back to kind of take us home.
Thank you, Nate. Had some better network service in the back. So that's it for adaptive loading. Today we talked about adaptive media loading, code serving, data fetching. In general, a lot of these ideas have got some promise, and we're very excited about them. They do have some potential drawbacks that are worth being aware of. Adaptive loading does use this idea of often point-in-time information about the user's device and network constraints. And you do want to keep in mind like what impact is that going to have on things like HTTP caching. So just be very careful with adopting these techniques. I do think they can have a lot of promise, but that nuance is probably useful to talk about as well. And adaptive loading isn't like, it's not this groundbreaking huge thing, right? It's an incremental practice. Over many years, we've been talking about this idea of trying to increasingly become more lazy first with our content. And so adaptive loading is really just an incremental pattern on top of those things. And so in general, even if you take nothing else away from this talk, try to reduce, defer, and coalesce the resources that you're serving down to your users. Ultimately, what we're trying to do with these patterns is build experiences that have inclusivity in mind. Build a core experience, ideally, that works great for everybody, and toggle or layer on features that can make it even more awesome if a user has enough memory, CPU, or a fast network. So that's it for adaptive loading. Thank you.
Thank you, thank you, thank you. Right.
Well,
shall we do that again?
Well, if we look at the bracket, We have finished one half, and we are now
moving on to the
moving
other
over
half.
to the other side, aren't we? And so,
How is that? Is it again?
hang on. This is what I wanted to press.
Yeah.
There we go. So this is the matchup we currently have to figure out. And so, as before, we will have to pull the feature that we are going to champion. So Marika, why don't you start?
All right.
What you have to champion for this round. You can all already get your phones ready. bigwebquiz.com. There is going to be a vote soon.
Yes! Class Fields! Yes!
Wait, which one?
Class Fields.
Oh, that's a good one for
This is a very good
Class
feature.
Fields.
Very good feature.
It's going to be tough for me.
Yes.
But I'm going to try. This feels like a good piece. I got this in the bag.
What?
Numeric separator.
Oh, that's good.
So
Did you want that? You wanted that one,
I wanted
right?
that, and I got it, and I think I might have just won the entire.
I'm sorry,
tournament.
Class Fields is the best.
All right, you go first.
Okay, start with Class Fields. So, JavaScript classes, you have to do this weird constructor thing, right? Now, you only thing you can. Go again. Now, you don't need to do this weird thing. You can just write it like this. It's very good, saves you typing. But not only that, you know you do this thing where underscore counter is obviously private because it starts with underscore, so nobody's supposed to touch it, but people touch it anyway, right? Now, and this is how new this is, you can use a hash to make it really, really private, and it's really new because syntax highlighter break. It doesn't know how to process it, but it is available in Chrome now. So, see, it's private, so you can't access it at all. It's
Amazing.
perfect. It's great. It's great.
All right, I hear you. But let's talk about this. Who has ever felt the problem where you look in the code
Big number.
and you see this and you know, I don't know what it is. And now with numeric separators, you can do this. And you know immediately, at a glance, this is 10 septillion. Amazing. And I think this will change the way that we write code in the future. And so, get out your phones. I mean, we can skip the vote, really.
Yeah.
We don't need the vote. This is clear. Because we're gonna do the vote because, you know, it's fun, and also I wanna feel the validation. Let me know which feature you...
Clearly, I mean, everybody writes class. Wait. Everybody writes class. It's the best.
This is not
Everybody
supposed to
benefits.
happen.
Everybody benefits from this feature, my feature.
I wanted to win.
How many times have you written that big of a number in your code?
I don't know what kind of code you write. But that's just my line number. Fine. Fine. It seems...
Yes!
It seems...
I get a point. I get a point.
It should have been like this.
No.
Been like
No.
Fine.
Yes,
You're
yes,
advancing.
Yes.
And as a result, you have scored your first legit
Oh, I'm
point.
sorry. I earned it.
All right.
Right.
That was enough of us.
Yeah. Oh, wait. Before you go, let me check. Good. It's charging.
Oh, good.
Go. Yeah.
I've been looking forward for the next talk for quite a while. The speaker
I've been
is someone.
worrying about this next talk quite a while.
The speaker is a really good friend of mine, and I looked up him as a speaker and a person. Please welcome to the stage, me. All right. That's off to a good start, isn't it? The main thread is overworked and underpaid. And yet all of us run their code almost exclusively on the main thread. And I'm not like wagging my finger at you. Like, this has been the norm. This is the best practice on the web currently. Because, and it makes sense, because if you had the choice between driving your car on the main road or on a side alley, you would drive it on the main road. And so what I'm really saying is, the main thread is overworked and underpaid, and the name is bad too, really. So what is this all about? Well, this whole thing started to become a topic for me when I was researching people coming online for the first time. 50% of the world's population are currently online, which means that 50% are not, or at least not yet. These 50% are now slowly coming online through a vast variety of devices. For example, feature phones. They have been incredibly popular for a long time in emerging markets like India. They're incredibly cheap to manufacture, and as such, they can be sold for a very low price tag, bringing more people from the world of offline to online. So the JioPhone that you can see here on the very right is running a fork of the old Firefox OS called KaiOS, which is based on Firefox 42. So that isn't a recent version of Firefox by any means, but it is modern enough to browse the current web. And this phone only costs $15, which means the phone is incredibly popular and makes the mobile internet accessible to many more people than before. And these people coming online for the first time with comparatively low-powered phones are sometimes referred to as the next billion users, or NBU. And I know that many of you hear this and might think of emerging markets like India, and that is absolutely not wrong, but it's also not the entire story, because there are also people in America. Now, they might not be coming online for the first time necessarily, but they do spend their time on devices with very similar performance characteristics. For example, the Nokia 2. The Nokia 2 is a great phone because it is nice looking, it is very cheap, and it runs modern Android. However, the Nokia 2 smartphone is as smart as Iron Man is iron. There is like a resemblance from the outside, but it's really made from something much more lightweight. So now, these Americans that have phones like the Nokia 2 have these phones because they're subsidized. These phones are available at little or almost no cost for people living below the poverty line. And that is around 16% of Americans. And similar programs exist in other countries in the Western world. So to compare, look at how the iPhones have been climbing the single-core benchmark over the years. They're absolute beasts, and they continue to keep getting faster. The Nokia 2, on the other hand, is down here. It came out in 2018, but is pretty much on par with the iPhone from 2011. That's 7 years ago. It's ancient for technology standards. And yet, this ancient hardware runs a modern version of Android with the most recent version of Chrome. So you get all the modern new APIs, but on old hardware. So you should be looking at the Nokia 2 or a similar phone to see how your web app feels for up to 16% of Americans. Or to phrase it another way, the Nokia 2.1 is probably representative as a 95th percentile phone for America. If your app runs on this phone, your app will be usable for 95% of Americans. And that's just America. Globally, the percentiles are skewed much more towards the low-end spectrum of phones. Either way, you should try out this phone and see how your web app feels. The bottom line is here that even in the wealthy Western world, we need to care about hyper-constrained devices with crappy CPUs, pretty much no GPUs, small screens, and sometimes even no touch. And more precisely, we need to start caring about people who are constrained to these kind of devices. And as an exercise in this, we wrote Prox earlier this year. It's a Minesweeper clone as a PWA, so it has all the PWA goodies like offline and nice graphics. And it was projected that around 400 million phones, feature phones, would be sold in 2019 alone, so we explicitly wanted to include that audience in our target audience so that they can play on these devices as well. So we wanted to see what it takes to make a game run on devices like this, these hyper-constrained devices, without writing a completely separate version of the game. And a couple of early experiments showed that we are really pushing the performance boundaries of these devices by something as simple as a table with a couple of buttons and some JavaScript to update the table. The main thread was completely overworked. So what is the main thread? Since the beginning of browsers, websites only ever had one thread. In the early days, the entire browser just had one thread because you just had one window. If you wanted to surf multiple websites, you would start a completely separate second instance of that browser. Since then, we have at least gotten one thread per tab, kinda. There's exceptions. But at the same time, the web has evolved from static documents with a couple of styles and images to full-blown dynamic applications. And everything that is required to make this jump from docs to applications has just been added to this one thread, to the main thread over time. And as a result, the main thread ended up with a lot of responsibilities when loading and running a website. So it has to process the events that the user causes by scrolling or interacting with it and figuring out if there's any JavaScript that needs to be run in response to this event. If there is, the browser needs to run that JavaScript. Then figure out if the JavaScript changed the styles and which elements are affected by the changes in these styles. Then it needs to do layout to figure out where the elements end up where on this page, and where the text flows and breaks. And it needs to paint everything, meaning it needs to color in the elements' backgrounds and the borders and the images and the text and the shadows. And lastly, it needs to finally composite all these individual elements into the final image that you see on your screen. Now, to put that into context, we want to ship 60 frames a second, because that's what it takes to make scrolling or animations feel smooth to, well, humans with human psychology. Not hitting that goal is what can make your web app feel like low quality or unpolished. Failing to hit a consistent 60 FPS is one of the bigger factors in why web apps feel worse than a comparable native app. So if we want to ship 60 frames a second, the entire system can spend at most 16.6 milliseconds to finish each frame start to end. Most of these tasks are run by the browser, and so you really don't have any direct control over the duration. The only thing where you have direct control over the duration is your JavaScript, the amount of code that you run on the phone. But it's not just that, not just the JavaScript, but also the amount of work that the JavaScript causes. So it's really hard to tell how much work a piece of JavaScript will cause. And that's why it's so important to test on real devices. And here you might realize the device that you choose for testing will have a massive impact on the results that you get in your testing. So while you test on your iPhone or even your laptop, it might look like this, and you feel, oh, that's fine. But then you check on Emoji 4, and it looks like this, which is still fine, but definitely less headroom. And then you run your app on, say, a feature phone or a Nokia 2, and suddenly you're way over your budget. And again, the budget was 16 milliseconds because that's how much time you have when you want to fit 60 frames into 1 second. But recently Google brought out the Pixel 4, which has a 90 Hz screen. So on that device, you only have 11 milliseconds per frame. On that note, 2 years ago, Apple published the second generation of the iPad Pro, which has a 120 Hz screen. So that means that, yeah, you only have 8 milliseconds. We barely make it through our calculating styles here. Did I mention that there's desktop screens with 144 Hz? Yeah, we're in trouble here. So on the one hand, we have hyper-constrained devices that are not getting faster, but cheaper. And at the same time, us wealthy Westerners getting the flagship phones get faster hardware, but also screens that want to ship more frames per second. So both of these developments leave us with less and less time to spend on the main thread for our code. We can't just keep putting code there without thinking about it. So really what I'm trying to say here is, if we want to follow the Rail guidelines, we are imposing budgets on ourselves based on how an app feels when a user uses it. So basically based on human psychology. And that is completely independent of the device that the user holds in their hands. And then we write some code, and we throw it all at the main thread. And every piece of code we run consumes a piece of our budget from the main thread. But how much is actually dependent on the hardware, and as such, is completely device dependent. So we are setting ourselves up for failure here. We have no control over the environment that our app will run in. So the question is, the main thread is completely unpredictable. What takes 2 milliseconds on a modern flagship phone might take 20 milliseconds on the next low-end phone. How can we escape this unpredictability? Looking at native platforms like Android or iOS, they provide threads and patterns around and on top of threads, and have done so for a very, very long time. Basic threading often looks like this. This is a snippet that would work like this in Java or C#, but most other languages are similar, where you just give a thread a function, and now that function will run in parallel to the rest of your program. You can access the same variables from both threads, and to make sure there's no race conditions, you can use mutexes or semaphores to synchronize access to these shared resources. In terms of higher-level abstractions, iOS, for example, has Grand Central Dispatch, a scheduling service, which allows you to think in tasks. Here's an example from Swift and how you use Grand Central Dispatch in Swift. In this case, we want to update a label in our UI with a new text, and to know what goes into the label, let's say we have to hit the database or the network. So we schedule the load article text function that does this in the background, so it runs independent of the main thread and with a lower priority. And once it is done, it will schedule another main thread task that actually does the assignment to the label, because only the main thread can access UI elements. This is what I would love to have for the web. However, JavaScript as a language is incapable of providing these kind of threads. JavaScript was designed around the concept of a single thread. And we can't just add threads and shared memory to JavaScript because it would actually break everything and set it on fire. So instead, we have to isolate the concept to a dedicated type like shared array buffer and provide parallelism through workers. Now, shared array buffers are fairly new, but workers are actually not new at all. They have been around since roughly 2007 and had wide support in every browser since 2012. And just to make it clear, web workers are something very different from service workers and worklets. They share some characteristics, but be careful to not conflate them. In the context of this talk, I'm only talking about web workers. So workers, in case you don't know, are a bit like as if I opened the browser twice, but one of them is kind of headless. So they're completely isolated, no variables can be shared, and they run in parallel. Now, in terms of code, you create a worker by passing a file to the worker constructor. And that will basically spin up the isolated worker that you can, the second browser without the headless version. You can still communicate with it by sending messages. And the value or the message you want to send is the parameter for this post message call. That value will now be copied to the worker, and to receive it, you must register a handler for the message event. The value can then be read on the .data property on the event, and the worker is, of course, allowed to send a message back to the main thread with the exact same API, and you receive it on the main thread again with the exact same message event handler. And that's all you got. That's all you can use when you want to use workers. Now, that might seem kind of OK. So far, workers have historically only been used for move a piece of heavy work away from the main thread. And the worker only exists for the duration of the main thread. For example, in Squoosh, we did exactly this. We spin up a worker, we load our WebAssembly-fied image codecs, we send over a bitmap, WebAssembly does its thing and responds with the encoded image, and then we terminate the worker. We're done with it. It's just a one-off worker for a single task, a single-purpose worker, if you will. However, things will get unwieldy quite quickly when you want to offer more than one operation in a worker. To get back to our previous example, what if in addition to addition, we also wanted to add subtraction? Now, we have to not only encode the parameters into the message, but also the operation that the worker is supposed to execute. And that has implications for the complexity of the worker. Because now we need to not only introspect the operation, but also dispatch the parameters to the right piece of code that actually does that. And now what if, while the first operation is being calculated in the worker, the main thread sends another operation? How do we know which response maps to which original request? We have to now do bookkeeping with IDs, and it is not great. If you've ever worked with threads in any other language, coming to JavaScript and workers is going to feel really bad and feel very complicated. And I think that's one of the main reasons why workers haven't seen enough adoption on the web to this day. I actually believe that post message has been a bit misunderstood, and it could actually be a strength if you build something around that message passing pattern. For example, the actor model is a perfect fit here, and Paul Lewis and I talked about this here at CDS last year, and you should check that talk out if you're interested. But since we already talked about it last year, I want to talk about a different approach this year, and this is with libraries like Comlink. Now, Comlink is a library that removes the conceptual overhead of communication with the worker. Its goal is to let you use workers without actually thinking about them. So through some convoluted proxy magic, Comlink allows you to share variables between the worker and the main thread, almost like the normal programming languages that are out there. So for example, I can import Comlink into my worker, and I can define a set of functions that I want to expose to the main thread. And then on the main thread, I can also import Comlink and wrap the worker and get access to these exposed functions. The API variable here on the main thread will behave exactly the same as the one in the worker, except that every function will now not return a value, but a promise for that value. And in combination with async await, it barely makes a difference syntactically, though. And so this is exactly what we used in procs to move parts of our game into a worker. But now the next question is, which parts did we actually move? Because one of the limitations that many people point out is that workers do not have access to the DOM. And actually, they can't access a whole bunch of APIs. So depending on whether your app relies on access to some of these APIs, you might not be able to run most of your app in a worker. So really, the title of this talk should be "The main thread is overworked and underpaid, the name is bad too, and yet sometimes you don't even have a choice." At that point, you have to chunk your code that is running on the main thread to make sure with APIs like isInputPending that Eddie and Nate talked about. But again, it's really hard to know at how small the chunks should be because devices are so widespread in their performance metrics. And also, just because we cannot move everything doesn't mean we should abandon the entire effort altogether. Every small piece of code that we can move buys us a little bit more headroom to make room for the stuff that we have to run on the main thread, like access to the DOM, because the DOM is not available in a worker and therefore is bound to the main thread. And I'm pretty sure all our apps have UIs. And again, this is not an alien concept. Both Android and iOS do not let you access your UI from anywhere but the main thread. So let's go back to the Swift example that we had earlier. If we could just go to the main thread just to change the text of a label. If we were to skip that step, the app would crash. They actively enforce it. You cannot do that. You cannot access your UI from anywhere but the main thread, which is actually why both iOS and Android often call their main thread the UI thread. And I find that really helpful because it tells you what should be there and what should not be there. One of the struggles I often see is that current UI frameworks on the web are the center of your universe. They are the entry point to your code, and they are the overall orchestrator of everything. Anything else that you want to use in your app ends up being a component within that UI framework. And again, it's not something that we can blame UI frameworks for. This is how it's been on the web since its inception. That has been a best practice, or even the only choice. UI frameworks think in UI components and are inherently tied to the UI and the DOM. And as a result, workers are not very useful from a UI framework's perspective. And I think we can move forward here by separating these concerns. I think we should try to use the UI thread for UI work only. And UI frameworks do UI work. They're allowed on the UI thread. They belong there. But many other things can actually go somewhere else. And that's the mantra that we followed for procs. We actually distinguished between visual state and game state. Or to categorize it another way, we had the main thread, which runs our two rendering engines. Yes, we have two rendering engines, one using WebGL and one using Canvas 2D, because not all phones actually have WebGL like these feature phones. And this code handles states for animations and transitions and small things where we want to be really snappy and responsive. The code is small and really, really fast. The worker runs the game logic and is purely computational. This code is longer and can actually run longer or even in a blocking fashion. So note there's two kinds of state, UI state and app state. The separation has proved quite useful to use, but is somewhat of a change in a mindset. And now, this might sound familiar to some of you, because what we did up doing here is pretty much use something that is very similar to the Flux pattern, as in Flux Redux. And I found this realization really interesting, because to me it kind of means that many apps that use Flux or Flux Redux might actually have a pretty easy time to migrate to an off-main thread architecture. In case you don't know it, this is kind of what the Flux architecture looks like. It is kind of implied that only the view is supposed to do the UI work, and as such, it should run on the main thread. Then the UI emits actions. The actions are received by a dispatcher, and the dispatcher then kicks off the functions that manipulate the state according to the action, and the new state gets stored in, well, the store. And this is the important part. All of that can run in an off-main thread environment, or more specifically, in a worker. Now, no matter how much processing the dispatcher has to do, it does not block the main thread. It could even run a while true loop. The UI would stay responsive. The user can keep interacting. So if you use Redux or any other form of Flux pattern, I wrote a blog post on how to put Redux in a worker, which might be of interest to you. Now, if you want to adopt an off-main thread architecture, I want you to be very aware that off-main thread architecture will not make your app faster. It will make it more reliable, because we're really just moving the same amount of work to a different thread. The overall amount of work stays the same. If anything, it might actually get a tiny bit slower because of the additional communication overhead between the worker and the main thread. The difference is that while the worker is busy running whatever logic you have, the main thread stays free and available to process user interactions and do scrolling and do all these kind of things while JavaScript is running. It's often better to make the user wait a little bit longer than to drop a frame. The time to drop a frame is on the order of milliseconds. The time to make a user wait is on the order of hundreds of milliseconds. And so adding thread helps to process state change is less risky than squeezing more work into the next frame, especially when the amount of time that you cause on the main thread is so unpredictable. Now, of course, off-main thread can make your app faster because phones have multiple cores, and with workers, we can make use of all these cores in parallel. So if your app's logic is parallelizable, you should go ahead and reap the benefits. However, do keep in mind that on phones, it's only often 1 or 2 cores that are actually fast, and all the other cores are a lot slower. So it's actually hard to estimate what the benefits are going to be. And for this talk, I want to focus on risk reduction, because I think that's really the key word. I see off-main thread as a means to reduce risk, make your app more robust in the face of adverse runtime conditions. It's not about parallelization for me. It's about improving my micro-benchmarks. And in Prox, we actually have a pretty extreme example of this. Let's look at this. Here we have a version of Prox where everything runs on the main thread. No workers are in use, and the timer starts when a user taps one of the fields on the screen. You ready? Go. The game engine is now figuring out what needs to happen, which fields need to get revealed. And during that time, the UI is frozen. No animations, no scrolling, for 6 seconds in total. That's pretty bad. Now let's compare this to the game running on the same hardware, but with our off-main thread architecture, with workers. Ready? Go. We see an animation. We see, actually, that the game engine is working. And during all this time, the UI is responsive. The user can scroll and tap and keep playing. Basically, the user is getting feedback that something is happening, a very basic UX rule. And here's why I say it's an extreme example. The game takes almost twice as long to reach the same state. Now, that sounds pretty bad, doesn't it? But the question is this really the number that we should be looking at here? Is the question, how quickly can we get this work done? Or how can we make the game feel better? Because let's measure how long it takes for the game to give the user a visual response. On the version without workers, we saw we had to wait for 6 seconds for the task to finish. And since it was on the main thread was completely blocked. So after 6 seconds is the first time that we actually can cause any change. And that's exactly what the number shows. When we use workers, we keep the main thread free. And we can use that freedom to update the UI while the game logic was running. So the first update actually happens 7 frames after we tapped, which is roughly 100 milliseconds, and so perfectly in line with our Rail budget. So the question is this, it takes twice as long, a big deal? Yeah, it's a big deal, but it's also a very conscious trade-off. And it's also important to note that the slowdown is not because we're using workers. It is slower because we are using the freedom to ship more frames than the other version, which shipped no frames at all. And shipping frames on these low-end devices is very expensive. And it looks very different if you run the exact same code on a modern piece of hardware. Ready? Go. That's it. You can see it's pretty fast, so we can give the users of hyper-constrained devices a better experience without penalizing the experience of flagship phone users with the same code base. To simplify, really, slower does not always mean worse. As an anecdote, and you might have heard this one before, Houston Airport actually got a load of complaints that people were spending too much time waiting for the luggage at the belt, like customers were complaining. And so they could have spent time optimizing how quickly they could get the luggage from the plane onto the belt, but instead, they made the way longer for the customers to walk from the plane to the belt. So the customers were being kept busy with walking and spent technically less time waiting. they were happier and got less complaints. And this is kind of what we're doing here. We made a task slower to have more freedom and to use that freedom to keep our users busy with a nice animation and actually with the ability to continue playing the game. So if you find yourself doing micro benchmarks, keep in mind that there might be not so obvious trade-offs and that the numbers game is not always the best game. Something I've glossed over so far a little bit in this talk is that the value that you send from a worker to a main thread needs to be copied. And that process is called structured cloning. It has been a source of worry for many people evaluating workers over time. So I run a benchmark. You don't need to look at this graph too much. I just put it in here so that I look legit when I talk about numbers. But what I try to prove here is that the time it takes to copy a value from one thread to another is dependent on how complex the object is. A deeply nested big object will take longer than a long-ish string or simple array. And what it turned out that there is actually a kind of simple rule of thumb. The amount of time it takes to structured clone an object is roughly proportional to the length of its JSON representation. Now, keep in mind that the number that you get is very much device-specific. And so I ran some more benchmarks to kind of establish a lower bound. So I want to look at the results that I got on the Nokia 2. The TLDR of this graph is that even on the Nokia 2, if your raw JSON is under 10 kilobytes, you don't have to worry about bursting through any of your rail budgets. This might not be enough. The 10 kilobytes might not be enough for every app, but you can actually do quite a lot with 10 kilobytes. If, however, you are running into problems with this post-matches pattern, you can look into alternatives like transferring array buffers, using shared array buffers and atomics, or even look into WebAssembly. But I can't fit all of that into the 30 minutes that I have. So if your interest is piqued, I also have a more detailed blog post onto this where I explain the graphs and the methodology, but also these alternative techniques that might help you address the performance problems if you actually encounter them. So if you want to experiment with workers now, you might be wondering what the tooling situation is. Because workers are not really mainstream. They have been kind of ignored by or overlooked by most of the tooling that we have today. Webpack and Rollup, for example, don't support workers out of the box. To change that, my colleague Jason wrote a plugin that teaches Webpack about workers. I wrote a plugin that teaches Rollup about workers. I want to give a big shout out to the Parcel people because they actually made workers work out of the box. So thumbs up to them. And this was basically my off-main thread on the web speedrun for you. There's much more to talk about. There's much more nuance in this topic, and it's very explorative at this point. So I just want to leave you with this. We are experiencing death by 1,000 cuts. Our problem is not really that any specific UI library is slow or that painting takes too long in one browser. It's the accumulation of all these tasks, that we run everything on the UI thread. Support hyper-constrained devices. It is a matter of inclusivity. We need to look beyond the tech bubble that we often live in and experience the web as the 50th percentile and probably even better, the 75th percentile. Some of our current pages won't even load over 3G on a feature phone, let alone run in a usable way. By embracing off-main thread architecture, you are moving execution costs to a different thread, but you actually also move parsing cost. So in turn, it might mean that your UI thread is now booting up faster, giving you a better time to first contentful paint, or maybe even a better time to interactive. And so in turn, you could increase your Lighthouse scores. Just saying. And lastly, web workers seem very complicated and crazy, but scary. But they can be enjoyable, either by embracing the communication model or through libraries like Comlink. And with this, I think we can actually take a big step for the web development ecosystem to make our web apps more reliable, but also more usable for everyone. Thank you.
I don't know if you noticed, but the screen has been flickering, and every time I flicker, I was like, oh no, again, not again.
No tech problems this time. So you have all deserved a break after listening to me around for 30 minutes.
And people on the live stream, don't go away. There's going to be more talks on the live stream, so stick around and grab a coffee and come back here at 4:45.
4:45. See you then.
Hello everyone, my name is Yi. I'm here to talk about new features in Canvas. Off-screen Canvas. To understand off-screen Canvas, let me first talk about Canvas. Canvas is a popular way of drawing all kinds of graphics on the screen and is an entry point to the world of WebGL. WebGL allows you, the web developers, to render interactive 2D and 3D graphics on Chrome without using any plugins. However, all Canvas logic, rendering computations, user interactions, and much more are all happening in the main thread. When the main thread is busy with critical computations, the Canvas becomes very janky and slow to use. It is a big drawback for Canvas. How can we improve performance? Fortunately, off-screen Canvas is a solution. As the name may suggest, it allows users to run tasks in the background. That is, it can be detached from DOM and move Canvas logic and computations to a web worker. Web worker is a web version of thread. So, in other words, we moved all those Canvas computations to a different thread. And Canvas like this, Canvas logics and computations can be done in parallel with computations on the main thread. And by moving these computations away, main thread will have more room for rendering logic and other things. One way to create off-screen Canvas is by calling transfer control to off-screen. It mirrors the regular Canvas to an off-screen Canvas. So what happened in the off-screen Canvas will be rendered automatically to the source Canvas, the one that is shown on screen. I want to highlight that image bitmap rendering context is also available for off-screen Canvas. It can be accessed via off-screen canvas.getContext bitmap renderer as shown in these slides. We can then load bitmap to the context by calling transfer from image bitmap. Image bitmap can be from any source, including other canvas or even other off-screen canvas. The advantage is that the image bitmap is just a texture, and it can be drawn without any undue latency. Without further ado, here is an example of performance differences between canvas and off-screen canvas. In both cases, the main thread is very busy. On the left, with the busy main thread, it doesn't have time to do any computations for the canvas. The animation is very janky and slow. On the right, since the computation for canvas are sent to different threads, the busy main thread doesn't affect canvas performance at all. The animation is very smooth. Coding off-screen canvas is very easy. You can simply create a worker.js file. Then you can create this worker in your JavaScript and start to use it. Here, I'm showing an example of implementation of such a worker. As it is a new feature, you may wonder if it is safe to use. In fact, we're using off-screen canvas in production today. Before this talk, I looked into Chrome feature stats to get some exact data on the usage. It is used in almost 23% of all pages loaded by Chrome across all channels and platforms. 80% of Chrome users interact with a page that contains off-screen canvas daily. I think most of you who are listening to my talk have used it today already. It is the top 200 CSS properties among the 3,000 properties available, and I hope it will get even more popular after today's talk. Moving canvas computations to a different thread is not the only advantage of off-screen canvas. Even when it's running on the main thread, it's still faster than canvas. We have run a macro benchmark on creating canvas, then get its context. Performing these operations on off-screen canvas is 50% faster than performing them on a canvas. I'm showing one particular run of many runs we have done. It has a particular advantage on text-related operations. It is consistently 15 to 45% faster. Speaking of text, it leads to our next topic, what's new in text metrics. We added the actual bounding box measurements in measure text functions. The actual bounding box measurements It measures the smallest rect that can bend the text. It ignores the space at the beginning and at the end. In this example in the slide, I'm measuring space, space, ABC, space, space. The only measurement we support before in measure text is width, which includes the length of space, and the actual bounding box will only contain the size of ABC. In fact, actual bounding box left will be a negative value due to the indentation. I will also take this opportunity to share with you what we are working on right now. Batch draw image. This is when multiple images can be drawn within a single API call. Recorded pictures. This is when you can create a record object that receives all the commands from a Canvas 2D and can be replayed multiple times. With these two features, we're hoping to get some good performance improvement in Canvas. There are few new primitives, such as round rect and oval primitives. We will also improve our support to text and color. Thank you very much for listening to my talk. Of course, I did not code everything I presented today, not even half. This is a joint effort with all my teammates. They are here on this slide. I want to give a special thanks to Fernando, our tech lead for this project.
Hi, I'm Yuna, and I'm here to cover what's new in material design on the web. We've got a lot to go over, so let's get started. The first update is the Material Theme Builder tool on Glitch. The tool itself is a self-contained application that showcases each of the material components with prompts to update the base theme shown. It helps teams to leverage the three subsystems of theming within Material: typography, shape, and color. The tool uses Sass variables to show users how to adjust an interface style and make their own brands shine by changing just a few lines of code within a theme file. For example, color can be adjusted via a series of variables such as primary, secondary, background, and surface colors. These come paired with on colors, which represent the text color on top of a variable background. Shape customization can be made for 3 component size classes: small, medium, and large components. Small components include buttons and input, medium components include modals and dialogues, and large components include menus and drawers. There's a great shape tool on Material.io to help you visualize these changes on our components before applying them to your codebase. And finally, we can adjust typography through the generalized MDC typography variable or through Sass maps that allow you to customize individual typographic levels, such as having a separate weight and font family for primary headlines rather than the body copy. In the end, your theme could look something like this. This is just one example that comes from Google Developer Days in China. We've made thousands of themes around the world so far, so head over to Glitch to add your own. We're also working on a set of guidelines for adapting dark themes using material components. For example, in a dark theme, Google Materials color palette reduces intensity to mitigate visual vibration or strong color contrast against a darker background. Instead of solely adding drop shadows to illustrate elevation and depth, in a dark theme, a lighter overlay is applied. Check out the Material.io guidelines for more design guidance on how to transition your designs into a dark theme, considering contrast, depth, desaturation, and limiting colors for accessibility. To help with this transition, MDC Web has released a set of typography theme variables that respond to background shades for text styles. You can now also use the theme variables in 3 different ways. The most supported and robust technique is with our Sass styling API, using variables and mixins to override styles. You can also create CSS classes with the variable names to style them by. And finally, for modern browsers, CSS custom properties can be used for the theme styling. We're still working on full support for custom properties at this time. We provide so many options because theming should not be limiting. You can extend the theme builder to make your own theme as unique as your product. Leverage our code and build on top of our material components to quickly and easily get started building product on the web. The next new feature in Material is data tables. You asked, we listened. Our designers considered these 3 principles when it comes to data tables. The first is that data must be organized in a meaningful way. Data tables should also be allowed for user interaction. And finally, those interactions should be as logical as the structure of the data table itself. Data tables come with some basic default functionality, such as row selection, but you can also hook them up to other components, such as these filter chips. Check out the links provided below for a deep dive into how you can actually implement data tables in your web projects and combine material components for orchestrated actions. We also have a new density subsystem option in Material. Material design uses low density space by default with large tap targets and margins, but offers high density space when it improves the user experience. We brought density into our system for the following reasons. The first is for scannability. Scannability is improved for data-heavy applications with a higher density interface. The second is that dense UIs may actually help users focus by reducing space between actions. And finally, more content is available to the user on a single screen in more high-density applications. Whether or not to increase your UI's density can be determined by how users interact with a component. Components with high density enable users to process and take action against large amounts of information in a more manageable way. Lists, tables, and long forms are components that benefit from increased density. But density shouldn't be used for every component. For example, don't apply density to components that involve focused tasks or alert the user of changes, such as snack bars or dialogues. Applying high density to alerts reduces their ability to command attention. A series of new styling classes on the web allows for us to access density in 3 ways: the default component size, a comfortable size, which provides a higher density display while respecting minimum touch target size, and compact, which may be used for pages with a lot of information, but may be inappropriate for user actions. Material.io got an update as well. We now provide a cross-platform view of all of our component offerings on a dedicated components page. This page allows for quick access to components and an overview of cross-platform availability. It should make it easier to navigate our product and implement it for your needs. Check out material.io/components to browse them all yourself. And finally, we're kicking off a new initiative this year to focus on supporting Material across web frameworks. Why? We know that most of you are developing web apps using a framework, and the open source community has stepped up immensely, building components for some of the most adopted web frameworks out there. We want to celebrate this work and help bring the material design vision to life, along with our open source community. So many of you have already built your own wrapper libraries using MDC Web's components, foundations, and adapters. And we're working more closely with the rest of the open source community as well. We've updated Material.io to link to 3 of the most popular open source component libraries. They've already uncovered bugs in the material design guidelines and asked great questions, helping us to make material even better. And we're helping them to follow the spec and the material guidelines more closely as well. We look forward to continuing the conversation and working to bring the material design vision to every platform and framework, making it easier for everyone to use material design on the web. There's so much to explore and play with, from theming to density to data tables to new website features and our open source community. It's an exciting time to be building with Material. So check out material.io and the links below where you can find all the resources that I mentioned today. Can't wait to see what you build with Material. I'll see you on the web.
There are many ways to add support for payments on your website, but which one is right for you and your customers? My name is Sok, and I am a developer advocate with Google Pay. Today, I want to provide some guidance on how you, as developers, can enhance the online checkout experience for your customers. Specifically, I'll walk you through how to make payments simple and more secure with Autofill and Google Pay. In many cases, people make online purchases with a credit or debit card. Providing this information is often accompanied with a request for other details like a user's shipping or billing address. Autofill simplifies this experience for users by making their payment details readily available during the checkout flow. Autofill does most of the work for the user, and no additional effort is required by website operators to take advantage of it. Autofill works by providing a list of suggested payment and contact details that have been saved to the user's browser. If the user is signed into Chrome Autofill extends this by asking the user to save these details to their Google account. This action makes the user's payment and contact details available across any of their Chrome-enabled devices. Checkout forms can vary significantly from one website to another. To account for this, Chrome Autofill uses heuristics to identify payment and contact detail fields. To improve the effectiveness of autofill and to ensure that your users have a great autofill experience, make sure your form fields are tagged with their respective attributes for credit card fields and address fields. Links to autofill resources can be found in the video's description below. With Google Pay, you can make checkout even easier for customers by eliminating payment and shipping forms altogether. Google Pay provides users with a simple and secure method for entering their payment and shipping information on websites. Plus, it works across all modern browsers. Hundreds of millions of Google users already have their payment details saved to Google Pay. That means purchases are just a click away. They don't even need to enter a CVC. In addition to accepting credit card and debit card payments, Google Pay offers additional payment methods like PayPal. Once configured, using PayPal as a payment method with Google Pay no longer requires the user to re-enter their PayPal password when making a payment. The security and privacy of user data is paramount to Google, and this is no different when it comes to payment data in Google Pay. Payment credentials are encrypted for secure payment processing. Integrating the Google Pay button into your website is easy, and testing it out requires very little effort. First, include the Google Pay JavaScript file. Check if the user is ready to pay. Add the Google Pay button, request payment data, and finally extract the payment token for processing. A detailed step-by-step guide is available as a code lab linked in the description below. To speed up and simplify the purchasing experience for your customers, add the Google Pay button to your checkout flow, shopping cart, and product pages. Google Pay is always making improvements for both our merchants and users, so keep an eye out for new features like promo codes and offers. We've also been experimenting with enhancements to the Google Pay button, and early results have shown increased usage rates amongst users. If you are interested in early access to these new features, please let us know by following the link in the description below. What about the Payment Request API? The Payment Request API is a W3C standard that helps users share their payment and contact details with websites using web or native payment apps like Google Pay. If you are a payment app provider, we encourage you to explore the Payment Request APIs as a way to offer your users an enhanced experience on Chrome browsers. Payment app creators can use the Web Payment Standard to deliver a better user experience. The Google Pay JavaScript library leverages the Payment Request API to provide a native experience on Chrome for Android, with a native experience rolling out soon on Chrome for desktop. At the moment, the Payment Request API is not consistently supported across all browsers and requires developers to include browser-specific logic. Therefore, to accept Google Pay, we recommend that developers integrate with the Google Pay JavaScript library directly. Google Pay can simplify your customers' purchasing experience by eliminating the need to interact with a payment form completely. In addition, it provides a simple, browser-agnostic API for developers, a simple and secure payment experience for users on both mobile and desktop, support for additional forms of payment, and in future, access to features like promo codes and offers. When used together, Autofill and Google Pay can help make payments simple and secure. Thanks for watching, and see you next time.
Hello.
Oh, some of you came back. Brilliant. Paul?
Yes?
Why do you look like you were involved in an explosion at a paint factory?
I'm glad you asked. I was actually slightly concerned that I was going to end up wearing the I'm a failure at life t-shirt. Still a possibility. So I thought I could offset it by basically wearing perfection. Right?
Okay, no, okay, explain to me. Just explain it.
Right. First of all, this design works front and back. A cowboy cat riding a shark that's vomiting a rainbow. Doesn't get much better than that until you realize that on the front, it doesn't line up.
Oh no, you have to get rid of that. No, I can't handle that.
And actually, have a feel of the fabric. I invite you to feel that is.
Yep, it's the same quality as it looks.
Yeah,
It's terrible. Yeah.
But the thing I actually really genuinely love about this is, and this is something, again, I'm going to be wearing this for the rest of the day, I think, and into this evening. I invite you to come and have a close look, because there's quite a lot of, they've basically taken the image and blown it up as big as possible, so it's quite pixelated, and there's a lot of JPEG artifacts on it.
No, what? Hang on. Oh yeah, that is JPEG, isn't it?
It is,
Look
but
at that.
As somebody who's into performance, I appreciate the compression. So I think this is hitting all the markers.
It's not WebP though. Can you tell WebP compression from JPEG compression?
No, because I'm not like you.
I did. I saw it. I was on The Guardian. I blown the page up. Like I was looking at it in close detail. I was like, I reckon that is a WebP, and it was. I was very proud of myself. Just giving myself a compliment there.
You are amazing at parties as well.
Ah, yes. Should we do some more of this?
Big web quiz. Right. Let's have a look at what we've got going on here. Now, you may recall from earlier that I made a slight mistake. I essentially picked out media keys from the hat over there, and then I went, we've already had that one. Turns out we hadn't. We'd had it in rehearsal.
Yes.
And so we had a chat backstage, and I said, well, great. This is a chance for me to redeem myself.
You've touched it. You get to keep it.
I will take this in the next round. So I have pre-selected for myself media keys, and now you're going to select what you're going for.
I am, and I am going to go for, please be a good one. Yes, background fetch.
Really?
Well, you say really? This is the feature I worked on.
I'm
I
so
was going to
sorry.
be so disappointed if someone else got this one, because this is
right. Well, then
mine.
You don't need to be sorry. But I will just explain why it is I think. I mean, let's jump straight into it. Let's be honest. This is the better feature. And as somebody who uses this day in, day out, but as a consumer, I love it. So you're busy doing your dev work, you've got your music on, and then you hit the media key on the keyboard, like play, pause. And up to this point, the browser's gone, nothing to do with me. And the music keeps playing, then you're like, okay, which tab of the 400 is the one? Go and find it, stop the music, by which point it's just all awful. Now, with this API, you can simply listen to, if there's a media session going on, you can say, right, if they tap next track, this is what you do. It's amazing. So that's why it's the better feature of the two.
It just works for videos, right? Like, if you're a video site or a music site, but nothing else really. Okay. No, that's okay. That's okay.
I'm sorry, do you not listen to music?
Yes.
Do you not watch videos?
Yes, I listen, yes, but like there's two websites I use for that. Like, and
they now are both better.
Okay, fair enough, fair enough.
What have you got?
Well, I have background fetch. So what we're seeing here is a download being triggered by a website. Now, if you've got a large download that you're triggering, what you need to do is normally you stare at your phone until that download completes, because if you put the phone in your pocket or you close the web page, that download will stop. Not with background fetch. It will create a notification, as you can see here. It will show progress, and that means the thing will still download even if the user leaves the page. But it's not actually going to save it into like the downloads folder or something, like more traditional downloads. This is giving it to the web app and asking it, like, what do you want to do with it? So this is how you trigger one of these downloads. It can be multiple requests. And it could be a download, like a podcast or a movie of many gigabytes in size, but it could also be an upload. So uses you uploading a gallery of images to some
honestly,
websites.
Mine was 2 lines of code.
Yeah.
It was great.
And then in your service worker, it will tell you when it's done. So this is even if the user's left the website, phone in their pocket, later on it'll wake up your service worker and go, hey, we downloaded all that stuff. Where do you want to put it? Probably the Cache API. And then you can change the notification to say, hey, we've downloaded that movie, or hey, we've successfully uploaded your photos. It's a huge problem a lot of websites have, and it is now solved, and that is shipped in Chrome.
Yeah, but it's such, I mean, that's a lot of code, mate.
A lot of code for a very powerful feature, I reckon.
Yeah, but I mean, who's got time for that? Nobody.
Well, shall we
let's
ask
find out. Let's find out.
audience?
All right, Media Keys.
BigWebQuiz.com, this is where your options are going to appear.
The shirt says go for it, Media Keys.
Remember, this is personal for me. So, okay, yeah, I'm happy with this.
I mean...
Yeah, that's pretty good. Thank you so much. I would have been so upset.
Which is why you should have done it.
Months of my life into this feature.
Yes, which is why you should have...
Should we call it?
Yes, call it.
My heart's actually going more than any of the other ones I've done of this. My heart is
I
really,
tried to
really
sway
going.
it with the shirt. I tried everything I knew.
Maybe people just don't like the shirt. Have you considered it might be that way?
You take that back.
No, it is a brilliant shirt. It's a brilliant shirt. It's got two sides, yes, like most shirts have.
Okay.
Excellent. So, just gonna set myself as the old winner there.
And that means we must be going on to the next round.
We shall be, yes. So let's zoom into that bit then, shall we? Because it is background fetch versus class fields.
Yes.
I mean...
As a listener, sure, remember class fields. If you like JavaScript, you write class all the time.
Background fetch is JavaScript as well.
Yeah. How many times do you need to download the data? Class is everything.
Do I have to remain impartial?
No, you don't have to remain... No,
Brilliant.
hang on.
Vote Marika. That's what I'm saying.
That's not impartial.
Oh, okay, sorry.
That's the opposite of impartial.
Partial, if you will.
Okay, yes.
It's more important to keep your fields private. Class fields, remember? Private fields, private fields, private fields.
Let's find out what you think. Is, I guess, a slightly higher level.
Yes.
It's sort of high level versus low level here, I think.
No,
It's very close. That's the Brexit number. Don't leave it there.
No. Remember, class fields, class fields.
Paul, I think I'm going to have to ask you to close the vote.
I'm going to close it.
Are you going to use my phone, are you? Okay.
Yeah, I haven't got my phone.
You've not got your own?
No, I put it away.
Well, but I want you to not be looking at the screen.
Remember, you need to write class.
So you want to be doing results?
Okay. Everything.
Yeah.
Every field. Private field. How many times do you need background fetch? You need class. I can't believe it. I quit.
Genuinely reckoned backstage that background fetch was going nowhere in this competition, and we all thought class fields might have been the overall winner. We've been surprised quite a lot.
I thought that was our other finalist. I genuinely did.
Fine.
But then, I mean, I'm sorry, I'm going to have to do this. I got one vote for my first win, one score, I guess, point, and 2 for the next one. I'm catching up with you there.
There's still time.
There's still time. Excellent. Right, we've been here long enough. Yep. So, here to talk about all of the fancy new stuff that has been arriving in CSS. Please give a huge welcome to the stage. It's Adam and Yuna. Thank you.
Hey. Hi. Hey, everyone. How are you doing? We got one woo. Thank you. Thank you, Soul Woo. I
got the
appreciate
clicker.
you. So we're here to talk to you about next-generation web styling.
And we've got... Oh, wait, hold on. Wait.
I was here to help. 12.
Oh, 12. Well, I had the little raptor.
Oh,
anyway. And yeah,
This is going well.
I'm a developer advocate on Chrome doing CSS.
And I'm a developer advocate for material design on the web. And you can follow us online here, as well as follow us into this journey into the future of web code.
So all of our demos that you're going to see, they are live screen captures, so there's no trickery happening. And we have links to all the demos, which you can see right there on nerdy.dev, CSS@CDS.
And we're going to start with some of the most well-supported features, and then go into things that are definitely coming in the future.
I'm going to start us off with, scroll snap.
Kick it off.
Notice that we have a little bar chart there under there that tells you the amount of support that we have, and we're going to start with things that have great support, and by the end, we're going to find things that have no support. So scroll snap, one of my favorite things here is that the support is great. It's touch-enabled, 60 frames per second, native scrolling for every platform. There's no synthetic scrolling with scroll snap points, and it's all organic. It's not organic. Anyway, whatever. It's mobile and desktop for free. And my pro tip with Scroll Snap is make sure that you try to keep it horizontal, because when you do it vertically, it kind of feels like scroll hijacking. So let's look at a little diagram. We've got our viewport is in the center. Each dot represents a snap point item. And this is basically a carousel where the items snap to the inline start. And let's see a demo, because we love animations. So we have a horizontal snap point demo here. This feels like a carousel. We're looking at shirts by Ten Hun, a rad Seattle artist. And we have a scroll X, so we have overflow container on the section. We're snap starting, we're throwing, and we're allowing skipping. So scroll snap stop, you can tell it to stop at one at a time in case you don't want to let them throw. And it always settles perfectly. So gotta love that. And did you know, well, I'm sure you did because I mentioned it earlier, you can do it vertically. So here I'm doing vertically, same CSS. I've pretty much just flipped the X for a Y, and I've told it to align center because that just looks so good. I like it.
Nice.
And here's the kicker. Did you know you can do both directions? Matrix snap. And basically you just say overflow and scroll snap type both and align in the center. And I want to call out too that overscroll behavior contain. That's so if somebody hits the end and they keep swiping, they won't, the scroll event won't leak outside and go into the next item. Kind of cool.
All right, so now we're going to talk about focus within, which solves a lot of accessibility elements when you're focusing within those elements. So if you wanted to create a menu bar, oftentimes we see menu bars with drop-downs or flyouts that occur within those list items. So you could have a list that's inside of your navigation. You could have some markup like this, where you have list item 1, list item 2. Inside that list item, you have this unordered list with more items. We see this pattern a lot. And if we want that submenu here to appear or be displayed when you hover over its parent element, we can apply some CSS to style it. So it could look like this, where on hover or on focus of that element, because you always want to have a focus style when you are creating hover styles, we want to make sure that inside list becomes visible and has a display. In theory, we could then write code like this, where we say visibility visible with opacity 1 and display block. But as we're tabbing through here, we're actually not able to see the elements inside of that second list item, which we've applied that sublist within. And that's because we're using focus. When you style with focus, when you're tabbing into the parent using that focus style, you will have those children visibly appear. But when you tab to the next tabbable elements, they disappear because we're no longer focusing on the parent. So you lose that style. Now, if you use focus within, it solves those problems because you're actually telling the browser to apply that style when you're focusing within a parent element. So that could look like this. All we have to do is swap focus to focus within, and when we tap through these, over here you see that sub-navigation appear, and we've solved that accessibility problem.
Cool demo. I like it. These are all the cool new media queries we have. And I said prefers/star because we have a lot of preferences that we can bring to the table now. We can consider our users' preferences and adapt our UI UX to lean into those. I also think these are kind of design surfaces. These are new design opportunities, these contexts and use cases. The way that they work for all of us webheads is the browser is our proxy for all this. The system and our platform sets these settings. They trickle down into our browser and come in the form of a media query. Here's a quick overview of some of the device preferences you might see on macOS, Windows, iOS, and Android. These things get as cool as adjust contrast and font size and theme. Personalization, right? I love it. Super cool. So here's our first one. This one's pretty popular. Look at the support. It's pretty good. It's a hook to pacify movement for folks that are sensitive to movement. And you have the option of no preference or to reduce the motion. Supports killer. And I have a fun demo that I want to show you real quick. So we have an animation that's pretty wobbly. We have mixing of colors happening. But if the user prefers reduced, instead of removing the animation, I crossfade. This is an important thing I want to share with y'all, that reduced motion does not mean no motion. Anyway, I thought that was a cool demo. And so I got really worked up there. DevTools has got your back in case you want to test it. So just pop it open, go to the rendering tab, which you can get there from the snowman that's on the left of console there, and you can change the properties and test your work. It's super cool. Another one that's pretty popular, which you might have noticed on the Chrome Dev Summit site, is prefers color scheme, light or dark, so you can adapt your UI for your user's preference on their eyes. It's really hot right now. My mom is on dark mode. Hi, Mom. You're in my talk now. And here it is again. We have a little bit of code here. We have a little demo. CDS side is a good example of this. And I have a hot tip, which is to follow some of the HSL patterns that we've seen with Yuna's demos. So we'll have a CodePen demo in that link that we shared. And there you can just sort of flip a couple custom properties and watch the whole site pretty much invert. Super rad. And again, DevTools has got your back. And in here, you can simulate both of those so that you don't have to go into your operating system and click a checkbox and go back to Chrome and do it all right inside of here. I'm showing that inside of Chrome Canary, so make sure you're in Canary when you're checking right now. So here's a bunch of media queries, just a little fast pass for ones that are coming down the pipe. And look at all these design opportunities. Prefers contrast, prefers reduced motion, forced colors, and light level dim. And now we can have users that say something like this: I prefer high contrast, dark mode motion when in dim lit environments. And we can do that with CSS. We can handle that. It's kind of cool. Anyway.
I love that browsers is becoming so much more personalized to our needs. And us, as developers, we can now create styles that work with our brand, but also work for all those different preferences. It's super cool. So logical properties are another thing that allows for really speaking to your users and creating dynamic directional spacing within and around elements. This is really important to maintain layout integrity across translations and writing modes. Right now, in a left-to-right based and top-to-bottom based language like English, we think like this. We think about height and width, and we think of top and bottom, left and right. So it's kind of like this compass rose aesthetic here when we think about layout on the web. But with logical properties, that sort of changes. Height and width become block size and inline size. Left and right become the inline start and inline end. And top and bottom become block start and block end. You may be familiar with some of these concepts if you've used logical properties within CSS Grid. But instead of thinking about layout like this, top right, bottom left with height and width, we think of it like this, in this new mental model. And when we do this, we actually get a lot back from the browser. With these logical properties, when we use them to write code, the browser actually creates adjustments for us based on the writing mode and the direction of the language. So in a left-to-right language like English, margin inline start would refer to margin left. In a right-to-left language, that would be margin right. In some Japanese typography, that might be a margin top in a vertical right-left language. So we don't have to make all these calculations ourselves. The browser is actually doing it for us. So for something like a block start, that would refer to the block flow on the page instead of the inline documents on the page. And for here, for both left to right and right to left languages, the margin block start refers to the margin top. And for a vertical right to left language, that would start at the margin right, because the block flow would go from right to left. Without logical properties, as you change the direction and writing mode, the layout integrity falls apart. Our boxes collapse, that border top becomes misplaced, the text is overlapping, and it starts to look a little bit like a mess. But with logical properties, we can have the browser do that work for us. When we're using logical properties in this layout, instead of using height, we've used block size, and instead of using width, we've used inline size. And this allows for the boxes to not collapse when we're creating a vertical layout. Instead of the margin left, we're using a margin inline start here on those headers and paragraphs. So as we swap directions, we still have the style of that layout maintained. And finally, in this main section here, for the border, we are using border block start and margin block start instead of a border top and margin top. And that's what's making that border retain its spacing. So you can write code like this, or you can write code like this, and it's the same amount of code, same number of lines. It's just changing the mental model of how you write it. And the browser does all of that great work for you to make that website more internationalized.
Logical props, y'all. There was a little hack I found. It's not a hack, it's just a good shortcut. If you do border block, you can do borders on just the tops and bottoms. Can't really do that shorthand any other way, so if you want a little sneaky way to get started with logical props, start there. I made a tweet about it. I don't know if you saw it. Anyway, this is about sticky situations. This is a CSS sticky, a really fun property that I like. Here's a sweet diagram. And one of my favorite things about sticky is you can see that as we scroll, so there's paper and a viewport there, the item is in flow with the document. But as soon as it reaches the point at which I've told it to stick with CSS sticky, it gets locked into the viewport. The page can keep scrolling until it comes back to the position at which it was in flow, and it becomes back and is a member of the page. Here's a nice little demo. I call this one the sticky stack. This is a classic sticky. There's nothing tricky with the sticky. Just setting the top to 0. Anyway, the HTML for this ends up being what's more interesting, so I just have position sticky top 0 there. Let's check on the HTML. I chose to use the definition list for this group list, and notice how the DT elements are siblings. So a definition list goes DL, DT, and then DDs are all the different artists there. And this is why they share the same sticky space, is they actually have the same parent. So let's look at an example where they're cousins. We get the sticky slide. And the sticky slide is where one appears to go out while the other one comes in. And the only difference, this is the same CSS, is that we have a different parent. So our cousins are, that's where we're cousins now. And this is my favorite example. This is sticky desperado. And that's because the sticky element looks really desperate to hang out with its friends. Right? I'm like, just go away, bro. Anyway, the only difference here is the HTML. I got a display grid, went sideways, and it's still the sticky slide, as we saw before.
I love those demos, and they're all going to be available at the link that we share, so you can go there and use them for your navigations. I'm really excited to also talk about backdrop filter. This allows you to style adjust behind an element, and not just on an element, when you want to apply filters to that element. Right now, you can apply CSS filters. They're great. They're super dynamic. They allow for a non-destructive layered transformation on top of any applied elements. And often we see filters used on images, but you can also use them on hover effects and transformations, on icons, links, menu bars, and even video if you wanted to. A cool feature that I recently discovered in DevTools is that all of these values for the filters are actually pre-filled, so you can see what they do and what input arguments they take. So I thought that was awesome hat tip to DevTools. Now, when you're creating a backdrop filter, it allows for you to apply those filter styles behind an element. So here we're applying the backdrop filter of blur on top of a text element. This aesthetic here previously was not possible without a bunch of weird CSS and JavaScript hacks to make this really work. But now you can do it in one line of CSS. So here I have a video where I'm applying this blur backdrop filter to that bottom left header. And you can see that you can apply different properties to it. You can use this for a blur or lightness or contrast or any of those filter types. And so this can be used to increase legibility of a piece of text on top of an image, and so many more things that we're just starting to discover because we just got this in browsers, and I'm so excited about it.
I do love backdrop filter. It's all over VisBug. It looks good. Is selector. So this is a modern, newer spec version of what we've had for many years, any in matches. In fact, it's 10+ years old. It's super handy. I'm a big fan. And I'm just going to show you a video because it pretty much sells the whole value of it right here. It's a what?
It's like bam.
Oh, bam! Watch me
right
go.
away.
Ah, is. I like you.
Nice.
What were you before? Oh my God! Anyway, I'm
Too
just
much
kidding.
code.
It was great. It was great still before, right? Oh, and now we have gap. It's not just grid gap, it's gap. It's coming to Flexbox. That means this is the spacing between your children. Your children don't have to, your kids, I'm a dad. Your children don't have, should I start calling nodes kids? That'd be funny.
No, don't do that.
Not. Yeah, I agree, I shouldn't do that. And so on the left, we see what margin is doing. And margin is where each child owns its spacing. And on the right, we see gap, where the container owns the spacing. And we've all felt the pain of what it's like when children are managing their spacing. So I made this demo. This is in the awesome Firefox DevTools. We have a grid on top, a flexbox on bottom. Both of them are just using the same gap and the same definition. And we see them competing for a better layout strategy here. And one of the best things about this is we see Flexbox gap being an amazing, amazing feature for us. This is one spacing declaration instead of whatever might have been many. So lobotomized owl, I don't think we need you anymore. You were great, though, until then. This is a good demo here where we have the spacing between. This matches the diagram that we saw. Display flex, flex wrap, and gap. Hey, wrap and gap rhyme. And we can end the debate if when our buttons have icon left, icon right, and all these different members in the child button here. We can end the debate by just putting a gap on it.
There's so many times I've hacked around Gap that I'm stoked to see that in browsers. I'm also super excited about CSS Houdini hitting browsers. Woo! Yeah, shout out to Houdini. CSS Houdini is a low-level API for CSS that gives developers the ability to tell the browser how they want it to read and understand custom CSS. This is what that looks like. It provides developers access to the CSS object model in a much more consumable way. Previously, if you wanted to style anything on a web page that didn't currently exist by using properties in CSS, you had to write a JavaScript polyfill for it, which not only convoluted your logic and your styling code, but it also was way slower, because you'd have to wait for the website to read your DOM and the CSS object model and go through the whole cascade layout paint composite step, and then you'd have to reapply whatever JavaScript at whatever point updated your page to have that repaint and to have it recomposite. And so we don't want that. With Houdini, you can now tell a browser from the CSS level how you want it to draw your page. So it gets that from the very start. And that means more performance, powerful, and extensible styling on the web. Houdini is the intersection of work done to improve browser performance, give developers and designers more power to translate their visions onto the web, and to extend what's possible in the set of CSS properties that we have today. It's really this umbrella term that covers a few different APIs. And those APIs are the Layout API, the Paint API, the Parser API, the Properties and Values API, the Animation Worklet, the Typed Object Model, and the Font Metrics API. If you want more info about any of these, Is Houdini Ready Yet is a great resource created by Surma that shows you all of these specs, their current place and time, and when they're covering. Today, we'll be covering the Paint, Properties and Values API, the Typed Object Model, and Animation because they are the most supported now. So let's start with properties and values. These allow you to extend custom properties, extend the capabilities that we have today when we're creating custom properties or CSS variables on the web. Right now, you can write a custom property by giving a name and a value, but that value is string-based. With registered custom properties, this Houdini custom property, you can give that a syntax, an initial value, so you have fallback values, and say if it inherits from its parent or not. So this allows for a lot of really cool things like error checking and creating visuals that previously were not possible on the web. Without registered custom properties, if you try to animate a gradient, for example, it just doesn't work. Whether you're trying to animate that gradient inside the gradient itself or using this custom property here to try to do it, the browser can't comprehend what you're trying to tell it to do. In this example, I'm trying to animate from a red to pink to a blue to pink gradient on hover with a 1-second smooth transition. But the browser has trouble interpolating these values in this context. Now, if we register a custom property and call it gradient start, we can set a syntax to that property so that the browser knows what to expect. So here we're setting a syntax of color. And this is the exact same code that we saw before, but we are seeing that smooth 1-second transition because we've now told the browser that gradient start is a color and to look out for that, and it knows how to interpolate now between those color values. Custom properties are great for design systems. They're great for type checking your CSS. In this example, we have a custom property called color primary that we've given an initial value of deep pink. When we have some code here, I don't necessarily have to say what color primary is. I don't have to specify it in either the global or in the element level. It just knows to read from deep pink because we've registered it on the CSS interface. We can still override that value very easily using the cascades. So here I'm overriding color primary as blue. But if we have something that's invalid, like a number here, this will fall back to deep pink. Without a registered custom property, the CSS would just ignore that line, and it would appear like a blank box. We would just see white background. So having this really allows for type checking in CSS, which I think is really cool. Also, I think this is even more exciting. The feature syntax for this is all going to be in CSS. So just like you can write custom properties in the root now, you can write all of your property declarations in your CSS and keep them all in the same file, and it's going to be great. It's just a vision of the future that I see. A tear.
CSS, CSS. Oh man, logical properties are sweet. All right, typed OM. So this is where you need to ask the DOM for a value that's like, what's the current CSS value? And right now you get a string. And it's kind of hard if you want to add something to it or remove something from it. And so what do we have upcoming? The typed OM. We're going to get objects, y'all. Super cool. So anyway, here's a good example. I've pulled up the Chrome Dev Summit website. I have a little GIF of me typing the old way, so I'm going to stash this selector for an H1. I'm going to ask the window to get a computed style of this H1, and then after that, I'll say, I need a computed property, and I'm going to want the font size, and it says 34 pixels. And that's what design tools have been dealing with for all these years. But what they're going to get here is I can ask the H1 directly for a style map, and to get the font size back, and I get the value in the unit broken out. It's super neat. I think VisBug is really going to love this. Any design tool is really going to love it. And really, if you're doing any JavaScript computation, it's going to be really nice. So on the left, we have what we used to do, which is string-based regex parsing. And you'd have to disassemble and reassemble. With typed OM, you ask, you math, you set. It's super rad. Here's the JavaScript of today, just so in case you need to copy-paste it, screenshot it. Right? We're asking the window for a computed style of an H1 and its font size. But tomorrow, we can just ask the H1 for a style map and a get call for its font size. And you get more here, too. You get conversion, clamping, error handling, and more. So you can't really mess that one up as much as you could the previous one.
I love this semantic CSS. It's happening on the web. It's so exciting. The Paint API is also something that's super exciting because you can now create your own Paint functions using a Canvas-like syntax. Before we get into the Paint API, we should talk briefly about worklets, because the Paint API is one such worklet. Worklets live in a separate thread from your main thread, meaning they don't take up page resources or slow down your site to apply styling changes like this Paint worklet would do. They're similar to web workers like service workers. They're registered to your page, and they contain all the instructions that live outside the main thread and can be acted upon when called. So Houdini worklets work in very much the same way. To get a Houdini worklet into your code base, you do the following. You first would write and register your worklet definition in JavaScript. So here, because I'm showcasing a Paint worklet, I would say register Paint, give it a name, and then have all of the Paint code being pulled inside there. Then we want to invoke that worklet file by using add module on the CSS interface inside of, say, the HTML here. So here we have script css.paintworklet.add module, and then the name that we gave it. And then finally, we can use that worklet by that name. So I called it fun here. We can say background paint, the type of worklet that we're pulling in here, and then the name. So it could look like this. This is an example of a pixel art, sort of rainbow top to bottom example that's just painting colors on an element. First, I'm checking for support by saying if type of register paint is not equal to undefined. Then I'm going to write out the worklet, saying register paint, give it a name. And then inside of that, I'm pulling in the context and size of the element for which I'm applying the worklet to. So I can set a size, height, and width from that element, and then I could fill the context there. Then in the HTML, we have the class box that we're going to apply this to, and we're going to add that worklet to the CSS interface. And finally, in CSS, all we have to do is write background image, paint, and then rainbow ties. That's the name that I gave this worklet. But it doesn't only have to be a background image. You can use these worklets anywhere. So I can also use this as a border image, that exact same worklet logic, but instead of a background, I'm applying it as a border, and you get a very different effect. For a few other examples of what you can do with the Paint API, I created this website, this library called extra.css, and what this showcases is just the power of custom properties and Paint worklets, and what you can do with them. You could change all of these different values inside of your code for sparkles, or if you wanted to create a scalloped border inside of your code with one line of code, changing different properties like color and width. Why have one underline when you can have many underlines? So here, it showcases how much power and fun you could have when you can tell the browser how you want it to understand the code that you're writing, especially the styling code, which we previously didn't have that much access to. And finally, let's end with some confetti. The talk's not over yet, just this part. For a more practical example, I played with recreating angled corners on the web using Houdini. This currently isn't possible on the web, but it is possible in other platforms like Android and iOS. And so in the material spec, we have angled corners, but it's not something that we can do in our platform. And I wanted our platform to have nice things too. So I had a few requirements. The first was that I wanted to make sure I could set each corner individually, just like you can with border radius. And I wanted to make sure this was a truly cut element, which meant that the ripple wouldn't extend past the element itself. I wanted the frame to end at those corners. So I used a mix of custom properties and input arguments for this. Here's that worklet itself, so I'm registering the paint, giving it a name, angled corners, and then I'm pulling in these input properties, these custom properties. I'm telling the worklet to look out for values that I'm going to then use inside the worklet itself. You can also pass custom input arguments. So here I'm doing static get input arguments, and I'm setting the syntax for these input arguments. In this case, the syntax is a custom identifier, and so here I'm looking for that custom identifier to be a string, field, or outline to show two different modes of using this worklet. Then I can use the context, the size, the properties, and arguments to build out this worklet. And so what I'm doing here is I'm building this canvas angled shape. And I'm getting the properties, the size. I'm using that to actually determine where I'm placing those points. And finally, here I'm calling for the argument of outline. I'm checking for that string. If it's an outline mode, then I'm going to use a stroke to apply the style. If not, I'm going to fill it. So that's because for these angled buttons, I first set the corner radius, and then I want to create a mask on all the buttons to make sure that nothing goes outside of the end of those buttons. So that's where this WebKit mask paint angled corners in a filled mode comes from. But there's other types of buttons in material, and one of those is the outline button. So here I'm using the outlined argument I'm setting a couple of more properties here, the paint color and the stroke weight, and I'm using the exact same worklet to apply a border image that's then painting this on top. So for the outline button, I'm using a mask and a border image with the same worklet. So altogether, it looks like this. You can also use these as CDNs, so you could include this as a CDN in your file, and then set your custom properties and include that line of code that says I want angled corners, and it's just really exciting time. But I know this is talking about future CSS. I still get this question a lot, but what does it look like in unsupported browsers? Well, it looks like this. Here's what it looks like in IE11. This is emulated on BrowserStack. You don't get the angled corners, but these buttons still function well, and you still have your UI there. I think this is a great example of progressive enhancement. You can have great UX across browsers, but you don't have to have pixel-perfect, identical interfaces. So I want to free you of that construct, of that burden. I think that you can use Houdini today in a way that is decorative and can enhance your UIs without making it a core part of your UI. So when you do have things fall back, check, make sure they work, but don't be afraid of using these future-thinking properties. I turn to you.
I love that you use the same worklet across multiple use cases. It was a border image, it was a mask, it was a border, it was a background.
So useful.
So rad. Let's talk about the animation worklet. This is off the main thread animation. This is where your first-party animation. You're not going to be chasing something with a request animation frame. You are included at the core. It's so different. And what I've built is a demo that kind of brings all of this stuff together that we've been talking about today. So really quick, just like a paint worklet, we create a class which implements the Houdini animation interface, which really just means it has a function called animation. Then we add the module to the CSS object model. And since ours is an animation, we don't really do much in the CSS after that point. So let's see a demo, just so kind of what I'm talking about. I built a tabs component, which might not be that exciting, but notice our little indicator on the bottom. It's always in sync with the scroll zone. I can click to go to my different tabs. I can use tab and spacebar to navigate with accessibility. And whether it's on a responsive desktop or on mobile, I have touch and I have everything. And this is really exciting to me. So how did I get there? What this is Houdini plus a scroll timeline. And so we can pass a new tick to Houdini. And what that means is usually your tick is usually the screen refresh rate, but now we can send it to scroll position of something else. So since I created a CSS grid layout that had scrolling snap points, I create a keyframe effect, I create a scroll timeline that points to that scrolling space, and I pass in some options for initial state, like how many tabs there are and what's the maximum scroll, and I give that to the animation worklet, and then we get a gorgeous 60 frames per second scrolling and in-sync tab component. So here's what my keyframe effect looks like. The keyframe effect is kind of like if you make an at keyframes animation, but you only take one little piece out of it. You can kind of make many little pieces and then assemble them later. It's really cool. If you haven't heard of a keyframe effect. The scroll timeline is also cool, so this is new. This is where I'm creating a scroll timeline, and notice it's scroll. There's going to be other timelines in the future, so what we're going to be able to do is not just rely on one type of tick. We can specify many and create our animations that are like reactive to different things. So this one is reactive to the scroll source, which is called section, and I give it a width, I clamped a length there. And I created a worklet called tabs. The constructor takes in some initial props and sets state. I have the animate function that's going to get called on tick, and it does the math, which is going to calculate the position. All together now, this is my tab.controller. So I'm going to create a new animation that's spinning up my worklet. I'm going to name it. Well, I'm going to reference it by name. I'm going to pass in my keyframe effect. I'm going to pass in my scroll timeline. There's my initial state that we were talking about earlier. And then I say animation.play, and nothing happens. Why? Because the tick is not the screen refresh rate. It's my scroll position. You have to scroll to make it go. And I think that's really cool. So we got everything in here. We have touch, we have mouse, we have keyboard. Everything's ready to go. This is on a glitch. Fork it and check it out. It's super rad. And this is something that I got really inspired by. Once I made that demo, my brain started going nuts about the reactive animations I could create, and I saw this GIF, and I was like, I could do that with Houdini and scroll timeline. We've got a vertical scroll snap and a horizontal scroll snap. And all we're doing is reacting to the position of those things, and we're letting them snap, and we want people to be able to touch and push those things any way that they want. I'm starting to talk fast, and that's because it's time for
Speed Round!
Speed Round!
Kick it off, Adam!
Okay, here we go. So we got size. This lets you set height and width in one fell swoop.
We've got aspect ratio, which allows for your media to retain its dimensions, meaning you can avoid those awkward stretch or squish images, or when you're trying to use a web page and the web page starts to move around because the images are loading in. This prevents that. Aspect ratio allows for those images to actually have their own aspect ratio.
Yes! We got min, max, and clamp, and this is the ability for us to set constraints on any CSS property that we want. We don't have to do min width and max width and width. We can just specify a min and a max and clamp it.
Lists don't have to be boring anymore. With the upgraded list style capabilities in Chrome 79, you can have SVG and emoji, and if you wanted to play with Smile again, maybe animated SVG, I don't know, do your thing.
Animated little arrows, read me, read me.
That would get so annoying.
All right, we have display, can take 2 parameters now. You can specify how it's fitting in the outer scope of the block level and how its inner should work.
Regions in CSS allow us to fill a region, an area, with content. So you might be familiar with this concept if you ever used InDesign to lay out books or brochures. Essentially, you can create areas of code that flow into and out of different boxes, and your code doesn't have to be just rectangular. This works really great for grids, where you can define your various regions and have that text flow into and out of those regions.
Well
said. Spaces,
Nailed it.
UI.
CSS modules. So now we've got JavaScript can ask for a module, whether it's from remote or local, and it gets a rich object back. Super nice.
We can't forget subgrid.
How did we almost forget that in the
I don't
list?
know.
I don't know. That one's not cool. Wait, that one's amazing.
I know. This is coming in Firefox 71, and this allows for you to create micro layouts along with macro layouts that use CSS Grid.
Stoked. Wow, we did 20 and 30 there. That was 20 CSS and 30. Anyway.
We made it.
We made it.
So we can all take a deep breath. You've made it with us. Thank you for joining us in this journey. Check out that URL for all of the resources, for links to all of our demos. Also, if you're here, come and talk to us. We'll be outside in the sandboxes for VisBug and for material design. If you're watching this online, feel free to tweet at us. We love talking about this stuff. I think that's all we have for you today, and we're definitely out of time, so thank you again.
Thank you. Nailed it.
All right, shall we get going?
Let's do a quiz. Do you want to go and pick first?
Yes.
And we will
Only
see what we
4
get.
features left.
BigWebQuiz.com, as usual. Head there on whichever device you got. What have you got?
Match all.
You got match all. Okay. I feel all right about this. That's it, I think. I've got sharing. Sharing
caring.
is caring.
Yeah.
Fine. Okay. So sharing. Do you want to start with your explanation?
Well, so I would like to start this with regex. Match all. You know, like at some point in web development, everybody writes regex. And you know, regex is illegible and it's hard to read. So you do this thing where you match and you get array back, but it doesn't really get all the information back. So now there is a new regex method called regex.matchAll. And it's returns the iterator. Is that iterator? Yeah. So you can loop over to get all of the information. Very useful, very useful. Very useful.
Yeah.
I used to make text editors. This is very useful, actually.
Yeah. So on the other side, you've got the ability to actually share now to the native side, if you will. So if you've got a PWA there and you want to share some stuff to onto a native app, you can do that. And we've just, you see here, you've got this files with the file array. You can actually share binary data across to the native side.
Yep.
That's amazing. But also, it's a 2-for-1, because if you've got a
native app.
A native app, there we are. You can say in your manifest.json, I'm a shared target. You can actually share from the native side to me. And if the PWA is installed, then it will start to show up for users when they say, I'd like to share this, and your PWA can pop up as well.
Yeah, but remember, if you share, the text data needs to be parsed by regex. So regex needs more importance, like higher importance.
I mean,
you know, match all, it's great. Iterators, yeah.
I'm just gonna start the vote and see what people make of this one. Right, staining. Here we go. Match all, just saying, I mean, if you like regex, sure. Or sharing, something that everybody does. See how you feel about it. Voting is open.
Knew it. I knew
No! Well, okay.
Big surprise. I knew it. Regex is not for everybody. I know it.
looking
I know
good,
it. It's
but-
fine. It's fine.
I mean, I like regex as much as the next person, but I prefer sharing, which is why it's the better feature. Okay.
It's clear, isn't it?
Gonna close it in 3, 2,
It's clear.
1.
Fine, fine, fine.
Thank you.
Remember, Paul has a lead points. Why don't I get points?
I don't know.
So you're gonna implement your own point?
I will do after this. I'm just gonna sit here or stand here and just look at that 70% for a little while. Good. What's happening next?
What's up? Oh, I thought you were gonna implement it here.
I will do.
Oh, okay, it's fine. Right. So the next is about PWA. Have you built PWA before, Paul?
I think I've heard of them.
Oh, you have heard of them. Okay, we'll get to know more about it. So please welcome to the stage PJ McLaughlin and Sam Thurgood.
Thank you.
Hi, everyone. Thanks so much for joining us today. I'm a product manager with Chrome, and I work on the installable web.
And I'm Sam on the Web Developer Relations team here at Google.
And I'll introduce you to Mukund a little bit later in this talk. Your users know that the word install means that it's software that's meant for their device, and you want to meet your users' expectations. So that's what you see there on the right, an app that launches from the home screen and is essentially indistinguishable from a native experience. Let's start at the beginning of the story, though. Bookmarks are the original way for users to get back to anywhere on the web they wanted to get back to. They're kind of a universal install button, and they've been available on every major browser since the dawn of the web. So a good question would be, why don't we just use that? And in a word, the answer is mobile. Of course, you can bookmark on mobile, but it never really fully made the jump. And we do see significantly less bookmark usage on mobile than we see on desktop. One reason for that is that the UI just isn't quite as convenient. And that's not just saving the bookmarks, it's also organizing and finding them as well. The second challenge that we see for bookmarks on mobile is that apps, as we just saw right now, integrated to the mobile OS in ways that are important for functionality. So, for example, a lot of apps do need to tie into, say, Android's native sharing sheet, which is what you see on the right side of this slide, where URLs shared from the Myntra PWA to Twitter. And to enable a share target, we need an OS-level entity. We need something like an APK on Android, and not just a bookmark. A lot of you will be familiar with this term, add to home screen. And again, you see that on the right in the Starbucks screenshot of this example. Unfortunately, add to home screen can actually mean two different things. It could mean that it's a bookmark that's being placed on the home screen, or it could also mean that it's actually an integrated experience on the device. And that's why we'll be using the word install for the rest of this talk to talk about the integrated experience. And in the future, you're going to see this in the browser UI on mobile and desktop. The reason for that is install is a UX affordance that's familiar to mobile users who are used to adding content from their OS's stores, such as Play, and then finding that content again on the device through whatever the native launch surfaces are, so on mobile, usually from the home screen. Install aligns to a user's mental model for how installed, like basically how experiences ought to operate on their device. An installed web app looks and feels like every other app. And the fact that your user discovered and installed your app from the browser or from Play shouldn't actually matter when they go back to use your app again. Most importantly, the word install signals to users that the experience was meant to be great on their device. Here's a summary of how web install is different from bookmarks. Web install offers users access to web apps that are from familiar discovery and launch surfaces for their device. So install web apps can be standalone. That means they can be separate from the browser. It also means that they can be integrated into the native task switcher. And this can be a more familiar way for users to interact with apps, or it might be more suitable to certain types of tasks than tabs. Web install integrates the web apps with the device services that expect an installed app. The important thing to remember when you're asking a user to install a PWA is that with an installed app, you're telling the user that it is an experience that is meant for the device that the user is using. And that means that you need to live up to those expectations. What you design, or you're going to have unhappy users. There's a good thing that we have a pattern for building experiences that do just that. Progressive web apps are a pattern for great apps that use web technology. And they have all the features and functionality users expect from a modern app on mobile or desktop. I'm sure most of you in this room are quite familiar with PWAs at this point, so I'll just cover some of the very high-level background information about PWAs for those of you who maybe are new to the concept. PWAs include things like personalized content, offline mode, push notifications, and instant loading. And PWAs and installed web apps do go hand in hand. You need to have a PWA in order to offer install. There are, of course, other projects that are trying to crack this problem. And you can take a look at React Native, at Electron, or Cordova. And all of these are basically offering you a way to build native apps using web technology. But those experiences do depend on functionality that won't also work in the web browser. The PWA's goal is to build directly on the web. So that means you can maintain one code base, and that's going to work for visitors, both in the browser as well as for your installed users.
So hi. I'm lucky enough to get to work on Santa Tracker every year, which is a fun, holiday-themed experience for all ages. And so we'll be using this as an example as we go along. Santa runs on basically everything with a browser, even this magical screen-changing device. And so we find that folks who install it to their home screens on any one of these platforms where it's supported are some of our most engaged users, coming back the most often. And on Android alone, a few years ago, we found that about 10% of all our loads were coming from that installed icon. So that's a quite nice number. This is fundamentally because when an app is installed, your users will feel like it is designed for them. Users will have better engagement, more loyalty, and have a positive experience with your installed application. But, of course, who are these users? Who is going to benefit from this extra power? We're the first ones to admit that it won't be everybody. The power of the web has always been that it is ephemeral. Users can move seamlessly between experiences, and so you shouldn't expect all of your users to install. And to that end, there is a bit of an install funnel. This is the same as native apps or e-commerce conversions. Most strategies for optimization apply here as well. You don't want to push the user to convert too soon, or they'll leave your site running. You should only promote install to users who are frequent users or who will actually benefit from your services. Focus on features that users might care about, like smaller download size or faster access. You'll also want to track the right events and analytics to make sure you know what to optimize. PJ will cover this a bit later on. So promote web install on screens where the use case makes sense, including desktop, tablet, and mobile. Take this example of Spotify's CTA from a landing page. We'll also be covering more of these as we go along. So we've covered some of the what and some of the why, and I'll continue now by talking about the how of install. Your basic requirements for supporting the installable web are to have both a web app manifest and a service worker. These are actually, in 2019, pretty well documented. These are the same requirements, as we mentioned, to be called a PWA. I'll mostly be covering the manifest. For the service worker, just briefly, the requirement is that you do actually load offline. If a user clicks on your app icon while they're offline and they see nothing or an offline dyno, users will have a bad time, and so will not allow you to be installed in this case. I think you'll find some great, amazing content on Codeless for Google on service workers online. Oops. The manifest is a simple JSON file which basically informs your user how the site acts when it's installed. You need one per app, and you need to include a link to it from every page of your site, so the user can tap install anywhere. And I'm kind of trivializing it, but pretty much all modern browsers have some level of support for this file. And including it's quite simple. You simply include a link in pretty much all your pages, as I mentioned, because you don't know where your user will hit install from. One of its core parts is controlling what your launcher icon will actually look like, and the start page that opens when you press it. Here's what an Android experience will be. Santa Tracker has a little green icon with a short name, and you'll see something quite similar when an app is installed on desktop. The manifest also controls how your app is loaded. For games, you might choose full screen, see the example on the right. But for anything app-like, you'll want standalone, which won't take over the target device's UI. Websites running in any mode can still use browser's APIs to later request full screen. There's a few other options here, including browser, which retains the URL bar. But honestly, we don't think this is that interesting, and so we think these two options are what most people will end up choosing when they configure their installed PWA. The manifest itself is pretty boring. Here it is for completeness. I won't go through every field. Like I said, there's actually tons of information out there on the web. But I want to cover some important patterns. You need to include a few icons, including one which is at least 512 by 512. And remember that this isn't your site's fav icon, so you still need to include one of those. In building Santa Tracker, one thing we really discovered was that there's no implicit internationalization support. You need to serve a different manifest for every language. And on icons, the standard also now describes maskable icons. The very short version is, if you provide an icon and indicate that it's maskable, this is a signal to the platform that it can cut your icon down to safely display crazy icon types like circles, squircles, or teardrops, making your users feel like the app was really made for them. And with this, we actually recommend not using transparency in your PWA icons at all, because the OS is handling this part for you. Of course, this is still a bit brand new, so we recommend also loading up your app in some major environments to check what the icon will look like. There's a few more things coming in the manifest which are also worth mentioning. App shortcuts have just been added to the spec. This lets an install icon provide secondary intents, perhaps through long press. I've kind of cheated here and shown you an Android example of this case. And Web Share Target, which we'll cover more, allows an installed web app to be a target for sharing. We're also just seeing a bunch of tooling around manifests. And we think that honestly going forward, nearly every tool chain will just provide you a web app manifest. And so while we're glad you're listening, this stuff is also becoming just boring enough that it's likely handled for you, which is great for us as web developers. So as I mentioned earlier, manifests are supported by pretty much all modern browsers, which leads me on to, well, the nuances, a web developer's best friend. Let's start with Android. This was the first place that install was available, and once installed, apps are first-class citizens provided by real native APKs. Importantly, Chrome on Android is actually able to prompt your users to install, if your site includes a service worker and a manifest. Santa Tracker here is actually pretty ambitious. If you take a look at this animation, even during the loading screen, it pops up a little mini info bar. It's not ideal, but we'll revisit this in a bit. Regardless, if you then tap that info bar, you'll get a full-screen prompt to install. There's a few things to dissect here. While this does say add to home screen, as we mentioned, we're moving away from that verbiage as we support really so many platforms now. And as I mentioned, this generates a real APK that works with any launcher and is really a first-class citizen for users like any other installed application. Another option for install on Android is something called Trusted Web Activities, or TWA. While this has a few details to get through, fundamentally, you're writing an Android application which features a core activity provided by Chrome, or actually, fairly soon, Firefox as well. And you're uploading it to the Play Store, so it's discoverable and promotable like any other native app. The best way to learn more here is to go and follow Google's Code Labs on this. Do a search for TWA Code Labs to find out more. We've also got an interesting option for folks who are using Managed Play with G Suite. This means if your organization signs into corporate Gmail on their devices, you can simply push real APKs that load your website via Managed Play. There's quite a few steps. This video is quite long, but if you watch closely here, I've built Santa Tracker for Work, which pushes Santa Tracker to all the elves in Santa's org. So while we think this is really interesting, it's also worth noting that your corporate users will actually never see the URL that's being added to their device. You're able to push any website as a real app, not just your own. Finally, and probably most interestingly, let's talk about the how on iOS. iOS has had installable web apps since the beginning, but the last few releases have really made install on iOS quite practical. Here's an example of loading Santa Tracker from the iPad. We do have to have custom icons. This is done via the iOS meta icon tags, which I won't really cover here. And while they're a bit of a pain, tooling can help you generate these. Apple has also previously suggested providing splash screens. Honestly, we don't think this is that important anymore. iOS 13 has brought you nice animations and fades that make sure that your website isn't just jarringly dumped on the screen. We didn't want to use one in this example. And last but not least, I also want to talk about desktop. Only Chrome provides install on desktop right now, but it works well across all platforms, macOS, Linux, Chrome OS, and Windows. Your sites will get this little plus button, and users will get a native app that lives in their launcher. The plus button will even wiggle a little bit if you do the right thing, calling attention to the fact that install is available.
Thanks, Sam. I'd like to cover some of the frequently missed details that will help you acquire more installed users. So first, a lot of companies have native apps and worry about accidentally promoting the PWA to a user who already has their app. And you may want to promote your PWA, but you want to explicitly target the group of people that are not your native app users. Now keep in mind that there's all kinds of reasons that a user may not have or want your native app, but might still want the web app. Storage, for example, is the #1 reason that users remove apps from their device. But most web apps are tiny, and the storage that most web apps use can be dynamically purged from the browser through either a manual cache clear or in response to storage pressure. So you may want to let users know that the web app option exists, but you don't want to create any channel conflict with your native apps. So to avoid promoting your PWA install feature to native app users, you want to use the get installed related apps, just there to help. This API is going to let you see in JavaScript if the user has your native app installed. Get installed related apps is not in stable yet, but it is in an origin trial, which is an early access program. You can still use it on your site today. An origin trial might sound scary, but all it means is that you need to register online, and the API will be enabled for all Chrome visitors to your site.
If only there was some search engine that will help you with that.
If only. Most PWA installs today are happening from the mini info bar. The mini info bar was only intended as a temporary shim. It's not the best user experience, and since it's generated by the browser, it really has no way of knowing whether this particular moment is the right moment to present to the user the option to install. It just shows up as soon as the site passes installability criteria and a user engagement measure. You're going to want to replace the mini info bar with something better. And we're going to get to what is better than mini info bar soon. But first, you need to hide it and make sure the mini info bar doesn't appear if you don't want it. And all you need to do that is to call prevent default on the before install prompt event. Make sure that you've added the UI that you need to trigger the install prompt before you do this, though, or you will literally have no installed users after you prevent default on this. So let's look at the code for a second. The relevant line is right here, event.prevent default, and that's the critical thing for hiding the mini info bar. For most sites, this should be a very trivial change. So let's assume that you've got a UI element in the page called install button, and that you're going to want to display this install button as soon as the browser signals that your app can be installed. You don't want to show this beforehand because this button won't work the way that the user would expect it to work. This element should be hidden and then enabled, and that's exactly what we do in this next line. And finally, you're going to want to capture a reference to the install event so that you can use it to prompt the user later when the user actually clicks on that install button. And now we can look at exactly how you do that. So here's how you use that saved reference. So let's imagine that you want to wait until the user has finished some important journey that's part of your experience before you prompt them. You can use this stored handle for whenever you're ready, or the user clicks on the install button in your UI, to trigger the browser's UI for the install prompt. Don't forget to instrument analytics so that you can understand your user's behavior with respect to install prompts. There's really 3 important moments that you want to capture here for your analytics. So the first is when that prompt is actually available. When did the site fulfill the installability criteria? And that happens with the before install prompt event. And that's what you listen for, and you can set up an analytics event there. The second is the analytics for when the prompt is triggered. If you're taking the recommended approach here and you're tying that to a piece of UI inside of your web content, then this is going to be probably a click handler on some element inside of your page. And finally, when the user has actually completed the app install, you're going to want to listen for the app installed event. And this is what's going to tell you that the app install was completed successfully and the user hit OK from the browser UI. So you may be asking yourself, what about iOS? And the great news here is that iOS Safari has had support for the essential PWA ingredient service worker for quite a while now. And it's easier than ever to install PWAs from iOS Safari with add to home screen, like moving to an option on the first level menu. So here's an install promotional pattern for iOS that we're going to use for Santa Tracker. Notice how we're basically triggering a pop-up helper to help the user through the install experience from the install button. And this is the same install button that we're going to use on Android as well. So the delta between the 2 experiences is really quite small.
So with that, I want to talk briefly about a few different UX patterns for your installed PWAs. So Santa Tracker is pretty unique, right? It already has a pretty distinct look and feel, and your site probably doesn't. It looks like a regular web page. So the uncanny valley here refers to something which looks almost correct, which is ultimately just a bit off, like this almost right dino game with some very odd UI elements. If your experience doesn't match your user's expectation, they might be put off. So we at Google love the web, and there's now an expectation that perhaps an installed app acts and feels like it's always been that way. And this advice isn't really unique to PWAs. I want to talk about the feeling we get when we use web apps like Gmail, Spotify, or even Google Docs. When I use these apps, I almost forget that I'm on the web. How can you help your users have that same level of immersion? There's a few tips I'd like to talk through to make your site feel more native and then lose that uncanny feeling. Focus rings are where I'm going to start. These let your user know where their cursor is. Pretty basic accessibility feature, which you should keep. But the default ring is a definite tell of the web, so mix it up, and this applies to form elements as well as links. Text selection is also probably something you want to disable, especially on UI components, because it's not an expected behavior of installed applications. Personally, I'm not ever a fan of making this UI part of a page selectable, but it's especially pronounced when installed. And set a theme color. This refers to the window color of your app, as you see in this desktop version of Santa Tracker, where it's a dark blue. By default, it's from the platform, so you don't really know what you're going to get. And overscroll, which you can see happening here, is actually somewhat related, because it can mean that 3 contrasting colors end up showing, and in most cases, you'll just want to disable overscroll to prevent this from happening. It's a very web pattern. As an alternative, at least make sure that your HTML tag is set to a reasonable background color that's not the default white. I'll also very briefly mention safe area inset, which if you're a fan of notches on phones, lets you avoid that notch and put some color or interesting content behind that area. You'll also want to think about some UX changes. I'm going to go through these fairly quickly. First, don't allow navigation outside your own site. If you do, users will get a really ugly URL bar. Make sure you always open external content in a new window. Next, think about better behavior for extended actions like select all, undo, and redo, especially if your experience is app-like. But by default, undo and redo only apply to text elements. What if you're allowing a user to reorder a list? And finally, you might want to do something different with the right-click menu, especially when installed on desktop. The default menu includes items like Save As or Cast, which barely make sense on some web pages. And while it's bad practice to disable this right-click menu on the web, when you're installed, there's really a license to improve the user experience by hiding these options.
So I mentioned a couple of times the different ways that you can promote your web app. And here's where we get into the examples of how exactly to do it. So keep in mind, as we go through these, that these patterns aren't intended for every kind of site. They're examples of good patterns that you can use. But try to understand your use cases and use patterns that are appropriate for you. And please always remember the rule of thumb whenever you're prompting users about anything, install or otherwise. Don't be annoying. Let's give this a try. All right, First, the header can be a good place to promote install of your app, but you do need to be careful here. This one comes with a lot of cautions and hand waves. These are really precious pixels. And you want to use information architecture and A/B testing to determine whether it actually makes sense for you to have an install option in the header of your site. For some apps, this will be a clear and obvious win, and for other apps, it would be completely inappropriate. That will really depend on your use case. You may want to use an icon instead of text if you want to make this action button a little bit smaller. And you might also want to consider selectively promoting only to users that have engaged with you. So for example, could be only shown to signed-in users who clearly have an interest in what the product or service that you're offering. This is an example of adding an install prompt to the hamburger menu. The great thing about using the menu here for promoting your web app install is that there's already a strong signal that the user's interested in what you're offering by clicking on the menu. And I hope that this is obvious, but you don't want to block access to any important functionality in your app with the promotion, here or anywhere else for that matter. You don't want to make sure that it doesn't overlay anything or clutter up the menu design or in any way take precedence over the other actions that the user might want to take by clicking on that menu. Here's an example of promoting install via a landing page. And landing pages are explicitly about marketing your product or service. And so this is really your one opportunity to go crazy, be as big as you want. But just keep in mind that all the usual best practices for creating a good landing page are going to apply here. In particular, the most essential thing about your landing page is that the user understands what the value proposition that you're offering them is. If your install pattern is getting in the way of that, then chances are you're going to lose both a potential user, and you're certainly not going to encourage them to actually install. Here's an example of an in-feed pattern for promoting PWA install. And feed cards are very common these days in many types of apps, including You see it in social and news, e-commerce, basically anywhere where there's a lot of vertical scrolling and chunked information. Don't show this promotion too often. And if a user dismisses the card, please remember and respect the user's choices here. Every app's use case is a little bit different, but there's almost always some key moment of engagement in the journey when you know that the user is truly interested and understands what it is that you're offering. And that's a great moment to ask if they want to reconnect with you in the near future. The usual rules apply here. You want to always focus on the benefit to the user and use the context of the key moment. In this example, the user's just finished a game. It's a great opportunity to say, hey, do you want to play again really easily? You can find this again from your home screen. So let's recap on the principles here. Don't be annoying. Your users came to your site to get something done. If you interrupt that flow or make it in any way difficult for them to get the task done that they came to your site for, chances are they're just going to leave and go get it done somewhere else. Information architecture is your friend for figuring out what belongs where, and that includes for promoting install. Second, remember that if the user doesn't benefit, you shouldn't be promoting it. And finally, do use the context, where is the user in their journey, to help the user understand what they're actually going to get out of installing your app. If you want to learn more, you can search through the fundamentals site with the query promoting install. Now, investing in a great PWA and making that PWA installable does have big benefits for user engagement. To talk about these benefits in practice, Mukund, a product manager for Oyo Consumer Experience, is going to join us on stage and talk about the impact installability has had for them and their team. As a little bit of background, Oyo is the world's second largest hotel chain, and it has a presence in more than 80 countries. It has more than 23,000 hotels. And with the rapid growth, they have basically pursued mobile web as a key demand channel. So today, Mukund is going to take you through all that's happened with their mobile web experience and how they've grown in the last year. Please welcome Mukund.
Thank you, Peter. Hi, I'm Mukund. I'm product manager for Oyo Consumer Experience, and I'm super excited and delighted to share the journey of Oyo Mobile Web, as well as how focus on this channel led to rich results for us. So if we talk about the growth that we saw in Oyo Mobile Web, we can talk about three major interventions that were brought about. First was PWA. This was followed by the capability as well as adoption of browser installs. Finally, the integration of TWA, that is Trusted Web Activities, really led to rich results for us. With each of these key interventions, we were able to see good, sizable lift in conversion, as well as key capability increase. Also, our product was made more accessible to the end users. Let me take you through each of these interventions one by one. PWA was the first major intervention for us. It provided users with key UX capabilities like offline support, reliability on different networks, which was especially important for us given the markets we were present in, and also better latency. Overall, we saw a conversion lift of around 2.2x, while our user base also rose by 4x. We saw a latency rise of almost 75%. Our product was optimized leaps and bounds, and this was one of the first major breakthroughs which really made us believe in Oyo Mobile Web. With an already optimized product in our hands, we were looking to make it more and more accessible to the end users. This is where the capability of browser installs came into the picture. From browser installs, users were already converting by around 2x as compared to PWA. Having these metrics in sight, we were actually looking to increase its adoption. This is where we started doing a lot of A/B experiments around how to have nudges across user journeys. We started making nudges on home pages and post-booking pages in which we saw adoption increase of around 1.5x, whereas we did not see any drop in PWA conversion. Finally, this May, we released Oyo Lite, which was built on trusted web activity. It was a major breakthrough in the world of Oyo mobile web. Users were starting to get access to Oyo PWA on Play Store, which was really cool. The numbers since have been incredible. We have a similar rating on Oyo Lite as compared to native app. This showcases the importance of core capabilities like low size, easy over-the-air updates, deep linking support, full screen, and a lot of other capabilities. Overall, we were seeing a conversion lift of 3x as compared to PWA. And our conversion was similar to the native app. To summarize, each of these interventions has brought about a good growth in our channel. From M-site to TWA, our conversion has risen by around 6.6x, which is incredible. Mobile web has been the highest growing demand channel for Oyo over the past few months, and we have undoubtedly benefited from all the 3 interventions and got a great ROI out of it. Thank you.
Thanks so much, everyone. Just to invite you to come on by the sandbox. We'll be there most of the day tomorrow. And our Twitter handles are right up here, so do please reach out to us if you have any questions, any feedback, or feel like a good public shaming.
Hello, hello, hello.
Well, well, well.
We have one more slot in our bracket.
We're going to be talking about the final 2 features of the day. We have this last bit.
I'm gonna go first.
You're going to go? Okay. I'm ready
If
to...
my math is correct, there should also only be 2 pieces of paper.
If there's more than 2 pieces of paper in there, we're in real trouble.
There is
We've
not.
really messed up.
Images in clipboard.
Ooh, okay. So, therefore, I can confirm there is 1 piece of paper left in here. And it simply says, prefers.
Where's there? There we go. Prefers for Jake.
Yeah,
So,
do you want
I
to go
guess-
first
Yeah,
then?
I guess that makes sense. I picked first, so I go first. Images in clipboard. It is pretty much what it says on the tin. You are now able to use the async clipboard API to put images into the clipboard, so you can paste them into Photoshop or whatever you use. And of course, also the other way around. You can now read images from the clipboard in case somebody copies. I think on Windows, you still, when you press print screen, the image ends up in the clipboard. Now you can paste it into the web app with this API. And that's it.
Congratulations, okay. Whereas I'm going to talk about something better. This is going to be prefer styles. So this is a couple of features. This is the first one is prefers color scheme, where you can use CSS media queries to react to the user's preference in terms of light mode or dark mode, which is really popular right now. It's so hot right now, right?
You will find the CDS website does support this.
Yes, it does. You're helping me, thank you. You can, of course, query this with JavaScript as well. Just be careful that this returns an object in Safari that's different to the one in Firefox and Chrome. Yeah, some people get caught out by this.
Some people.
And this is the one where I got caught out, actually. So this is another preference, a user preference saying they're not as keen on so much motion. We heard about this in the CSS talk as well. This is where the user said, like, yeah, don't throw stuff around the screen. I maybe have, like, I just don't like it, or I've got, motion makes me sort of ill or whatever. And that means you can listen to that and change how your site works. And this works with JavaScript as well.
Shocker.
Much better feature. Works with, it's about caring for people. The images clipboard thing, meh, whatever. Don't like it.
Fine. Well, let's see if the audience agrees with you or not.
Are you steering?
I am now. This is Climages in Clipboard versus Prefer Styles. Get out your phones. BigWebQuiz.com. This domain will remain the same all throughout today and tomorrow.
Yep.
So, if you haven't bookmarked it yet, what are you even doing? Cast your votes now.
Here we go. Oh,
That's closer than I thought so far.
Yeah, it's not too bad, but that's sort of definite 60-40 split.
I feel like this. I feel you all have this desire to go for round numbers. We always have like a 70-30, 50-50, 60-40, like very clean.
And which normally suggests there's only like 4 or 5 people voting.
Yeah, but we have
definitely not the case.
We have like 300, 400 people casting their votes right now.
Excuse me. Before this
can we
changes?
wait
Like
a little bit longer? I'm driving, right? You're not allowed to press, so I can just wait.
Sit here until
I was gonna wait until I win. Otherwise, we're gonna. All right, fine. I'm gonna see. It's close, man. That
was a lot closer than I was expecting.
I'm shocked. So in this regard, that means that fine, you have won this round, and you will get a point. But that also means.
Hello.
Hello.
Yeah.
I will step back. I will yield the stage.
Thank you.
Because we are now zooming on to the next match.
Ooh.
Which is
the ability to share, something that everybody does. I think it's amazing. I can share into and out of native, images.
Whereas Preferred Styles, like, think how popular dark mode is right now. Like, everyone loves dark mode, and it's the motion thing.
That's the wrong votes. I'm going back. Don't worry.
Do you want me to do it?
Yeah, I can do it.
Yep.
I don't know what my phone is doing. I said to.
I've got it.
That was a lot of drama for not a lot.
I was just trying to
What
win.
was I saying? Sharing, which everybody does, versus preferring a bit of style.
You can't blame a boy for trying. I'm just trying to win at a second attempt.
To be fair, I like the reduced motion part of the prefers, but I also think sharing is a huge capability. It's a deal breaker for some people.
It would prevent motion. It's going to stop people being ill.
Clearly, we can't decide. It's down to you.
Whereas,
what should I vote for?
And dark mode lets you, like, especially now, many of you will be using the app, and it's not going to be burning your retinas because you have dark mode enabled. We've actually done it for the Big Web Quiz app, so, you know, show some respect.
Wow.
Don't know if that's going to go my way. That's a weird tactic, isn't it?
It was.
Oh, well, I don't know. I think we have to call this. Yeah? 3, 2, 1, and the results are in.
But I have to say, again, closer than I thought.
Yeah, that was close. I mean, I could see why either of those would get through.
Yeah.
Hang on a minute. Where does that... Is that me versus you again, Jake?
That is a good question. It is going to be me versus you, but we're not going to do that yet.
No, we're not, but I am very curious about how that one's going to go.
We're going to wait for the next bit to do... yeah, so we're going to, in the meantime, before we do the final and figure out... I keep worrying you're pointing out that like, something went wrong.
No, I'm worried it's going to... Well, I'm not worried, actually. It'd be hilarious if it was me versus me.
That could happen.
Let's do this.
No,
let's find out.
No. That's cheating. That's absolute cheating. Okay, right. Let's get ourselves off the stage.
Yes.
And then we'll do the final after the next talk, and we'll see.
Don't go away after Sam. We will be back, and we need you to make the decision.
Yes. So here to talk about bridging the gap between native apps and web apps. Huge round of applause. It's Sam.
Hey everyone, thanks for sticking with us to the end of the day. The web is an incredibly powerful platform, and with its reach and the installability of PWAs, it's ideal for cross-device software delivery. But it can't do everything that native apps can do. We want to change that. We want the web to do everything that native apps can and be more secure and user-friendly while doing it. My name is Sam Richard, and I'm a developer advocate for Chrome OS, and I'm here to tell you a story of software development on the web and the work Google, Microsoft, Intel, and others are doing to build the future of the platform. This is the story of how we're looking to bridge the native app gap. The story for me starts fall of last year setting up my new computer. I had previously used a combination of native apps and command line tools to optimize images. Then I tried Squoosh.app, a PWA from the Chrome DevRel team. It worked on my Chromebook, it worked on my Mac, it worked on Windows. It was just a website. But with a simple install prompt, it found its way to my app launchers and replacing all of my native tools. To me, it became clear that PWAs should be the future of software delivery. They're built using modern APIs, enhanced to deliver native-like installability, reliability, and capabilities, all while reaching anyone, anywhere, on any device. There are still some gaps, though. The web is super powerful in its own right today. You can build a hyperlocal video chat app with WebRTC, geolocation, and push messaging. You can make that app installable. You can add video effects with Wasm, and you can even bring it into new realities with WebGL and WebVR. But there's still gaps in what we can solve with the web today. In the worst case, this means that developers are not building for the web at all, or they're relegating it to a second-class experience. For those that do want to build for the web but need the capabilities of native, they're forced to bundle web apps in native wrappers. This often results in developers effectively shipping their own custom browsers to users, exploding the size of their web apps and forcing them to take on the security and maintenance burden of both keeping the browser and their native wrapper up to date. These native wrappers also lose the reach of the web, forcing them to choose what devices and operating systems to support, often requiring different native wrappers, all of which further expands the security and maintenance burden. Filling these gaps is the key to fixing this and enabling the web to be the software platform of the future like we believe it to be. What does this future look like? What do you think is missing from the web platform today? What is the web you want? I'm going to tell you two stories of two fictional developers, Quinn, working on Fugu Journal, and Sawyer, working on Fugu Edit. Both Quinn and Sawyer want to solve problems for their users that have usually been outside the scope of what's possible on the web. As you'll see, both will leverage new capabilities that change what's possible to build their applications. We start with Quinn, the lead developer for a social media startup, Fugu Journal. Social apps on mobile devices have been hard because they need to be tightly integrated in order to be loved by their users. Quinn thinks to themselves, our users want to start a journal entry from anywhere on their device, and they want to be able to share those entries to other social accounts. They also want to collaborate on entries with their friends, so they need to be able to invite them to do so easily. Until recently, these capabilities would seem to roll out building a web app. They just simply didn't exist. Both WebShare and the new WebShare Target v2 and Contacts APIs, that calculus has changed, and Quinn can build a progressive web app instead of a native app. Let's see what Quinn is looking to do. After a user navigates to Fugu Journal, they should be able to install it to their home screen. Once installed, they should be able to find media, images, video, and audio from throughout their phone and share it to Fugu Journal. Users should then be able to share any entry using the native share sheet of their phone to another application. Finally, they should be able to find contacts from their phone to invite them to collaborate, sending off invitations once they've verified their contacts' information. Diving into how Quinn can make this work, let's start by looking at WebShare Target v2. This allows installed PWAs to both register as a shared target and describe what can be shared to it. To add it to Fugu Journal, Quinn needs to update the web app manifest to include a shared target. You can only have one shared target per web app manifest, and there are three parameters. Action, which is the URL to open when shared to. This should be pre-cached when your service worker is installed so that it's always available. Method, which determines how to share your items to your PWA. If you want to use post instead of get, you need an ENC type parameter as well for encoding. And then params, which is what is allowed to be shared and what those items should be called. Each of the parameters inside of params is optional. You can have title, you can have text, you can have URL, and you can even have an array of files, each with their own MIME type and a different name for those MIME types. When shared, the data is sent to the action URL as form data that can then be parsed and used as needed. A neat trick you can do for share target is to register a route directly in your service worker to handle the request. This will let you use it even without a backend. Here, we're importing Workbox's route register and registering our service or our share target as a route, a post route, calling share target handler function, which looks like this. The share target handler is an async function that takes in the event, then awaits the form data and peels off the media files from that. You can then do whatever you'd like with these files. You can cache them, you can send them somewhere with a fetch request. You can even make use of the rest of the options, maybe serving a page with some query parameters, for the other shared items, or storing the data and pointers to the media in indexed DB. Once the journal entry is in Fugu Journal, Quinn's users need to be able to share it back out. To do so, when the share button is clicked, Quinn checks to see if navigator.share is available. If so, it'll use the native share sheet. If not, we can fall back to custom sharing options. To activate the native share sheet, Quinn calls navigator.share, a promise, and passes it at least one of the optional parameters. Title, which is the title of the item being shared. Text, which is the text to be shared. The URL that is being shared, and note, this doesn't need to be the URL that you're currently on. It can be any URL. And then an array of files to be shared out as well. With both WebShare and WebShare Target in place, Quinn is ready to test sharing to Fugu Journal. They start by finding a file to create an entry from. Opening the file, they tap on the kebab menu, hit send, find Fugu Journal in the share sheet, and then tap it. This opens the image in Fugu Journal, posted and ready to go. They then click the share button from an entry, and hey look, Android's native share sheet pops up, ready to share. Twitter's PWA has also implemented WebShare and WebShare Target v2, so Quinn can share their entry over to Twitter. With a tap, Quinn's brought over to the Twitter PWA, and their post is ready to be tweeted out. Quinn now turns their attention to the contact picker. Contact picker is also a promise, so we're going to wrap it in an async function. When the function is run, Quinn checks for support by making sure both navigator.contacts and window.contacts-manager exists. If not, the user will get redirected to a manual contact entry form. If it does, then the contact picker will be launched. The picker takes two parameters: props, which is an array containing the properties to be requested, and options, which is an object specifying if multiple contacts can be selected. The results are an array. It's either empty if no contacts were selected or the contact picker couldn't be launched. Otherwise, it's full of contacts. Quinn then takes those results and passes it to a function to populate the invite form. Quinn gives the new contact picker a test run. Navigating to the invite screen, Quinn clicks the Invite Friends button and is presented with a contact picker. Now, there's been lots of thought around user security put into this contact picker. Apps aren't granted permanent access. It's on demand. Users also aren't required to provide all of the information requested. They choose what's returned from the request. Quinn decides to select a few contacts, but only share their name and email address. Once selected, the contacts now show up in Fugu Journal, and with that, Quinn can invite their friends to come try their newly launched site. And so can you. Go try it yourself. On your Android device, go to fugujournal.web.app, add it to your home screen, and try out everything you've seen, inviting friends, adding content, then sharing it out. While the Contacts API isn't fully launched yet, I've enabled an origin trial on Fugu Journal so you can see how it works without a special version of Chrome or toggling any Chrome flags. As a demo site, it's not hooked up to any backend, so no information will be collected, and all files shared are stored locally. We now move from Quinn to Sawyer. Sawyer is developing a new desktop class web editor, FuguEdit, and heard you like websites, so wants to build you a website to let you build websites. Sawyer has similar concerns that Quinn had. Editors are hard to build, and they really need to be seamlessly integrated into an operating system to feel useful. Sawyer thinks, editors are complicated. Our users want to be able to pick a file or folder to work on and just work on it. Users get attached to their favorite editors, so they'll want to be able to quickly open files from their home screen or their file system in the editor. These requirements, much like Quinn's, used to be impossible with a web app. Previously on the web, in order to edit files or folders, first you needed to upload them, then make your edits, then download those files again. You couldn't just change them in place. It was pretty cumbersome. And opening a file from the file system into an app, simple for native apps, previously impossible for web apps. Just like Quinn, Sawyer is going to turn to new APIs. This time, it's the native file system API and the file handler API. Let's see what Sawyer is looking to do. Navigating to FuguEdit on their laptop, a user sees a notification in the Omnibar that they can install it. Clicking it, they install FuguEdit and it's now available alongside all of their other applications on their computer. Once installed, they find a file on their computer and open it directly into Fugu Edit. They can then make changes to that file using Fugu Edit, save those changes, and then confirm that those changes are real by looking in the terminal. Finally, they can open a whole folder's worth of files in Fugu Edit, opening individual files from the file tree as they need to work on them. Sawyer is going to start with opening a file from the file system. The native file picker is a promise, so we're going to use async when the open button is clicked, or an async function. First thing Sawyer does is check to see if choose file system entries is available. If not, it'll fall back to other file picker options. If available, Sawyer is going to call choose file system entries. One option is included here, accepts, which here will narrow down what kinds of files can be selected by MIME type. We can also choose to allow multiple files, open directories instead of files, or create new files instead of opening a file that already exists. Selecting the file is step one. It provides basic information, the file's name, whether it's a directory, and whether it's a file. Calling getFile lets Sawyer know when it was last modified, its size, and its MIME type. Finally, in this case, calling .text is the final step, and it will read the stream of the file as a UTF-8 encoded text, kind of like how Fetch's text method does. If users open a file, they need to be able to save it as well. Sawyer is going to make this feel more native, so they're going to overwrite Control or Command S to save the file instead of saving the web page. This will kick off writing a file to disk. To write a file, Sawyer first creates a writer from the file handler. This creates a temporary file. Then they write the context to the temp file, starting at the 0th character and including all of the content. Finally, they close the temp file, which updates the original file on disk. Loading up Fugu Editor on a Chromebook, Sawyer's got two options: open a file or open a folder. Open a file feels very much like the file upload form that they're already used to, and once opened, it pops in. Opening a folder, however, is a different story. Sawyer selects a folder from their Linux environment on their Chromebook and sees a notification warning them that they're about to grant access to a site to view all files in that folder until they close the tab. This is a double opt-in because, much like the contact picker, this API was designed with security in mind. With the folder open, Fugu Edit's adapted to include a folder tree of all the files and folders in that directory. Sawyer can now move around the folder tree, opening files as they go. Sawyer opens the README file and makes some edits. This was edited from a PWA. Sawyer then hits Control-S to save the file. They get a notification telling them that if they agree, Fugu Edit's going to have write access to this file until the tab's closed. Again, an async block to ensure the user doesn't accidentally give permission to this functionality. After saving once, Sawyer checks to see that the changes have stuck by catting the file in their terminal. The file's changed. Great. Going back to Fugu Edit, Sawyer makes some more changes, presses Control-S again, and then checks again to see that the changes have stuck. Now that they're ready to use Fugu Edit to edit Fugu Edit itself. Just one more thing to do: opening files from the file system. Doing so is similar to what Quinn did with Web Share Target. Sawyer needs to update their web app manifest. The first thing they need to do is they need to add a file handler option to the web app manifest. This allows Sawyer to specify the URL, which should be used when opening a given file type. Sawyer can specify multiple file handlers here. One URL can accept multiple file types, and for OSs that work with MIME types, those will be used. Otherwise, it'll fall back to specific extensions. This also means you can use custom extensions with your PWA. The final thing that Sawyer needs to do to get the file opened is actually get it. To do that, on load, they set a consumer for the new launch queue. The launch parameters in the consumer include an array of files that are being launched with. They pick off the first file, and await opening it in Fugu Edit. Loading up Fugu Edit on their Chromebook, we go to the Files app, find a file in our Linux environment that Fugu Edit can work with, and open it with Fugu Edit. Ta-da! Opened and ready to work with. And again, you can try this out yourself. On your computer, go to fuguedit.web.app, install it, and try to open the files and folders and save them as you normally would. Native File System API is also not fully launched yet, but just like the Contacts API, I've enabled an origin trial so you can see how it works without a special version of Chrome or toggling any flags. File handling isn't available as an origin trial yet, so you need to open it up in Chrome on either a Chromebook, a Linux, or a Windows computer. Go to chrome://flags and enable the file handling API. Support is coming for Macs, and implementation on other operating systems is still kind of ongoing, so you'll likely run into some bugs while we finish our initial implementation. If you want to see the source code for both of these apps, check out the Bridging the Native App Gap repo on github.com/ChromeOS. One word. While Quinn and Sawyer may be a glimpse of what's possible in the future, teams are starting to use these new capabilities today. But to do so, they need to be confident that they can use these APIs securely. These APIs that we're exposing are really powerful, which can be really scary, and a lot of thinking has gone into ensuring that going to a website continues to be a safe proposition. They're all being designed with a user-first permission model, where all permissions are clearly defined and easily revocable. In fact, security and privacy is so important that if a capability can't be made private, safe, and secure, it won't be exposed. They're also being developed as part of an open standardization process. Tomorrow morning, there's a whole talk on this intent to explain demystifying the Blink shipping process that you should watch to learn more about that. All the APIs I've talked about are in the stage where they're publicized, and we're actively looking for feedback to iterate on them. Or we're looking for public support and for you to try it out today using an origin trial or the latest stable Chrome release. So, with these APIs in the wild, who's actually using them? GoIBibo is a leading online travel booking brand in India. While most users book for themselves, 15% of their bookings are for other people. They've recently implemented the Contact Picker API to allow users to choose someone they'd like to book travel for, smoothing out that process. They're also looking into other ways of incorporating the Contact Picker API, including sending referral links and codes over SMS and incorporating GoCash Plus, their system for rewarding users when contacts they have synced make a booking. Google Earth Studio is a browser-based animation tool for Google's 3D and satellite imagery. It allows users to program their camera's flight path and then render that animation as an image sequence. It used to rely on the old Chrome file system API to store files during render. This required generating a zip of sometimes gigabytes of images that was then downloaded to the downloads folder. This posed significant limitations on the length and size of animations they could make. It also caused confusion and frustration for their users. They couldn't find the generated files, they couldn't save to an external hard drive, and they would get out-of-space errors when lots of space was available. The native file system API solved these problems. When users start, they choose the folder to save the file to, and accepting the prompt to allow the site to view files in that selected folder. Notice how the folder, the file, just has the file we started with, nothing else. Once a user starts a render, they're prompted to allow Google Earth Studio to write to that folder. When allowed, Earth Studio creates a working directory it will put the rendered images in, as well as make a copy of the camera's flight path. When the images start to render, they're put in a new folder named Footage that is easy for users to find and keep track of. By directly choosing the output folder to render to, there's no zipping, no confusion as to where the files are, and all of the user's disk space is utilized. In short, it's a dream come true for the Earth Studio team and their users. Finally, I want to talk about AVR Girl. AVR Girl is an open source project that talks to the Arduino bootloader and writes a program from the computer's hard drive to its memory. It's written by Suze Hinton, aka NoOpCat, an open source embedded developer. Suze does a lot of code streaming, and at the end of September, showed off something super cool that she'd be working on for AVR Girl. By leveraging another one of these new capabilities we've been working on, the Web Serial API, Suze was able to program her Arduino Uno to blink straight from her browser. Let's watch.
So this is the Upload-O-Matic. What it does is it takes pre-compiled code for an Arduino board, and it's able to use web serial in order to upload that. So I have some pre-compiled code that I'm going to try this out with. I have an Arduino just above me and that you can watch. So I'm going to pick my Arduino Uno board. I have some files here. Let's go with Blink so that we can actually see that the code did upload, and then we should see a light blinking when that's done. I'm going to click Upload, which allows me to give permission to access my serial device, which is my Arduino here. And as soon as I click Connect, that's going to start uploading. And there you have it. The light is now blinking. And as that was being written, it was dumping out all of the pages of memory that it was actually writing to the device as well, which is pretty cool.
I agree. It is pretty cool. So, what's new and what's next? What Twitter, Google Earth, GoIBibo, and AVR Girl have been able to do with these new capabilities already is pretty impressive. But now it's your turn. What new capabilities can you add to your web apps today? What can you experiment with? What is in development? And what does the future hold? So, things that have already shipped. As of Chrome 79, we've got WebShare, WebShare Target v2, the Shape Detection API, which is for barcodes, face, and text detection. And we've got Get Installed Related Apps for web apps that have established a connection to a native app through something like a digital asset link. They'll be able to query if that related app is already installed. There are also a bunch of stuff in Origin Trial. So things we've talked about already: native file system, contact picker, file handlers, and web serial. We're also going to have a badging API for app icon badges, as well as wake lock to prevent the screen from going to sleep, an SMS receiver to enable SMS one-time password flows, periodic background sync to run a service worker at designated intervals while online, for instance, to update the status or content in a background, Web HID, or human interface devices, great for getting the most functionality possible out of things like gaming controllers, notification triggers, which are notifications based on events, like timers or location, instead of push events, and then back pressure for WebSockets to improve handling for large amounts of data over WebSockets. What are things that are in development? Well, font enumeration to get a list of local system fonts, font table access to allow true type and open type table access for fonts to allow custom font rendering, raw clipboard access to extend async clipboard to allow unrestricted access, and two that I'm really looking forward to, screen enumeration and window placement. Screen enumeration makes applications perform well across multiple displays with different properties, like presentation apps or financial dashboards. And then Windows placement allows you to create, manipulate, and enumerate windows for an application, including moving windows as a group and moving windows to specific screens. Finally, what's coming in the future? So we're looking into things like service worker launch events, which control where links open, if they open a PWA, a tab, or a window, a low-level audio API, user idle detection, a tabbed application mode for PWAs, native sockets, scheduled tasks, and being able to control connected cameras. If you want to keep up to date with all the work that we're doing, go to goo.goal/Fugu API tracker. It's a really fun URL to say out loud. The status of each of the APIs we're being worked on or considered is there, where the API is targeted for, mobile, desktop, or both, and links to the implementation tickets for each capability. We also need to try these APIs out and give us feedback. If you want to explore more, come find us over in the sandbox area, where we've got a booth dedicated to these new capabilities, including code labs for you to try out yourselves. I will also be over at the Chrome OS booth. You should also sign up for Origin trials, so you can try these out with your real users. Origin trials give you the ability to try out experimental APIs with real users of your site without needing them to change their Chrome version or toggle any flags for a limited period of time. Features in Origin trial have what's called a 1 week of guaranteed breakage. This means that you're guaranteed to have a feature not work for a week before the feature becomes stable. as origin trials aren't meant to be early launch mechanisms. Finally, origin trials, you can also give us direct feedback on their implementation and your usage of these features. Setting up an origin trial can be done in 4 steps. Step 1, choose your origin trial. Step 2, register your domain for that origin trial. Step 3, get the token for your origin trial. And step 4, add a meta tag for your origin trial with that key that you got. With that, you can try out the feature you'd like with your real users and provide us with feedback. Finally, what's missing? All of these APIs we're developing because we're being asked for them. Participating in origin trials and giving feedback there is a great way to help us shape APIs that we've started working on, but we want to know what you need before we get to that stage. Let us know what you need. Go to webwewant.fyi to let us know what you'd like to see added to the web platform to help you bridge the native app gap. Thank you.
All right, everyone. I'm glad you're still here because we have an important moment in history to decide.
I'm really nervous,
Put a moment in history.
I'm so excited. So before we start, I thought we would take a look at, because it's one thing to win the final, it's another thing to actually get the most points.
Oh, and we have two rounds left to do.
We have a semifinal and the final. So before we go into that, I mean, we could look at the bracket, right? Like, this is where we're at. We have to find the opponent for Intel and then decide if that one is better than Intel itself.
Right, and so it could be me versus Paul in the final.
Or Paul versus Paul.
Oh yeah.
Yeah.
That would be boring. Wouldn't that be boring?
No, that would be amazing.
Looking at the points, Paul is already ahead.
Yes, but it's 3 points for the semi-final.
So if Jake won the semi-final, he would tie up with Paul to 9 points, making the semi-final even more juicy.
Sure, but Paul versus Paul. I mean, that's just ridiculous.
Let's be real.
I mean, that's not what you planned for today.
We already have enough Pauls in WebDevRel.
I know, but it's so good.
Okay.
Look, all right, let's not waste any time. Get out your phones.
Well, should we zoom into the appropriate part of the bracket?
No.
Okay.
All right, sure. We are doing the semi-final.
Look, I mean, all due respect to you, Jake. Background fetch.
Go on, pitch.
Really
pitch a
good.
bit.
Really good.
Thank you.
But sharing is what the web is in so many ways. It's like that ability to go, this is the URL. Poof, there you go. Into native land, out of native land. Like, this is the thing that people have said time and time again. I want to bridge that gap.
So why do you need an API?
Effortless.
The web can already share. Why do
It's
you need...
amazing, though, to be able to do it in and out of these native apps.
And once you've shared like a series of images or something into your app, you then need something to send those to the server in a reliable way, and that is where background fetch comes into it.
Sure.
And also, I would say
there are more apps that need to share things than need to do background fetching.
I've got a really
I'm cutting this off.
Well,
you have talked long enough.
Okay. I've got skin in the game here because, as I say, I did the spec and the feature design for background fetch. It was entirely luck that I picked it up.
I thought if you
work did you do on the
because
sharing?
I share things.
If you
Are
think
you one
this
of
is
the
for the
spec editors?
stage,
I am.
literally in the office, this is the kind of conversation they have.
Really? Backstage, it's been heated.
Yeah.
So you get to decide. Is it Paul versus Paul? Is it Paul versus Jake? Is the final going to be meaningful or is it going to be meaningless?
It'd be amazing. It's going to be amazing.
Cast your votes now.
So I would say, if you want things like Netflix to work on the web offline or YouTube, those are big files. The only way you are going to get those onto your device.
Granted, but you want
like
to
background
share things.
Netflix doesn't let you share.
So I would say, Squoosh you can already paste images into because some of this landed in the web years ago.
Pretty clear to me.
So it's not an entirely new feature. It's only new
Once
that
again,
it's async.
the room is going for a clean 2/3.
I think
you really are engineers. You like the nice numbers.
Yeah.
Oh, and then you broke it. Oh, well.
Well, that means the final is, wait, it's me and you again.
It is me and you. I'm really, really nervous.
Right, look, okay, granted. So we know background fetch, you just made your big case for that, but
Yes.
Intel. All right, look. I mean, I know it looks like a little thing, but it's a little big thing. I was chatting to some developers outside, and they were telling me, so many people are telling me, you know what, I'm so glad, having solved this problem time and time and time again, I don't have to solve this anymore because Intel does it for me.
I'm going to do dirty tricks again and say, with the Intel stuff, with the time thing, although you can get it to say like 5 seconds or 5 hours, the API does not let you do 1 hour and 5 minutes.
But
it doesn't let you split it up like that, so you only get one or the other, which I think there's still work to do on this feature. It is incomplete.
Your thing takes about 3 weeks to write, and you have to do something with the files that come down.
Oh yeah, your thing have to write service.
Let's find out what they think.
Yes, let's.
All right, you've seen and heard enough of these features for a day. You all know what it's about. You all know what's at stake. So it's time for you to resolve us from the suffering, to figure out
I really want Intel
who's
here.
going to be smug for the rest of the day. Who will have to wear this awful shirt that Mariko designed, by the way.
Let's do this.
Absolutely.
Make your decision now.
You fat fingered the button again. Summer, will you press? Right.
I can't deal with this kind of pressure.
By the way, if no one votes, that's what happens, just in case that encourages you.
No vote is not a number.
All right.
Oh my word.
This is the final everyone wanted to see.
It's amazing.
You don't get to close
I don't.
Mariko does, because I can press buttons, apparently.
What's up? What's up?
You hold it, you decide when we close.
How do I close
So
this?
difficult to choose. These are both huge features.
Oh, it's currently...
What? So yeah, if anyone wants to change their minds, now is the time to do it, although I would encourage you to not. Unless it's more votes for background effects.
This is incredible. I'm so happy about this.
Absolutely incredible.
But I think
Are
we
you
have
ready?
settled. We have settled on a
Are
result.
you ready?
It's creeping, it's creeping, it's creeping.
I'm gonna close it. 3, 2, 1.
Have you? Well done.
Well done.
Well done, well played.
And so I would say, like, I'm chuffed to bits, but that's I don't know if that phrase travels. I'm really happy.
Yes.
But the final there is not what any of us expected, right?
It is really not.
No.
Like, we thought it was
I
gonna come
thought
down.
class fields it's going to win.
I thought image lazy loading.
I think we were
yeah,
all certain
yeah.
that was going to be the final.
Yes.
And it's completely not. And I think it's fair to say, like, the two of you got lumbered with some real bad features.
Are you saying that this score is not representative?
No. Oh, and I get to hand you your T-shirts for tomorrow. This is the. I shall try and show it to everyone. This is it. This is the "I'm a failure at life" T-shirt.
But on the back.
And because internationalization was in the final,
we've got it in German and in Japanese on the back.
And how do you say that in German, please, Soma?
Ich bin ein Lebensversagensexperte. I'm basically just compound nouns as a service. That's my job. Compound nouns as a service.
Thank you. And how is it said in Japanese?
It says in Dame Ningen on the back. Literally the failure person.
The failure person.
I feel terrible about this now.
Do you?
Do you
No,
really?
you really do not.
Yes and no.
You
Not
really
bad
do
enough
not.
to
Actually, I'm enjoying this one.
So, with that, we have concluded the big web quiz for today.
Hey.
We're going to have a new incarnation for tomorrow.
Yes, where we are going to be talking about not features that landed in Chrome in the past year, but features that are on the horizon, like things that might be out next year or in the next few months.
Some of them really close future, like, it's already all these intro. Some of them just an idea. So tomorrow, that's bear in mind.
Leading edge.
And we have been told that the people who are, like the project managers, are actually going to use this as a scientific data point for priority. I thought that was funny as well, but they took it seriously.
You get to decide who keeps their job.
Yeah. Oh.
I mean, sure.
So with that, I guess all that remains to say is, like, thank you very much for joining us today. I hope you join us all tomorrow, especially on the live stream as well. We're going to have another day of like exclusive content there as well. For people who are here, we're going to have like a drinks reception that is going to be in the Sandbox and Code Labs forum, a bit of the building, and we look forward to chatting to you there. Thank you very much for joining us.
Have a good evening.
Thank you.